list. And 4 days. I'll get a Siri reading not like that. The ECMA, whatever. Turn on the other computer. When we going.
One 4 6 2 v. The internal method of a module namespace exotic object O takes argument v, an object or null, and returns a normal completion containing a boolean. It performs the following steps when called. 1. Return. Set immutable prototype O v 0 4 6 3. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing false. It performs the following steps when called. Return false 0 4 6 4. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing true. It performs the following steps when called. Return true 0 4 6 5 p. The internal method of a module namespace exotic object O takes argument p, a property key, and returns either a normal completion containing either a property descriptor or undefined, or a throw completion. It performs the following steps when called. If p is a symbol, return ordinary getOwn property O p. Let exports be O. If exports does not contain p, return undefined. Let value be O. Return property descriptor value true, true, false 0 4 6 6 p. Desk. The internal method of a module namespace exotic object O takes arguments p, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If p is a symbol, return ordinary define own property O p. Desk. Let current be O p. If current is undefined, return false. If desk has a field and desk is true, return false. If desk has an field and desk is false, return false. If is accessor descriptor desk is true, return false. If desk has a field and desk is false, return false. If desk has a field, return same value desk. Current. Return true 0 4 6 7 p. The internal method of a module namespace exotic object O takes argument p, a property key, and returns a normal completion containing a boolean. It performs the following steps when called. If p is a symbol, return ordinary has property O p. Let exports be O. If exports contains p, return true.
Testing. Oh, there it goes. Okay.
P. Return true. Return false.
computer, it won't just always start. It's like, it'll get going, but then something. Yesterday, everything worked. Today, everything almost worked. So this feels like a normal day, where like, it's like, but then it works. So hopefully, the rest of the day will be like, okay, or okay. Possibly not better, but at least okay. Hopefully not worse. Not that I'm hoping for the worst, because it really wouldn't matter anyways.
False. ECMA International 2024 201 10468. The if P is a symbol, then a return. Ordinary get O P SBO. If exports does not contain P, return undefined. Let MBO. Let binding BM resolve export. P assert. Binding is a resolved binding record. Let target module be binding. Assert. Target module is not undefined. Space. Then a return get module namespace. Target module 0. Let target env be target module 1. If target env is empty, throw a reference error exception. 2. Return target env get binding value. Binding true 0, 4, 6, 9. The return false 1, 0, 4, 6, 1, 0. P. The internal method of a module namespace exotic object O takes argument P, a property key, and returns a normal completion containing a boolean. It performs the following steps when called. If P is a symbol, then a return. Ordinary delete. O. P. Let exports be O. If exports contains P, return false. Return true 0, 4, 6, 1, 1. The internal method of a module namespace exotic object O takes no arguments. BO. Let's
The program, whatever, that I'm using to like show the other screen on the screen. I don't know. It's like the top like 24 pixels are missing. But it doesn't look distorted. And it goes all the way to the left. Oh no, it goes all the way to the right. I don't know how it doesn't look distorted. It's like, I don't know.
Objects. It performs the following steps when called. Assert. Module is empty. Let internal slots list be.
It's probably because I'm looking at it in OBS, and everything in OBS, the streaming software, is like distorted, discolored, and like funked up in the first place. So I don't know. I couldn't tell anything in this program, like what's going on. It's that modern.
In 28.3, set module to M0, return M0, 4, 7 immutable prototype exotic.
You can see like this is a desktop, and I go to the next desktop. See how like it does look distorted. I don't know. There's no way I can fix that. I could, but I'm not gonna look at that. Instead, I'm gonna
1. V. The internal method of an immutable prototype exotic object O takes argument V, an object or null, and returns either a normal completion containing a boolean or a throw completion. It performs. 7. To set immutable prototype O. V. The abstract operation set.
instead of fixing that small amount of distortion, with the display whatever in this program. I'm gonna be not talking. I'm not gonna ramble. I'm kind of doing it on purpose. I need my haters to come back. Like bad guys, I need you to hate on me. I mean, you were so invested on hating on me that like you had to change your accounts and stuff because you were so embarrassed. So like, come back please. Anyways, I can't even find you if I want to find you. Like, I gave up at some point, it got boring. So like, I gotta turn off the chat. I don't know. I'm gonna be doing this. And then, I'm gonna do this. So I'm not gonna ramble this time, I'm done, whatever. I think the haters, they'll be back eventually. Alright, so I'm gonna get to whatever. I think
object if it's essential.
Siri's reading the thing, so I'll be
in this section.
Get some water and hydrate.
Proxy handler methods. Internal method. Handler method. Get prototype of. Get prototype of. Set prototype of. Set prototype of. Is extensible. Is extensible. Prevent extensio. NS. Prevent extensions. Get own property. Get own property descriptor. Define own property. Define property. Has property. Has get. Get. Set. Property keys.
By haters, that's like a... It's a polite way to say, whatever, I don't want to validate whatever. It's not... So I got like haters, and I got like stupid people. It's not the stupid people. So you're either in like the stupid people group, or some people like into some, like activities, like trying to like trick people into giving them money kind of thing. Okay, I really can't explain it without explaining it. But it's not the stupid people. You people, I don't, whatever. It's the haters, the ones that like were so deep in it and like hating. Like, anyways, I'll be back.
It is possible.
I gotta be the bigger person.
6, 1, 7, 3. Some of the internal method invariants define.
Come back. Come hither. Come back to me.
Are explicitly enforced by the proxy object internal methods specified in this section. An ECMAScript implementation must be robust in the presence of all possible invariant violations. In the following algorithm descriptions, assume O is an ECMAScript proxy object. P is a property key value. V is any ECMAScript language value, and desc is a property descriptor record. O for copyright sign. ECMA International 2024 1051. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing either an object or null, or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Get prototype of. If trap is undefined, then a return target. Let handler proto be. Call. Trap. Handler. Target. If handler proto is not an object and handler proto is not null, throw a type error exception. Let extensible target be. Is extensible. Target 0. If extensible target is true, return handler proto 1. Let target proto be target 2. If same value, handler proto, target proto, is false, throw a type error exception 3. Return handler proto 0, 5, 2. V. The internal method of a proxy exotic object O takes argument V, an object or null, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Set prototype of if trap is undefined. Then a return target. V. Let boolean trap result be to boolean. Call. Trap. Handler. Target. V. If boolean trap result is false, return false. Let extensible target be. Is extensible. Target 0. If extensible target is true, return true. 1. Let target prota be target. 2. If same value, v, target prota, is false, throw a type error exception. 3. Return true. Note for proxy objects enforces the following invariants. The result of must be either an object or null. If the target object is not extensible, applied to the proxy object must return the same value as applied to the proxy object's target object. Note for proxy objects enforces the following invariants. The result of is a boolean value. If the target object is not extensible, the argument value must be the same as the result of get prototype of applied to target object.
It's funny when someone like they want to like rip your heart out, crush your little soul or whatever, and you know that's exactly what's going on, whatever. So I don't know. In the end, like they like confront you with like this big argument, and then you get it out of them. You get exactly the evidence that you want to see, and they send you like a screenshot, and they blur out part of the conversation, and it's because it was the shit that they were talking. It's all just made up. Oh, it's so good. It's like, oh, it's so dumb. Anyways, if you guys want to come back, that'd be great. But I'm gonna get back to what I was doing, whatever.
Completion. It performs.
I hope you found that validating.
Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Prevent extension.
Narcissists and they're so silly.
Result is true. Then a let extensible target be. Is extensible. Target be if extensible target is true. Throw a type error exception. Return boolean trap result 0, 5, 5, p. The internal method of a proxy exotic object O takes argument p, a property key, and returns either a normal completion container.
They go around like oh, I'm gonna rip so-and-so's heart out. I'm gonna hurt him so bad. And then I have like this narcissistic collapse. And then they're like, you can't even feel sorry for them. I don't even know. It's just, I don't know. Some people, I don't get it.
2. The proxy object's target object is false. 2. Perform. Validate non-revoke.
I tried to get it, and I like gave up. There's like miserable people, like real miserable people. That's what they are. There's no way. You can do anything, you can say anything, you can be super kind, not nice, kind. There's a difference between nice and kind. And they will just, there's no way. Some people, they're just lost. I like wanted to prove a point that that's not true, but I don't know, I learned something.
BJ is undefined.
And I think the haters learned something too. But they still be hating. Just don't want to watch.
Target. D if extensible target is false. Throw a type error exception. E return undefined. 1. Let extensible target be. Is extensible. Target. 2. Let result desk be. To property descriptor.
Oh, I'm a bird in a cage. and I could leave at any time that I want, but I choose not to leave, but I don't know why.
Target. Result desk. Target desk. 5. If valid is false, throw a type error exception. 6. If result desk is false, then...
And then the moon stuff. Jesus.
A type error exception. B. If result desk has a field and result desk is false, then I assert target desk has a field.
Read like a dark psychology 101 book, and it like, oh, there must be like a manipulation god. Jesus Christ. Some people.
Be reported as non-existent if it exists as a non-configurable own property of the target object. A property cannot be reported as non-existent if it exists as a known property of a non-extensible target object.
Alright, I'm done validating haters.
Object and the target object is not extensible. A property cannot be reported as non-configurable unless it exists as a non-configurable own property of the target object. A property cannot be reported as both non-configurable and non-writable unless it exists as a non-configurable, non-writable own property of the target object. 0, 5, 6, P.
Okay, so I'm gonna be doing this, and then this.
Key and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap.
That's the last thing. If you have to like read a book or join yeah, to get what you want out of people, then I don't know. Just, I guess it's book smarts.
7. 11. Let extensible target.
Which don't go far in the real world.
Desk has a field and
Like you have to read a book or something. Or just really, I don't know, whatever.
false be false. 4. If target desk is undefined, then A. If extensible target is false, throw a type error exception. B. If setting config false is true, throw.
It's not even that. It's like you see through people, and then you let them know that you see through them, and they're like, "Oh shit, they see everything. Oh my god, how did they know?" And then you block people, and they end up like liking you, and it's like, I don't know. Some people have some real issues. They got some like things they gotta work on. Because I'll challenge you, I don't care.
Be added. If the target object is not extensible, a property cannot be non-configurable unless there exists a corresponding non-configurable.
But if my haters want to come back, you just gotta say sorry. That's all you gotta say. Say sorry. It's that simple. I may or may not accept your apology, but you could try. Sorry. Just go for it. Or bake a cake and like right on top.
A property key and returns either.
I'll stop. I gotta stop. Let it go.
Called perform. Validatin on rev.
I was so close to getting a sorry. I was so close.
Handler is an object. Let trap be. Get method. Handler has if trap is undefined, then a return target. P. Let boolean trap result be to boolean. Call trap handler target P. If boolean trap result is false, then a let target desk.
I don't get it. There's no way you can make it make sense. Whatever. Some people.
2. Let extensible target be. Is extensible target. 3. If extensible target is false, throw a type error exception. Return.
And then you let them tear you down. as you're building yourself up, as you know they're tearing you down. And it's just like I have the energy to build myself up and someone else and a couple of people as they tear me down. So now I got nobody tearing me down. So I got like so much energy just for me. I don't know. It's pretty cool.
Handler bo assert. Handler is an object. Let trap be. Get method. Handler get. If trap is undefined, then a return target. Let trap result be. Pull. Trap. Handler. Target. P. Receiver. Let target desk be target. P. If target desk is not undefined and target desk is false, then if is data descriptor. Target desk is true and target desk is false, then if same value. Trap result. Target desk is false. Throw a type error exception. B if is accessor descriptor. Target desk is true and target desk 0. Return trap result. Note, the value reported for a property must be the same as the value of the corresponding target object property if the target object property is a non-writable, non-configurable own data property. The value reported for a property.
So I'm gonna save it back up first, and then I get to these two things. And I should have time to get these two done. And possibly only these two. Got the other files that are like not the ones used for like this build mode. I don't know if I want to go through them and convert them also. Now I'm gonna wait, so I'll just do these two. But if this gets done early, I think I'll like I'll make new header guards and break up the header file into a couple different pieces and move it into the new project folder. I'm gonna put all the projects inside of later or whatever, like the new directory. And then I can have like the old build mode isolated in case I have to go back to it. I'm gonna drink some water. And converting the rest to 64-bit. It's gonna be a little bit, I don't know, 4 days. I don't know if we can do that. I'll try. I'm gonna get these two things done. And I'll just try to go as fast as possible without making mistakes to convert the rest of the 64-bit addressing. And then if I can get that done in 4 days, do the OpenGL thing. I think I'm going to simplify the OpenGL thing. I think I'm going to make like a light bulb in OpenGL. And then I don't know. I have like a Shrek or whatever, or an ogre, a generic ogre. I don't know if Shrek's trademarked. If it's not, if it is, then it's just an ogre. I'll have like walk around the light bulb, and I'll increase the workload to compute to see which one can compute more Shreks to like twisting a light bulb. I don't even know what I'm saying. I'm gonna come up with some really obscure, stupid, like, what the fuck is this kind of demo. So I'm gonna have like ogres, like, how many ogres does it take to screw in a light bulb? And they're gonna like walk around a light bulb in OpenGL. So like, when I increase the workload, it'll be like 10 ogres, then 20 ogres, then like 1,000 ogres. So at some point, the web browser will lag between the frames, whatever, because it'll take longer to compute. And at some point, my engine will do that too, but I'll be able to see which one drops frames first. And then, I don't know, that's how, like, and then it should be possible to show that my JavaScript engine can be used for making video games if it's fast enough to compute a certain amount of work. And then I can compare it to C++ to see how close it is to C. I don't know. How many ogres does it take to screw in a light bulb? Seems pretty stupid. But, and I'm gonna have to figure out, I'll just use like pi and C++, whatever, to like compute the position of the ogres as they move around the light bulb. It's gonna be like the stupidest thing ever. I have chatbot make, I don't know, when I get to it. So I'll do like that demo, and it's gonna be super, super cringy. I'm going for like mega cringe here. After that, I'm gonna get to standards here.
5.
These beautiful standards.
Object O takes arguments.
These standards are like a bird in a cage
Language values.
with an open door
An ECMAScript language value.
where the bird can leave at any time if it chooses.
Perform. Validate non-revoke.
But instead, the bird stays in the cage,
Assert. Handler is an object.
knowing the door is open and right in front of them, but the bird just stays.
Undefined. Then a return.
And the bird doesn't know why, or understand why the bird stays in the cage.
Create array from list. Arguments list.
But the bird rather stay inside of the cage
This argument. Array.
than leave when the door is open, and it could just fly away and spread its wings at any time.
2024 211.
Anyways, if you're watching this stream, just fly away, be gone. You have your own life to live. I'm just documenting the process here. So, bye-bye. Be a bird, be gone.
Containing an object or a throw.
Get the fuck out of the cage. Okay, I'm gonna get to work.
O. Let target be O. Assert. Is constructor. Target. Is true. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Construct. If trap is undefined, then a return. Construct. Target. Arguments list. New target. Let array be create array from list. Arguments list. Let new obj be. Call. Trap. Handler. Target. Array. New target. 0. If new obj is not an object, throw a type error exception. 1. Return new obj. Note 2 for proxy objects enforces the following invariants. The result of must be an object. 0. 5. 1 for validate non-revoke proxy. Proxy. The abstract operation validate non-revoke proxy takes argument proxy, a proxy exotic object, and returns either a normal completion containing unused or a throw completion. It throws a type error exception if proxy has been revoked. It performs the following steps when called. If proxy is null, throw a type error exception. Assert. Proxy is not null. Return unused. 0. 5. 1 5 proxy create. Target. Handler. The abstract operation proxy create takes arguments target, an ECMAScript language value, and handler, an ECMAScript language value, and returns either a normal completion containing a proxy exotic object or a throw completion. It is used to specify the creation of new proxy objects. It performs the following steps when called. If target is not an object, throw a type error exception. If handler is not an object, throw a type error exception. Let P be make basic object. Set P's essential internal methods, except for and, to the definitions specified in 10.5. If is callable, target, is true, then A set P is specified in the 10th of May 2012. B if is constructor, target, is true, then I set P is specified in the 10th of May 2013. Set P to target, set P to handler, return P, 12, ECMA International 2024. Note 1 A proxy exotic object only has an internal method if the initial value of its internal slot is an object that has an internal method. 11 ECMAScript language. Source text syntax, source character, any Unicode code point. ECMAScript source text is a sequence of Unicode code points. All Unicode code point values from U+0000 to U+10FF, including surrogate code points, may occur in ECMAScript source text where permitted by the ECMAScript grammars. The actual encodings used to store and interchange ECMAScript source text is not relevant to this specification. Regardless of the external source text encoding, a conforming ECMAScript implementation processes the source text as if it was an equivalent sequence of source character values, each source character being a Unicode code point. Conforming ECMAScript implementations are not required to perform any normalization of source text, or behave as though they were performing normalization of source text. The components of a combining character sequence are treated as individual Unicode code points even though a user might think of the whole sequence as a single character. Note in string literals, regular expression.
This takes 2 minutes to build. I'll be back.
Sequences that explicitly express a code point's numeric value. Within a comment, such an escape sequence is effectively ignored as part of the comment. ECMAScript differs from the Java programming language in the behavior of Unicode escape sequences. In a Java program, if the Unicode escape sequence U000, for example, occurs within a single line comment, it is interpreted as a line terminator. Unicode code point U+000A is line feed, LF, and therefore the next code point is not part of the comment. Similarly, if the Unicode escape sequence U000A occurs within a string literal in a Java program, it is likewise interpreted as a line terminator, which is not allowed within a string literal. One must write N instead of U000A to cause a line feed, LF, to be part of the string value of a string literal. In an ECMAScript program, a Unicode escape sequence occurring within a comment is never interpreted and therefore cannot contribute to termination of the comment. Similarly, a Unicode escape sequence occurring within a string literal in an ECMAScript program always contributes to the literal and is never interpreted as a line terminator or as a code point that might terminate the string literal. 1 static semantics, UTF-16 encode code point, CP. The abstract operation UTF-16 encode code point takes argument CP, a Unicode code point, and returns a string. It performs the following steps when called. Assert 0 CP0 times 10FF. If CP0 XFF, return the string value consisting of the code unit whose numeric value is CP. Let K1 be the code unit whose numeric value is floor. CP0 times 10,000, 0 times 400 plus 0 XD800. Let Q2 be the code unit whose numeric value is CP0 times 10,000, modulo 0 times 400 plus 0 XDC00. Return the string concatenation of Q1 and Q2. ECMA International 2024 213. 1 2 static semantics. Code points to string. Text. The abstract operation code points to string takes argument text, a sequence of Unicode code points, and returns a string. It converts text into a string value. as described in 6.1.4. It performs the following steps when called. Let result be the empty string. For each code point CP of text, do a set result to the string concatenation of result and UTF-16 encode code point CP3. Return result 1, 1, 3 static semantics, UTF-16 surrogate pair to code point, lead, trail. The abstract operation UTF-16 surrogate pair to code point takes arguments lead a code unit, and trail, a code unit, and returns a code point. Two code units that form a UTF-16 surrogate pair are converted to a code point. It performs the following steps when called. Assert. Lead is a leading surrogate and trail is a trailing surrogate. Let CP be lead 0xd800, 0 times 400 plus trail 0xdc00 plus 0 times 10,000. Return the code point CP 1, 1. For static semantics, code point at string, position. The abstract operation code pointer takes argument string, a string, and position, a non-negative integer, and returns a record with fields, a code point, a positive integer, and a boolean. It interprets string as a sequence of UTF-16 encoded code points, as described in 6.1.4, and reads from it a single code point starting with the code unit at index position. It performs the following steps when called. Let size be the length of string. Assert. Position 0 and position size. Let first be the code unit at index position within string. Let CP be the code point whose numeric value is the numeric value of first. If a first is neither a leading surrogate nor a trailing surrogate, then return the record CP 1, full 6. If a first is a trailing surrogate or position plus 1 equals size, then return the record CP 1, true. Let second be the code unit at index position plus 1 within string. If second is not a trailing surrogate, then return the record CP 1, true. Set CP to UTF-16 surrogate pair to code point first, second 0. Return the record CP 2, false 1, 1. 5 static semantics, string to code points. String. The abstract operation string to code points takes argument string, a string, and returns a list of code points. It returns the sequence of Unicode code points that results from interpreting string as UTF-16 encoded Unicode text as described in 6.1.4. It performs the following steps when called. Let code points be a new empty list. Let size be the length of string. Let position be 0. Repeat. While position size. Let CP be code point at string, position be append CP to code points. Set position to POSI tion plus CP. Return code points. 14. ECMA International 2024. 1.1.1. 6 static semantics. Parse text. Source text. Goal symbol. The abstract operation parse text takes argument source text, a sequence of Unicode code points, and goal symbol, a non-terminal in one of the ECMAScript grammars, and returns a parse node or a non-empty list of syntax error objects. It performs the following steps when called. Attempt to parse source text using goal symbol as the goal symbol, and analyze the parse result for any early error conditions. Parsing and early error detection may be interleaved in an implementation-defined manner. If the parse succeeded and no early errors were found, return the parse node, an instance of goal symbol, at the root of the parse tree resulting from the parse. Otherwise, return a list of one or more syntax error objects representing the parsing errors and/or early errors. If more than one parsing error or early error is present, the number and ordering of error objects in the list is implementation defined, but at least one must be present. Note to see also clause 17. 1.2 Types of source code. There are 4 types of ECMAScript code. Global code is source text that is treated as an ECMAScript script. The global code of a particular script does not include any source text that is parsed as part of a function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, async arrow function, class declaration, or class expression. Eval code is the source text supplied to the built-in eval function. More precisely, if the parameter to the built-in eval function is a string, it is treated as an ECMAScript script. The eval code for a particular invocation of eval is the global code portion of that script. Function code is source text that is parsed to supply the value of the and internal slots, C10.2, of an ECMAScript function object. The function code of a particular ECMAScript function does not include any source text that is parsed as the function code of a nested function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, async arrow function, class declaration, or class expression. In addition, if the source text referred to above is parsed as the formal parameters and function body of a function declaration or function expression, the formal parameters and generator body of a generator declaration or generator expression, the formal parameters and async function body of an async function declaration or async function expression, or the formal parameters and async generator body of an async generator declaration or async generator expression, then the SOA text match by the binding identifier, if any of that declaration or expression is also included in the function code of the corresponding function. Module code is source text that is provided as a module body. It is the code that is directly evaluated when a module is initialized. The module code of a particular module does not include any source. Note 1. Consider a text that has an early error at a particular point, and also a syntax error at a later point. An implementation that does a parse followed by an early errors parse might report the syntax error and not proceed to the early errors parse. An implementation that interleaves the two activities might report the early error and not proceed to find the syntax error. A third implementation might report both errors. All of these behaviors are conformant. Copyright sign, ECMA International 2024 215. Text that is parsed as part of a nested function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, async arrow function, class declaration, or class expression. Note 1. Function code is generally provided as the bodies of function definitions, 15.2, arrow function definitions, 15.3, method definitions, 15.4, generator function definitions, 15.5, async function definitions, 15.8, async generator function definitions, 15.6, and async arrow functions, 15.9. Function code is also derived from the arguments to the function constructor 20211, the generator function constructor 27311, and the async function constructor 27711. Note 2. The practical effect of including the binding identifier in function code is that the early errors for strict mode code are applied to a binding identifier that is the name of a function whose body contains a use strict directive, even if the surrounding code is not strict mode code. 1. 2. 1 directive prologues in the use strict directive. A directive prologue is the longest sequence of expression statements occurring as the initial statement list items or module items of a function body, a script body, or a module body, and where each expression statement in the sequence consists entirely of a string literal token followed by a semicolon. The semicolon may appear explicitly.
I don't know. I think I want to add like another I can't optimize anything. I can't optimize anything without the risk of breaking stuff. I need to like just get it running first, 64-bit. It doesn't matter. It's so complicated.
Prologue that contains a use strict directive, or if the call to eval is a direct eval that is contained in strict mode code. Function code is strict mode code if the associated function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator.
I need a time macro, or whatever, not a macro. I need to like figure out how to get the time in C again, like an accurate time. I have some timers, but I always like make a new timer to like stopwatch, see how fast stuff is. Because I don't know. I wrap it in a macro and I call like start time or start clock, end clock, pause clock, like whatever. And it becomes too complicated. And I don't know. I'll just make a new stopwatch thing and use that to time the stuff that I'm making now. Otherwise I'm gonna spend like 20 minutes digging through. And there's like there's wall clock time, there's atomic time, and then there's like I don't know. Getting the time is difficult. And then they give you like a double, and then it doesn't normally print a double or something. You gotta like divide it by some amount, get the remainder. I don't know, getting the time is a pain in C. So I'm gonna get like, I'll like look up, I think this timer I have here, they use for something, it's for whatever the big Teslas I have. I think this was pretty accurate. So I'll try to like find the name of the API was, and then Google it, or I'll just pull it apart and then figure something out. I don't know. Yeah. I want a pet monkey though. They could like train to program. That'd be nice.
Capital T E M P L A T E, capital T A. Goal is used in syntactic grammar contexts where a regular expression literal, a template middle, or a template tail is permitted. The input element regexp goal symbol is used in all syntactic grammar contexts where a regular expression literal is permitted but neither a template middle nor a template tail is permitted. The input element template tail goal is used in all syntactic grammar contexts where a template middle or a template tail is permitted but a regular expression literal is not permitted. In all other contexts, input element div is used as the lexical goal symbol. Note the use of multiple lexical goals ensures that there are no lexical ambiguities that would affect automatic semicolon insertion. For example, there are no syntactic grammar contexts where both a leading division or division assignment and a leading regular expression literal are permitted. This is not affected by semicolon insertion, see 12.10, in examples such as the following: a equals b high g exec, c map, d, where the first non-white space, non-comment code point after a line terminator is u plus 002 f, solidus, and the syntactic context allows division or division assignment. No semicolon is inserted at the line terminator. That is, the above example is interpreted in the same way as a equals b high g exec, c map, d, syntax, input element div, white space, line terminator comment token div punctuator right brace punctuator, input element regexp, white space, line terminator comment token right brace punctuator regular expression literal, ECMA International 2024 217, capital I, N, P, U, T, capital E, L, E, M, E, N, T, capital R, E, G, capital E, X, P, capital O, R, capital T, E, M, P, L, A, T, E, capital T, A, white space, line terminator comment token regular expression literal substitution tail, input element template tail.
I need to go load up caffeine, pop, soda, sugar, and all the essentials for to promote brain activity. And I'll be back.
In category CF in the Unicode character database such as left to right mark or right to left mark are control codes used to control the formatting of a range of text in the absence of higher level protocols for this, such as markup languages. It is useful to allow format control characters in source text to facilitate editing and display. All format control characters may be used within comments and within string literals, template literals, and regular expression literals. U plus 200C, 0 width non-joiner, and U plus 200D, 0 width joiner, are format control characters that are used to make necessary distinctions when forming words or phrases in certain languages. In ECMAScript source text, these code points may also be used in an identifier name after the first character. U plus F, 0 width no break space, is a format control character used primarily at the start of a text to mark it as Unicode and to allow detection of the text's encoding and byte order. ZWMBSP. Characters intended for this purpose can sometimes also appear after the start of a text, for example as a result of concatenating files. In ECMAScript source text, ZWMBSP, code points are treated as white space characters. See 12.2, the special treatment of certain format control characters outside of comments, string literals, and regular expression literals is summarized in Table 35. Table 35. Format control code point usage. Code point name abbreviation usage U plus 200C 0 width non-joiner ZWNJ identifier part U plus 200D 0 width joiner ZWJ identifier part U plus FF 0 width no break space ZWNBSP white space 218 ECMA International 2024 12.2 white space code points are used to improve source text readability and to separate tokens, indivisible lexical units, from each other, but are otherwise insignificant. White space code points may occur between any two tokens and at the start or end of input. White space code points may occur within a string literal, a regular expression literal, a template, or a template substitution tail where they are considered significant code points forming part of a literal value. They may also occur within a comment, but cannot appear within any other kind of token. The ECMAScript white space code points are listed in Table 36. Table 36. White space code points. Code points. Name. Abbreviation. U plus 0009. Character tabulation. Tab. U plus 000B. Line tabulation. VT. U plus 000C. Form feed. FF, U plus FF, 0 width no break space, ZWNBSP, any code point in general category space separator, USP, no 1 U plus 0020, space, and U plus 00A0, no break space. Code points are part of USP syntax. Note 2, other than for the code points listed in Table 36. ECMAScript white space intentionally excludes all code points that have the Unicode white space property but which are not classified in general category space separator. ZEDS 2.3 white space tab VT FF ZWMBSP OSP line terminators, like white space code points. Line terminator code points are used to improve source text readability and to separate tokens, indivisible lexical units, from each other. However, unlike white space code points, line terminators have some influence over the behavior of the syntactic grammar. In general, line terminators may occur between any two tokens, but there are a few places where they are forbidden by the syntactic grammar. Line terminators also affect the process of automatic semicolon insertion. 12.10. A line terminator cannot occur within any token except a string literal, template, or template substitution tail, LF. And CR line terminators cannot occur within a string literal token except as part of a line continuation. A line terminator can occur within a multi-line comment but cannot occur within a single line comment. Line terminators are included in the set of white space code points that are matched by the S-class in regular expressions. ECMA International 2024-219. The ECMAScript line terminator code points are listed in Table 37. Table 37. Line terminator code points. Code point. Unicode name. Abbreviation. U+000. Line feed. LF. U+000D. Carriage return CR. U+2028. Line separator. LS. U+2029. Paragraph separator. PS. Only the Unicode code points in Table 37 are treated as line terminators. Other new line or line breaking Unicode code points are not treated as line terminators but are treated as white space if they meet the requirements listed in Table 36. The sequence, CR, LF, is commonly used as a line terminator. It should be considered a single source character for the purpose of reporting line numbers. Syntax, line terminator, LF, CRLS, PS, line terminator sequence, LF, CR look ahead, LF. LS, PS, CRLF. 2.4 comments. Comments can be either single or multi-line. Multi-line comments cannot nest, because a single line comment can contain any Unicode code point except a line terminator code point, and because of the general rule that a token is always as long as possible. A single line comment always consists of all code points from the marker to the end of the line. However, the line terminator at the end of the line is not considered to be part of the single line comment. It is recognized separately by the lexical grammar and becomes part of the stream of input elements for the syntactic grammar. This point is very important because it implies that the presence or absence of single line comments does not affect the process of automatic semicolon insertion. See 12.10. Comments behave like white space and are discarded except that if a multi-line comment contains a line terminator code point, then the entire comment is considered to be a line terminator for purposes of parsing by the syntactic grammar. Syntax, comment, multi-line comment, single line comment. 20. ECMA International 2024. Multi-line comment charsopt, multi-line comment chars, multi-line not asterisk char, multi-line comment charsopt, post asterisk comment charsopt, post asterisk comment chars, capital M, U, L, T, I, capital L, I, N, E, capital N, O, T, capital F, O, R, W, A, R, D, capital S, L, A, S, H, capital O, R, capital A, S, T, E, multi-line comment charsopt, post asterisk comment charsopt, multi-line not asterisk char, source character but not, capital M, U, L, T, I, capital L, I, N, E, capital N, O, T, capital F, O, R, W, A, R, D, capital S, L, A, S, H, capital O, R, capital A, S, T, E, source character but not one of all, single line comment charsopt, single line comment chars, single line comment char, single line comment charsopt, single line comment char, source character but not line terminator. A number of productions in this section are given alternative definitions in section B. 1.112.5 #comments Hashbang comments are location sensitive and like other types of comments are discarded from the stream of input elements for the syntactic grammar. Syntax. Hashbang comment. Single line comment charsoct. 2.6 tokens syntax. Common token. Colon identifier name. Private identifier punctuator numeric literal string literal template. Note the div punctuator. Regular expression literal. Right brace punctuator. And template substitution tail productions derive additional tokens that are not included in the common token production. ECMA International 2024 221 12.7 Names and keywords. Identifier name and reserved word are tokens that are interpreted according to the default identifier syntax given in Unicode Standard Annex number 31, identifier and pattern syntax, with some small modifications. Reserved word is an enumerated subset of identifier name. The syntactic grammar defines identifier as an identifier name that is not a reserved word. The Unicode identifier grammar is based on character properties specified by the Unicode standard. The Unicode code points and the specified categories in the latest version of the Unicode standard must be treated as in those categories by all conforming ECMAScript implementations. ECMAScript implementations may recognize identifier code points defined in later editions of the Unicode standard. Syntax. Private identifier. Identifier name. Identifier name. Identifier start. Identifier name. Identifier part. Identifier start. Identifier start char. Unicode escape sequence. Identifier part. Identifier part char. Unicode escape sequence. Identifier start char. Unicode ID start. Underscore. Identifier part char. Unicode ID continue. ZWNJ. ZWJ. Assign letter. 1 of A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z, capital A, capital B, capital C, capital D. Not but Gustav Wexes. Unicode ID start. Any Unicode code point with the Unicode property ID start. Unicode ID continue. Any Unicode code point with the Unicode property ID continue. The definitions of the non-terminal Unicode escape sequences given in 1.2.9.4. Note 1. This standard specifies specific code point additions, U+0024, $, and U+005F, low line, are permitted anywhere in an identifier name, and the code points U+200C, 0 width non-joiner, and U+200D, 0 width joiner, are permitted anywhere after the first code point of an identifier name. 22. Copyright sign. ECMA International 2024. Note 2. The non-terminal identifier part derives via Unicode ID continue. 2. 7. 1. Identifier names. Unicode escape sequences are permitted in an identifier name, where they contribute a single Unicode code point equal to the identifier code point of the Unicode escape sequence. The preceding the Unicode escape sequence does not contribute any code points. A Unicode escape sequence cannot be used to contribute a code point to an identifier name that would otherwise be invalid. In other words, if a Unicode escape sequence were replaced by the source character it contributes, the result must still be a valid identifier name that has the exact same sequence of source character elements as the original identifier name. All interpretations of identifier name within this specification are based upon their actual code points regardless of whether or not an escape sequence was used to contribute any particular code point. 2. Identifier names that are canonically equivalent according to the Unicode standard and not equal unless, after replacement of each Unicode escape sequence, they are represented by the exact same sequence of code points. 2. 7. 1. 1. Static semantics. Early errors. Identifier start. Unicode escape sequence. It is a syntax error if identifier code point of Unicode escape sequence is not some Unicode code point matched by the identifier start char lexical grammar production. Identifier part. Unicode escape sequence. It is a syntax error if identifier code point of Unicode escape sequence is not some Unicode code point matched by the identifier part char lexical grammar production. 2. 7. 1. 2. Static semantics. Identifier code points. The syntax-directed operation identifier code points takes no arguments and returns a list of code points. It is defined piecewise over the following productions: identifier name, identifier start. Let CP be identifier code point of identifier start. Return CP identifier name, identifier part. Let CPS be identifier code points of the derived identifier name. Let CP be identifier code point of identifier part. Return the list concatenation of CPS and CP. 2, 7, 1, 3 static semantics. Identifier code point. The syntax-directed operation identifier code point takes no arguments and returns a code point. It is defined piecewise over the following productions: identifier start. Identifier start char. Return the code point matched by identifier start char. Note 3: the sets of code points with Unicode properties ID start and ID continue include, respectively, the code points with Unicode properties other ID start and other ID continue. ECMA International 2024 223. Identifier part. Identifier part char. Return the code point matched by identifier part char. Unicode escape sequence. U hex 4 digits. Return the code point whose numeric value is the NV of hex 4 digits. Unicode escape sequence. U code point. Return the code point whose numeric value is the NV of code point. 2, 7, 2 keywords and reserved words. A keyword is a token that matches identifier name, but also has a syntactic use. That is, it appears literally, in a fixed width font, in some syntactic production. The keywords of ECMAScript include if, while, async, await, and many others. A reserved word is an identifier name that cannot be used as an identifier. Many keywords are reserved words, but some are not, and some are reserved only in certain contexts. If and while a reserved word's await is reserved only inside async functions and modules, async is not reserved. It can be used as a variable name or statement label without restriction. This specification uses a combination of grammatical productions and early error rules to specify which names are valid identifiers and which are reserved words. All tokens in the reserved word list below, except for await and yield, are unconditionally reserved. Exceptions f or await and yield are specified in 13.1, using parameterized syntactic productions. Lastly, several early error rules restrict the set of valid identifiers. C13, 1, 1, 1, 4, 3, 1, 1, 1, 4, 7, 5, 1, and 1, 5, 7, 1. In summary, there are 5 categories of identifier names: those that are always allowed as identifiers, and are not keywords, such as math, window, toString, and those that are never allowed as identifiers, namely the reserved words listed below except await and yield. Those that are contextually allowed as identifiers, namely await and yield. Those that are contextually disallowed as identifiers, in strict mode code. Let, static, implements, interface, package, private, protected, and public. Those that are always allowed as identifiers, but also appear as keywords within certain syntactic productions, at places where identifier is not allowed, as async, from, get, meta, of, set, and target. The term conditional keyword, or contextual keyword, is sometimes used to refer to the keywords that fall in the last 3 categories, and thus can be used as identifiers in some contexts and as keywords in others. Syntax: reserved word. 1 of await break case catch class const continue debugger default delete 2 else enum export extends false finally for function of import an instantia of new null return super switch this throw true try type off var void well with a yield 24 ECMA International 2024 note 1 per 5 1 5 keywords in the grammar match literal sequences of specific source character elements. A code point and a keyword cannot be expressed by a Unicode escape sequence. An identifier name can contain Unicode escape sequences, but it is not possible to declare a variable named else by spelling it else u. 65. The early error rules in 1.3.1. 1 rule out identifiers with the same string value as a reserved word. Note 2 enum is not currently used as a keyword in this specification. It is a future reserved word, set aside for use as a keyword in future language extensions. Similarly, implements, interface, package, private, protected, and public are future reserved words in strict mode code. Note 3: the names arguments and eval are not keywords, but they are subject to some restrictions in strict mode code. C13 1 1 8 6 4 1 5 2 1 1 5 5 1 1 5 6 1 and 1 5 8 1. 2.8 Punctuators. Syntax: punctuator, optional chaining punctuator, other punctuator, optional chaining punctuator, look ahead decimal digit, other punctuator, 1 of, comma, equals, equals 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 plus, percent plus plus, and equals plus equals 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 percent equals 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 and equals 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 and equals 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 equals. Div punctuator, equals sign, right brace punctuator, 2.9 literals, 2 9 1 null literals. Syntax: null literal, null. ECMA International 2024 225 1 2 9 2 Boolean literals. Syntax: Boolean literal, true, false. 2 9 3 numeric literals. Syntax: numeric literal separator, numeric literal, decimal literal, decimal big integer literal, non-decimal int, ger literal, plus sep, non-decimal integer literal, plus sep, begin literal suffix legacy octal integer literal, decimal big integer literal, 0 big int literal suffix, non-zero digit decimal digits, plus sep opt begin literal suffix, non-zero digit numeric literal separator decimal digits, plus sep, begin literal suffix, non-decimal integer literal, sep, binary integer literal sep, octal integer literal sep, hex integer literal sep, begin literal suffix, n, decimal literal, decimal integer literal, decimal digits, plus sep opt exponent part, plus sep opt, decimal digits, plus sep, exponent part, plus sep opt, decimal integer literal exponent part, plus sep opt, decimal integer literal, 0 non-zero digit numeric literal separator opt decimal digits, plus sep, non-octal decimal integer literal, decimal digits, sep, decimal digit sep, decimal digit, plus sep, decimal digits, plus sep, numeric literal separator decimal digit, 1 of 0 1 2 3 4 5 6 7 8 9 26. ECMA International 2024, non-zero digit, 1 of 123,456,789. Exponent part, sep, exponent indicator signed integer sep, exponent indicator, 1 of EE, signed integer, sep, decimal digit sep, decimal digit sep, decimal digit sep, binary integer literal, sep, 0b binary digit sep, 0b binary digit sep, binary digits, sep, binary digit sep, binary digit, plus sep, binary digits, plus sep, numeric literal separator binary digit, 1 of 0 1, octal integer literal, sep, 0 octal digit sep, 0 octal digit sep, octal digits, sep, octal digit sep, octal digit, plus sep, octal digits, plus sep, numeric literal separator octal digit, legacy octal integer literal, 0 octal digit, legacy octal integer literal octal digit, non-octal decimal integer literal, 0 non-octal digit, capital L, E, G, A, C, Y, capital O, C, T, A, L, capital L, I, K, E, capital D, E, C, I, M, A, L, capital I, N, T, E, G, E, R, capital L, non-octal digit non-octal decimal integer literal decimal digit, capital L, E, G, A, C, Y, capital O, C, T, A, L, capital L, I, K, E, capital D, E, C I M A L capital I N T E G E R capital L 0 octal digit capital L E G A C Y capital O C T A L capital L I K E capital D E C I M A L capital I N T E G E R capital L octal digit 1 of 1,234,567 non-octal digit 1 of 89 ECMA International 2024 227 hex integer literal SEP 0x hex digits SEP 0x hex digits SEP hex digits SEP hex digit SEP hex digit plus SEP hex digits plus SEP numeric literal separator hex digit 1 of 0 1 2 3 4 5 6 7 8 9 abdef a b c d e f. The source character immediately following a numeric literal must not be an identifier start or decimal digit. 2 9 3 1 static semantics early errors numeric literal legacy octal integer literal decimal integer literal non-octal decimal integer literal. It is a syntax error if the source text matched by this production is strict mode code. Note in non-strict code, this syntax is legacy 2 9 3 2 static semantics MV. A numeric literal stands for a value of the number type or the big int type. The MV of decimal literal, decimal integer literal. Decimal digits is the MV of decimal integer literal plus the MV of decimal digits 10n, where n is the number of code points in decimal digits, excluding all occurrences of numeric literal separator. The MV of decimal literal, decimal integer literal. Exponent part is the MV of decimal integer literal 10e, where e is the MV of exponent part. The MV of decimal literal, decimal integer literal. Decimal digits exponent part is the MV of decimal integer literal plus the MV of decimal digits 10n, 10e, where n is the number of code points in decimal digits, excluding all occurrences of numeric literal separator, and e is the MV of exponent part. The MV of decimal literal. Decimal digits is the MV of decimal digits 10n, where n is the number of code points in decimal digits, excluding all occurrences of numeric literal separator. The MV of decimal literal. Decimal digits exponent part is the MV of decimal digits 10e, n, where n is the number of code points in decimal digits, excluding all occurrences of numeric literal separator, and e is the MV of exponent part. The MV of decimal literal, decimal integer literal exponent part is the MV of decimal integer literal 10e, where e is the MV of exponent part. The MV of decimal integer literal 0 is 0. The MV of decimal integer literal, non-zero digit numeric literal separator op decimal digits is the MV of non-zero digit 10n plus the MV of decimal digits, where n is the number of code points in decimal digits, excluding all occurrences of numeric literal separator. The MV of decimal digits decimal digit is the MV of decimal digits 10 plus the MV of decimal digit. The MV of decimal digits numeric literal separator decimal digit is the MV of decimal digits 10 plus the MV of decimal digit. The MV of exponent part. Exponent indicator signed integer is the MV of signed integer. The MV of signed integer. Decimal digits is the negative of the MV of decimal digits. The MV of decimal digit. 0 or of hex digit. 0 or of octal digit. 0 or of 228. ECMA International 2024. Note, for example, 3 inches is an error and not the 2 input elements 3 and in legacy octal escape sequence. 0 or a binary digit. 0 is 0. The MV of decimal digit. 1 or of non-zero digit. 1 or of hex digit. 1 or of octal digit. 1 or of binary digit. 1 is 1. The MV of decimal digit. 2 or of non-zero digit. The MV of decimal digit. 3 or of non-zero digit. The MV of decimal digit. 4 or of non-zero digit, the envy of decimal digit. 5 or of non-zero digit, the envy of decimal digit. 6 or of non-zero digit, the envy of decimal digit. 7 or of non-zero digit, the envy of decimal digit. 8 or of non-zero digit, the envy of decimal digit. 9 or of non-zero digit, or of hex digit. 2 or of octal digit. 2 is 2. 3 or of hex digit. 3 or of octal digit. 3 is 3. 4 or of hex digit. 4 or of octal digit. 4 is 4. 5 or of hex digit. 5 or of octal digit. 5 is 5. 6 or of hex digit. 6 or of octal digit. 6 is 6. 7 or of hex digit. 7 or of octal digit. 7 is 7. 8 or of non-octal digit. 8 or of hex digit. 8 is or of non-octal digit. 9 or of hex digit. 9 is the envy of hex digit, or of hex digit. A is 10, the envy of hex digit. B or of hex digit. B is 11, the envy of hex digit. C or of hex digit. C is 12, the envy of hex digit. D or of hex digit. D is 13, the envy of hex digit. E or of hex digit. E is 14, the envy of hex digit. F or of hex digit. F is 15, the envy of binary digits. Binary digits. Binary digit is the envy of binary digits 2 plus the envy of binary digit. The envy of binary digits. Binary digits. Numeric literal separator. Binary digit is the envy of binary digits plus the envy of binary digit. The envy of octal digits. Octal digits. Octal digit is the envy of octal digits 8 plus the envy of octal digit. The envy of octal digits. Octal digits. Numeric literal separator. Octal digit is the envy of octal digits 8 plus the envy of octal digit. The envy of legacy octal integer literal. Legacy octal integer literal. Octal digit is the envy of legacy octal integer literal times 8 plus the envy of octal digit. The envy of non-octal decimal integer literal. Capital L, E, G, A, C, Y. Capital O, C, T, A, L. Capital L, I, K, E. Capital D, E, C, I, M, A, L. Capital I, N, T, E, G, E, R. Capital L. Non-octal digit is the envy of capital L, E, G, A, C, Y. Capital O, C, T, A, L. Capital L, I, K, E. Capital D, E, C, I, M, A, L. Capital I, N, T, E, G, E, R. Capital L times 10 plus the envy of non-octal digit. The envy of non-octal decimal integer literal. Non-octal decimal integer literal decimal digit is the envy of non-octal decimal integer literal times 10 plus the envy of decimal digit. The envy of capital L, E, G, A, C, Y. Capital O, C, T, A, L. Capital L, I, K, E. Capital D, E, C, I, M, A, L. Capital I, N, T, E, G, E, R. Capital L, E, G, A, C, Y. Capital O, C, T, A, L. Capital L, I, K, E. Capital D, E, C, I, M, A, L. Capital I, N, T, E, G, E, R. Capital L. Octal digit is the envy of capital L, E, G, A, C, Y. Capital O, C, T, A, L. Capital L, I, K, E. Capital D, E, C, I, M, A, L. Capital I, N, T, E, G, E, R, capital L, times 10 plus the MV of octal digit, the MV of hex digits. Hex digit is the MV of hex digits 16 plus the MV of hex digit, the MV of hex digits. Hex digits numeric literal separator hex digit is the MV of hex digits 16 plus the MV of hex digit 2, 9, 3, 3 static semantics. Numeric value. The syntax-directed operation numeric value takes no arguments and returns a number or a big int. It is defined piecewise over the following productions. Numeric literal, decimal literal. Return round MV result, MV of decimal literal. Numeric literal, non-decimal integer literal. Return, MV of non-decimal integer literal. Numeric literal, legacy octal integer literal. Return, MV of legacy octal integer literal. Numeric literal, non-decimal integer literal big int literal suffix. Return the big int value for the MV of non-decimal integer literal. ECMA International 2024 229. Decimal big integer literal. 0 big int literal suffix 1. Return 0z. Decimal big integer literal, non-zero digit big int literal suffix 1. Return the big int value for the MV of non-zero digit. Decimal big integer literal. Non-zero digit decimal digits big int literal suffix. Non-zero digit numeric literal separator decimal digits big int literal suffix. Let n be the number of code points in decimal digits, excluding all occurrences of numeric literal separator. Let nv be the MV of non-zero digit 10n plus the MV of decimal digits. Return z, MV 2, 9. 4 string literals. Note 1. A string literal is 0 or more Unicode code points enclosed in single or double quotes. Unicode code points may also be represented by an escape sequence. All code points may appear literally in a string literal except for the closing quote code points. U plus 005C, reverse solidus, U plus 000D, carriage return, and U plus 000 line feed. Any code points may appear in the form of an escape sequence. String literals evaluate to ECMAScript string values. When generating these string values, Unicode code points are UTF-16 encoded as defined in 1111. Code points belonging to the basic multilingual plane are encoded as a single code unit element of the string. All other code points are encoded as 2 code unit elements of the string. Syntax: string literal, double string character sopt, single string character sopt, double string characters, double string character sopt, single string characters, single string character sopt, double string character, source character but not one of or line terminator. ls, ps, escape sequence, line continuation, single string character, source character but not one of or line terminator. ls, ps, escape sequence, line continuation, line terminator sequence. 30. ECMA International 2024. Escape sequence, character escape sequence, look ahead decimal digit. Legacy octal escape sequence, non-octal decimal escape sequence, hex escape sequence, Unicode escape sequence, character escape sequence, single escape character, non-escape character, single escape character, one of BFNRTV, non-escape character, source character but not one of escape character or line terminator, escape character, single escape character, decimal digit, XU, legacy octal escape sequence, 0, look ahead. 8, 9, non-zero octal digit, look ahead octal digit, 0 to 3 octal digit, look ahead octal digit, 4 to 7 octal digit, 0 to 3 octal digit, non-zero octal digit but not 0, 0 to 3, 1 of 0, 1 to 3, 4 to 7, 1 of 4567, non-octal decimal escape sequence, 1 of 89. Hex escape sequence, X hex digit, Unicode escape sequence, U hex 4 digits, U, code point, hex 4 digits, hex digit. The definition of the non-terminal hex digit is given in 1293. Source character is defined in 11.1. ECMA International 2024 231. Note 2, LF and CR cannot appear in a string literal, except as part of a line continuation to produce the empty code point sequence. The proper way to include either in the string value of a string literal is to use an escape sequence such as n or u000 2 9 4 1 static semantics, early errors, escape sequence, legacy octal escape sequence, non-octal decimal escape sequence. It is a syntax error if the source text match by this production is strict mode code. Note 1 in non-strict code. This syntax is legacy 2 9 4 to static semantics. SV, the syntax-directed operation SV takes no arguments and returns a string. A string literal stands for a value of the string type. SV produces string values for string literals through recursive application on the various parts of the string literal. As part of this process, some Unicode code points within the string literal are interpreted as having a mathematical value, as described below or in 1 2 9 3. The SV of string literal is the empty string. The SV of string literal is the empty string. The SV of double string characters is the string. Concatenation of the SV of double string character and the SV of double string characters. The SV of single string characters is the string. Concatenation of the SV of single string character and the SV of single string characters. The SV of double string character, source character but not one of or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The SV of double string character, ls, is the string value consisting of the code unit 0 times 2028. Line separator. The SV of double string character, ps, is the string value consisting of the code unit 0 times 2029. Paragraph separator. The SV of double string character, line continuation is the empty string. The SV of single string character, source character but not one of or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The SV of single string character, ls, is the string value consisting of the code unit 0 times 2028. Line separator. The SV of single string character, ps, is the string value consisting of the code unit 0 times 2029. Paragraph separator. The SV of single string character, line continuation is the empty string. The SV of escape sequence, 0 is the string value consisting of the code unit 0 times 0000. Null. The SV of character escape sequence, single escape character is the string value consisting of the code unit whose numeric value is determined by the single escape character according to table 38. Note 2: it is possible for string literals to precede a use strict directive that places the enclosing code in strict mode, and implementations must take care to enforce the above rules for such literals. For example, the following source text contains a syntax error, function invalid. 7. Use strict. 32. Copyright sign, ECMA International 2024. Table 38. String single character escape sequences. Escape sequence. Code unit value. Unicode character name. Symbol B 0 times 0008. Backspace BS T 0 times 0009. Character tabulation. HT N 0 times 000 line feed. LF V 0 times 000B. Line tabulation. VT F 0 times 000C. Form feed. FF R 0 times 000D. Carriage return CR. Double quote 0 times 0022. Quotation mark. Apostrophe 0 times 0027. Apostrophe backslash 0 times 005C. Reverse solidus, comma the SV of non-escape character, source character but not one of escape character or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The SV of escape sequence, legacy octal escape sequence is the string value consisting of the code unit whose numeric value is the NV of legacy octal escape sequence. The SV of non-octal decimal escape sequence, 8 is the string value consisting of the code unit 0 times 0038, digit 8. The SV of non-octal decimal escape sequence, 9 is the string value consisting of the code unit 0 times 0039, digit 9. The SV of hex escape sequence, X hex digit is the string value consisting of the code unit whose numeric value is the NV of hex escape sequence, the SV of hex 4 digits. Hex digit is the string value consisting of the code unit whose numeric value is the NV of hex 4 digits. The SV of Unicode escape sequence, U, code point, is the result of performing UTF-16 encode code point on the NV of code point. The SV of template escape sequence, 0 is the string value consisting of the code unit 0 times 0000, null 1 2, 9, 4, 3 static semantics, MV, the MV of legacy octal escape sequence, 0 to 3 octal digit is 8 times the MV of 0 to 3 plus the MV of octal digit. The MV of legacy octal escape sequence, 4 to 7 octal digit is 8 times the MV of 4 to 7 plus the MV of octal digit. The MV of legacy octal escape sequence, 0 to 3 octal digit is 64. That is 82 times the MV of 0 to 3 plus 8 times the MV of the first octal digit plus the MV of the second octal digit. The MV of 0 to 3. 0 is 0. The MV of 0 to 3. 1 is 1. The MV of 0 to 3. 2 is 2. The MV of 0 to 3. 3 is 3. The MV of 4 to 7. 4 is 4, the MV of 4 to 7. 5 is 5, the MV of 4 to 7. 6 is 6, the MV of 4 to 7. 7 is 7, the MV of hex escape sequence. X hex digit is 16 times the MV of the first hex digit plus the MV of the second hex digit. The MV of hex 4 digits. Hex digit is 0 times 1000 the MV of the first hex digit, plus 0 times 100 the MV of the second hex digit, plus 0 times 10 the MV of the third hex digit, plus the MV of the fourth hex digit. ECMA International 2024 233 1 2 9 5 regular expression literals. The productions below describe the syntax for a regular expression literal and are used by the input element scanner to find the end of the regular expression literal. The source text comprising the regular expression body and the regular expression flags are subsequently parsed again using the more stringent ECMAScript regular expression grammar. 2.2.2.1. An implementation may extend the ECMAScript regular expression grammar defined in 2.2.2.1, but it must not extend the regular expression body and regular expression flags productions defined below or the productions used by these productions. Syntax: regular expression literal, regular expression body, regular expression flags, regular expression body, regular expression first char, regular expression chars, regular expression chars. Empty, regular expers, sign chars, regular expression char, regular expression first char, regular expression non-terminator but not one of or. Capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital B, A, C, K, S, L, A, S, H, capital S, E, Q, U, regular expression class, regular expression char, regular expression non-terminator but not one of or. Capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital B, A, C, K, S, L, A, S, H, capital S, E, Q, U, regular expression class, capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital B, A, C, K, S, L, A, S, H, capital S, E, Q, U, regular expression non-terminator, regular expression non-terminator, source character but not line terminator, regular expression class chars, regular expression class chars, empty. Regular expression class chars. Regular expression class char. Regular expression class char. Regular expression non-terminated but not one of, or, capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital B, A, C, K, S, L, A, S, H, capital S, E, Q, U. Note 1. A regular expression literal is an input element that is converted to a regexp object. See 22.2 each time the literal is evaluated. Two regular expression literals in a program evaluate to regular expression objects that never compare as equals to each other even if the two literals' contents are identical. A regexp object may also be created at runtime by new regex or calling the regexp.
I have a program, whatever, that I originally made this for, and then I added to it later, and I added to it, and I added to it. So it's not only for the original use, and I can't find like the main. There's a main, like every C file, or I guess you could possibly name it something other than main, but everybody likes to conform to calling the function that holds everything main. And then it's like int, char, argv, pointer, array for like command line arguments. It's like the conformity. And then like a main that is void, a void main that's like sin, because it always has to return an integer. Even if it's just 0, you can't. God forbid if you make main a void function type. Oh, it's like programming Bible. Can't use goto. People are so stupid. Okay, anyways. I need to find wherever the fuck the main is. And I really hope I didn't delete it. Which is what I think I may have done. Because I have test functions that check all these conditions, whatever, because I was updating it a while ago, and then I just kind of, whatever, behind the scenes, I did other stuff. Freaking find it. So many fucking files. And half of them aren't even used for this build mode. I have to like pick through them one by one. I have a list of them somewhere.
The TV of no substitution.
We had a list of 124 files covered in use out of the 300, 200, I don't know.
characters is undefined. Otherwise, it is the string concatenation of the TV of template character and the TV of template characters. The TV of template character, source character but not one of or $sign or line terminator is the result of performing UTF-16 edit.
I'm gonna put like any of the new stuff like at the very bottom because I don't want to mess stuff up above. I gotta use the globals unless I can find what I'm looking for. Then I can find the macros to account for local variables. But I can't because of that.
X. Copyright sign. ECMA International 2000.
I just gotta make it work. So I'm just gonna find the main. Because I have control flow macros. And I can't find anything like scattered around through other things that deal with like an if else. A do while, a switch. I gotta find the macros to make a freaking loop.
TRV of template middle, $sign, is the empty string. The TRV of template tail is the empty string. The TRV of template characters.
And function chat that made.
Characters. The TRV of template character.
There's only one if, two ifs. I could just go to the ifs, but they would probably affect the performance, whatever. So I kind of want to keep them. So I get rid of the ifs. All I have is a do while and a loop terminating condition. But I gotta find the macro that I made for a do while loop. I can't find it. So 90% of the crap is just testing, or like mini tests of like lines of code. There's a scope that's tied to the blocks and stuff. So like I can't just put an if and then test in a hacky way because there's like a whole system I have. I just gotta find the freaking file.
0 times 0075. Latin small letter U. The TRV of not escape sequence. U hex digit. Look ahead hex digit. Is the string concatenation of the code unit 0 times 0075. Latin small letter U. And the TRV of hex digit. The TRV of not escape sequence. U hex digit hex digit. Look ahead hex digit. Is the string concatenation of the code unit 0 times 0075. Latin small letter U. The TRV of the first hex digit. And the TRV of the second hex digit. The TRV of not escape sequence. U hex digit hex digit hex digit. Look ahead hex digit. Is the string concatenation of the code unit 0 times 0075. Latin small letter U. The TRV of the first hex digit. The TRV of the second hex digit. And the TRV of the third hex digit. The TRV of not escape sequence. U. Look ahead hex digit. Is the string concatenation of the code unit 0 times 0075. Latin small letter U. And the code unit 0 times 007b. Left curly bracket. The TRV of not escape sequence. U. Not code point. Look ahead hex digit. Is the string concatenation of the code unit 0 times 0075. Latin small letter U. the code unit 0 times 007b, left curly bracket, and the TRV of not code point, the TRV of not escape sequence, U, code point, look ahead hex digit, look ahead, is the string concatenation of the code unit 0 times 0075, Latin small letter U, the code unit 0 times 007b, left curly bracket, and the TRV of code point, the TRV of decimal digit, 1 of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 is the result of performing UTF-16 encode code point on the single code point matched by this production. The TRV of character escape sequence. Non-escape character is the SV of non-escape character. The TRV of single escape character, 1 of BFNRTV is the result of performing UTF-16 encode code point on the single code point matched by this production. The TRV of hex escape sequence. Hex digit is the string concatenation of the code unit 0 times 0078, Latin small letter x, the TRV of the first hex digit, and the TRV of the second hex digit. The TRV of Unicode escape sequence. U hex 4 digits is the string concatenation of the code unit 0 times 0075, Latin small letter u, and the TRV of hex 4 digits. The TRV of Unicode escape sequence, U, code point, is the string concatenation of the code unit 0 times 0075, Latin small letter u, the code unit 0 times 007b, left curly bracket, the TRV of ECMA International 2024 237, code point, and the code unit 0 times 007d, right curly bracket, the TRV of hex 4 digits. Hex digit is the string concatenation of the TRV of the first hex digit, the TRV of the second hex digit, the TRV of the third hex digit, and the TRV of the fourth hex digit. The TRV of hex digits. Hex digit is the string concatenation of the TRV of hex digits and the TRV of hex digit. The TRV of hex digit. 1 of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 ABCDEF is the result of performing UTF-16 encode code point on the single code point matched by this production. The TRV of line continuation. Line terminator sequences the string concatenation of the code unit 0 times 005C, reverse solidus, and the TRV of line terminator sequence. The TRV of line terminator sequence, LF, is the string value consisting of the code unit 0 times 000 line feed. The TRV of line terminator sequence, CR, is the string value consisting of the code unit 0 times 000 line feed. The TRV of line terminator sequence, LS, is the string value consisting of the code unit 0 times 2028 line separator. The TRV of line terminator sequence, PS, is the string value consisting of the code unit 0 times 2029 paragraph separator. The TRV of line terminator sequence, CRLF, is the string value consisting of the code unit 0 times 000 line feed. 2.10 Automatic semicolon insertion. Most ECMAScript statements and declarations must be terminated with a semicolon. Such semicolons may always appear explicitly in the source text. For convenience, however, such semicolons may be omitted from the source text in certain situations. These situations are described by saying that semicolons are automatically inserted into the source code token stream in those situations. 2.10.1 Rules of automatic semicolon insertion. In the following rules, token means the actual recognized lexical token determined using the current lexical goal symbol as described in clause 12. There are 3 basic rules of semicolon insertion. When, as the source text is passed from left to right, a token, called the offending token, is encountered that is not allowed by any production of the grammar. Then a semicolon is automatically inserted before the offending token if one or more of the following conditions is true. E. The offending token is separated from the previous token by at least one line terminator. The offending token is, the previous token is, and the inserted semicolon would then be passed as the terminating semicolon of a do-while statement 1.4.7.2. When, as the source text is passed from left to right, the end of the input stream of tokens is encountered, and the parser is unable to parse the input token stream as a single instance of the goal non-terminal, then a semicolon is automatically inserted at the end of the input stream. When, as the source text is parsed from left to right, a token is encountered that is allowed by some production of the grammar, but the production is a restricted production and the token would be the first token for a terminal or non-terminal immediately following the annotation, no line terminator here, within the restricted production. And therefore such a token is called a restricted token, and the restricted token is separated from the previous token by at least one line terminator. Then a semicolon is automatically inserted before the restricted token. Note TV excludes the code units of line continuation while TRV includes them. CR, LF, and CR line terminator sequences are normalized to LF for both TV and TRV. An explicit template escape sequence is needed to include a CR or CR, LF sequence 38 ECMA International 2024. However, there is an additional overriding condition on the preceding rules. A semicolon is never inserted automatically if the semicolon would then be parsed as an empty statement or if that semicolon would become one of the two semicolons in the header of a for statement C147. 4. Note the following are the only restricted productions in the grammar. Update expression, yield, await. Left-hand side expression yield await. No line terminator here. ++ left-hand side expression yield await. No line terminator here. Continue statement, yield, await. Continue. Continue. No line terminator here. Label identifier yield await. Break statement, yield, await. Break, break. No line terminator here. Label identifier yield await. Return statement, yield, await. Return, return. No line terminator here. Expression, plus in yield await. Throw statement, yield, await. Throw, no line terminator here. Expression, plus in yield await. Yield expression, in, await. Yield, yield. No line terminator here. Assignment expression in, plus yield await. Yield, no line terminator here. Assignment expression in, plus yield await. Arrow function, in, yield, await. Arrow parameters yield await. No line terminator here, equals. Concise body in, async function declaration, yield, await, default, async. No line terminator here, function binding identifier yield await. Formal parameters, yield, plus await. Async function body, plus default, async. No line terminator here, function, formal parameters, yield, plus await. Async function body, async function expression, a, sync. No line terminator here, function binding identifier, yield, plus await opt. Formal parameters, yield, plus await. Async function body, async method, yield, await, async. No line terminator here, class element name yield await. Unique formal parameters, yield, plus await. Async function body, async generator declaration, yield, await, default, async. No line terminator here, function binding identifier yield await. Formal parameters, plus yield, plus await. Async generator body, plus default, async. No line terminator here, function, formal parameters, plus yield, plus await. Async generator body, async generator expression, async. No line terminator here, function binding identifier, plus yield, plus await opt. Formal parameters, plus yield, plus await. Async generator body, async generator method, yield, await, async. No line terminator here, class element name yield await. Unique formal parameters, plus yield, plus await. Async generator body, async arrow function, in, yield, await, async. No line terminator here, async arrow binding identifier yield. No line terminator here, equals. Async concise body in, capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, S Y N C capital A R R yield await. No line terminator here equals async concise body in ECMA International 2024 239 async arrowhead async. No line terminator here arrow formal parameters yield plus await. The practical effect of these restricted productions is as follows. When a plus plus or token is encountered where the parser would treat it as a postfix operator, and at least one line terminator occurred between the preceding token and the plus plus or token, then a semicolon is automatically inserted before the plus plus or token. When a continue, break, return, throw, or yield token is encountered and a line terminator is encountered before the next token, a semicolon is automatically inserted after the continue, break, return, throw, or yield token. When arrow function parameter s are followed by a line terminator before it equals token, a semicolon is automatically inserted in the punctuator causes a syntax error. When an async token is followed by a line terminator before a function or identifier name or token, a semicolon is automatically inserted in the async token is not treated as part of the same expression or class element as the following tokens. When an async token is followed by a line terminator before a token, a semicolon is automatically inserted in the punctuator causes a syntax error. The resulting practical advice to ECMAScript programmers is a postfix plus plus or operator should be on the same line as its operand. An expression in a return or throw statement or an assignment expression in a yield expression should start on the same line as the return, throw, or yield token. A label identifier in a break or continue statement should be on the same line as the break or continue token. The end of an arrow function's parameter s and its equals should be on the same line. The async token preceding an asynchronous function or method should be on the same line as the immediately following token. 210. Two examples of automatic semicolon insertion. This section is non-normative. The source 12.3 is not a valid sentence in the ECMAScript grammar, even with the automatic semicolon insertion rules. In contrast, the source 123 is also not a valid ECMAScript sentence, but is transformed by automatic semicolon insertion into the following 1, 2, 3, which is a valid ECMAScript sentence. The source 4A, B, 40, copyright sign, ECMA International 2024, is not a valid ECMAScript sentence and is not altered by automatic semicolon insertion because the semicolon is needed for the header of a for statement. Automatic semicolon insertion never inserts one of the two semicolons in the header of a for statement. The source return a plus b is transformed by automatic semicolon insertion into the following return a plus b. The source a equals b plus plus c is transformed by automatic semicolon insertion into the following a equals b plus plus c. The source if a b else c equals d is not a valid ECMAScript sentence and is not altered by automatic semicolon insertion before the else token, even though no production of the grammar applies at that point, because an automatically inserted semicolon would then be passed as an empty statement. The source a equals b plus c d plus e print is not transformed by automatic semicolon insertion because the parenthesized expression that begins the second line can be interpreted as an argument list for a function call a equals b plus c d plus e print. In the circumstance that an assignment statement must begin with a left parenthesis, it is a good idea for the programmer to provide an explicit semicolon at the end of the preceding statement rather than to rely on automatic semicolon insertion. 210. 3 interesting cases of automatic semicolon insertion. This section is non-normative. Note 1. The expression a plus b is not treated as a value to be returned by the return statement because
It takes 2 minutes to build. I'm waiting to see if the code I just added is even included in the build. It should be, because this file's included in the project, so I might have to mess with the define guards for the build to get it to include this module. I'm gonna get some more caffeine sugar. It's still building.
Seeding them to change grammar productions when parsed. For the purposes of this section, a case of automatic semicolon insertion is considered interesting if it is a place where a semicolon may or may not be inserted, depending on the source text which precedes it. The rest of this section describes a number of interesting cases of automatic semicolon insertion in this version of ECMAScript 2.1.0.3. One interesting cases of automatic semicolon insertion in statement lists. In a statement list, many statement list items end in semicolons, which may be omitted using automatic semicolon insertion. As a consequence of the rules above, at the end of a line ending in expression, a semicolon is required if the following line begins with any of the following: an opening parenthesis. Without a semicolon, the two lines together are treated as a call expression, an opening square bracket. Without a semicolon, the two lines together are treated as property access, rather than an array literal or array assignment pattern, a template literal. Without a semicolon, the two lines together are interpreted as a tag template. The 13th of March 2011, with the previous expression as the member expression, an array plus or. Without a semicolon, the two lines together are interpreted as a usage of the corresponding binary operator, a regexp literal. Without a semicolon, the two lines together may be parsed instead as the multiplicative operator. For example, if the regexp has flags 2, 1, 0, 3, two cases of automatic semicolon insertion and no line terminator here. This section is non-normative. ECMAScript contains grammar productions which include no line terminator here. These productions are sometimes a means to have optional operands in the grammar. Introducing a line terminator in these locations would change the grammar production of a source text by using the grammar production without the optional operand. The rest of this section describes a number of productions using no line terminator here in this version of ECMAScript 2.1.0.3.2. One list of grammar productions with optional operands and no line terminator here. Update expression, continue statement, break statement, return statement, yield expression, async function definitions, 15.8, with relation to function definitions, 15.2. 42. ECMA International 2024. 13 ECMAScript language. Expressions. 3.1 Identifiers syntax. Identifier reference. Yield. Await. Identifier. Yield. Yield. Await. Await. Binding identifier. Yield. Await. Identifier. Yield. Await. Label identifier. Yield. Await. Identifier. Yield. Yield. Await. Await. Identifier. Identifier name but not reserved word. 3. 1. 1 Static semantics. Early errors. Binding identifier. Identifier. It is a syntax error if the source text matched by this production is contained in strict mode code and the string value of identifier is either arguments or eval. Identifier reference. Yield binding identifier. Yield label identifier. Yield. It is a syntax error if the source text matched by this production is contained in strict mode code. Identifier reference. Await binding identifier. Await label identifier. Await. It is a syntax error if the goal symbol of the syntactic grammar is module. Binding identifier. Yield. Await. Yield. It is a syntax error if this production has a yield parameter. Binding identifier. Yield. Await. Await. ECMA International 2024 243. Yield and await are permitted as binding identifier in the grammar and prohibited with static. Note, semantics below. To prohibit automatic semicolon insertion in cases such as let await 0, it is a syntax error if this production has an await parameter. Identifier reference. Yield. Await. Identifier binding identifier. Yield. Await. Identifier label identifier. Yield. Await. Identifier. It is a syntax error if this production has a yield parameter and string value of identifier as yield. It is a syntax error if this production has an await parameter and string value of identifier as await. Identifier. Identifier name but not reserved word. It is a syntax error if this phrase is contained in strict mode code and the string value of identifier name is one of implements, interface, let, package, private, protected, public, static, or yield. It is a syntax error if the goal symbol of the syntactic grammar is module and the string value of identifier name is await. It is a syntax error if the string value of identifier name is the string value of any reserved word except for yield or await. 3. 1. 2. Static semantics. String value. The syntax-directed operation string value takes no arguments and returns a string. It is defined piecewise over the following productions: identifier name, identifier start, identifier name, identifier part. Let id text unescape be identifier code points of identifier name, return code points to string, id text unescaped, identifier reference, yield binding identifier, yield label identifier, yield, return yield, identifier reference, await binding identifier, await label identifier, await, return await, identifier, identifier name but not reserved word, return the string value of identifier name, private identifier, identifier name, return the string concatenation of 0 times 0023, number sign, and the string value of identifier name, module export name, string literal 1. Return the SV of string literal. Note string value of identifier name normalizes any Unicode escape sequences in identifier name, hence such escapes cannot be used to write an identifier whose code point sequence is the same as a reserved word. 44. ECMA International 2024 131. 3. Runtime semantics. Evaluation. Identifier reference. Identifier. Return. Resolve binding. String value of identifier. Identifier reference. Yield. Return. Resolve binding. Yield. Identifier reference. Await. Return. Resolve binding. Await. Note 1. The result of evaluating an identifier reference is always a value of type reference. 3.2 Primary expression syntax. Primary expression. Yield. Await. This identifier reference yield await. Literal. Array literal yield await. Object literal yield await. Function expression. Class expression yield await. Generator expression. Async functio. N expression. Async generator expression. Regular expression literal. Template literal yield await. Tagged. Capital C O V E R. Capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N, yield await, capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N, yield await, expression plus in yield await, expression plus in yield await, dot, binding identifier yield await, dot, binding pattern yield await, expression plus in yield await, binding identifier yield await, expression plus in yield await, binding pattern yield await. Note 2. In non-strict code, the keyword yield may be used as an identifier. Evaluating the identifier reference resolves the binding of yield as if it was an identifier. Early error restriction ensures that such an evaluation only can occur for non-strict code. ECMA International 2024 245. Supplemental syntax. When processing an instance of the production, primary expression, yield, await, capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N, yield await. The interpretation of capital C O V E R, capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N is refined using the following grammar. Parenthesized expression yield await expression plus in yield await 3 2 1 ethis keyword 3 2 1 runtime semantics evaluation primary expression this return resolve this binding 3 2 identifier reference C13.1 for identifier reference 1 3 2 3 literals syntax literal null literal boolean literal numeric literal string literal 3 2 3 1 runtime semantics evaluation literal null literal 1 return null literal boolean literal if boolean literal is the token false return false if boolean literal is the token true return true literal numeric literal return the numeric value of numeric literal as defined in 1 2 9 3 literal string literal return the SV of string literal as defined in 1 2 9 4 2 46 ECMA International 2024 1 3 2 4 array initializer array elements may be elided at the beginning middle or end of the element list whenever a comma in the element list is not preceded by an assignment expression, that is, a comma at the beginning or after another comma. The missing array element contributes to the length of the array and increases the index of subsequent elements. Elided array elements are not defined. If an element is elided at the end of an array, that element does not contribute to the length of the array. Syntax array literal yield await elision ought element list yield await element list yield await elision ought element list yield await elision ought assignment expression plus in yield await elision ought spread element yield await element list yield await elision ought assignment expression plus in yield await element list yield await elision ought spread element yield await elision spread element yield await dot assignment expression plus in yield await 1 3 2 4 1 runtime semantics array accumulation the syntax directed operation array accumulation takes arguments array and next int x an integer and returns either a normal completion containing an integer or an abrupt completion. It is defined piecewise over the following productions. Elision let len be next index plus 1 perform set array length len true note the above step throws if len exceeds 232 1 return len elision return array accumulation of elision with arguments array and next index plus 1 element list elision ought assignment expression if elision is present then a set next index 2 array accumulation of elision with arguments array and next index let init result be evaluation of assignment expression let init value be get value init result perform create data property or throw array to string next int x init value return next index plus 1 note an array literal is an expression describing the initialization of an array using a list of 0 or more expressions each of which represents an array element enclosed in square brackets. The elements need not be literals. They are evaluated each time the array initializer is evaluated. ECMA International 2024 247 element list elision ought spread element if elision is present then a set next index 2 array accumulation of elision with arguments array and next index return array accumulation of spread element with arguments array and next index element list elision ought assignment expression set next index 2 array accumulation of element list with arguments array and next index if elision is present then a set next index 2 array accumulation of elision with arguments array and next index let init result be evaluation of assignment expression
builds and it caught the warning, whatever. So it's being included. So I set the warning so it would throw it so I could see if it catches it. I should have just let it build and run, check the log out. Because now I gotta turn off the warning, run it, then check the log out. So I'll do that then, and see if it enters this block or module, whatever, of this file. It's included. I might have to like go to a Windows 7 backup and find the original project. I literally just need like a couple macros. I'm gonna like look through these files again. I don't think it's in here. It's not. It's already been a couple hours. I'm gonna have to dig through an old hard drive to find some stuff. I need to just test this and get to the types. I saved a backup earlier. I'll save another backup. Never hurts. No, I'll run it again. I'll check if it's logging, because it caught the preprocessor error message that I set to catch it. So I know it enters this file at least, but some of the stuff is wrapped in if statements, so I don't know. It should enter here because it's at the bottom after all the ifs before the return. I don't know. Instead of stalling and talking, instead of just doing something, I'm gonna save it back up, rebuild it, try to find the file I'm looking for. If it's not in here, I'm gonna have to go to Windows 7 backup and dig through some old code. So I'm gonna do that and step up. This computer gets laggier every time I copy files. I do not understand what it's doing. Is it like Windows caching a copy of the whole thing copied? And keeping track of it or something, and then dumping in a restart? Because why the fuck does the computer get laggier every time I copy some files? And the bigger the copy, the laggier Windows gets. I have no idea. There's nothing plugged in to this computer. It's not on the internet. I have the HDMI. Oh, fuck this shit. I have to close it. I have a HDMI plugged in, but then I pass that to a HDMI to a component or analog, whatever. And I have another adapter that converts the analog back to HDMI. So there's no back and forth connection between my computer that I'm working on and the one that I'm streaming on, or the other computer, or the other computer. this computer's has no connection to anything other than keyboard, plug-in, keyboard, mouse, and HDMI or DisplayPort. I don't know what the fuck Windows is doing. There's something wrong with this Windows install. It's probably this hard drive. I should have used the Samsung. It's really funky. I don't know. I gotta save it backup again. It's to work. Have the program open. I just need to find a couple stupid files. And then I'm good. Really hoping it's not gonna get stuck. Please do not. It worked. I don't want to deal with this god-forsaken compiler and its bugs today, and like locking up folders and files and breaking stuff. I don't want to deal with it at all. Like, I never want to deal with it. I think chatbot, or not chatbot, Siri ran out of stuff to read.
Element list. Elision or spread element. If elision is present, then a set next.
I need to turn on music, focus.
Calculation of spread element with arguments array and next index. Element list. Element list. Elision or assignment expression. Set next index 2. Array accumulation of element list with arguments array and next index. If elision is present, then a set next index 2. Array accumulation of elision with arguments array and next index. Let init result be. Evaluation of assignment expression. Let init value be. Get value. Init result. Perform. Create data property or throw. Array. To string. Next int x. Init value. Return next index +1. Element list. Element list. Elision or spread element. Set next index 2. Array accumulation of element list with arguments array and next index. If elision is present, then a set next index 2. Array accumulation of elision with arguments array and next index 3. Return. Array accumulation of spread element with argument. Spread element. Assignment expression. Let spread expression. Let spread obj be. Let next be. Next is done. Return next index. See perform. Create data property or throw. To string. Next int x.
Is the mic working now? I don't know. I gotta find some files. The stupid push to talk button is broken. And my keypad. That's breaking too. I'll click the button on the knob that twists to go left and right, and it's wobbly. I need to get a new one. I need to stop being distracted.
Literal. Element list. Let array be. Array create. 0. Perform. Array accumulation of element list with arguments array in 0. Return array. Array literal. Element list. Elision naught. 2. Let array be. Array create. 0. Let next index be. Array accumulation of element list with arguments array in 0. 48. ECMA International 2024. 3. If elision is present, then a perform. Array accumulation of elision with arguments array and next index. Return array. 3. 2. 5. Object initializer. Syntax. Object literal. Yield. Await. Property definition list yield await. Property definition list yield await. Property definition list. Yield. Await. Property definition yield await. Property definition list yield await. Property definition yield await. Property definition. Yield. Await. Identifier reference yield await. Cover initialized name yield await. Property name yield await. Assignment expression. Plus in yield await. Method definition yield await. Dart. Assignment expression. Plus in yield await. Property name. Yield. Await. Literal property name. Computed property name yield await. Literal property name. Identifier name. String literal numeric literal. Computed property name. Yield. Await. Assignment expression. Plus in yield await. Cover initialized name. Yield. Await. Identifier reference yield await. Initializer. Plus in yield await. Initializer. In. Yield. Await. Assignment expression in yield await. Note 2 method definition is defined in 15.4. Note 1 an object initializer is an expression describing the initialization of an object, written in a form resembling a literal. It is a list of 0 or more pairs of property keys and associated values, enclosed in curly brackets. The values need not be literals. They are evaluated each time the object initializer is evaluated. Copyright sign. ECMA International 2024 249. Note 3 in certain contexts. Object literal is used as a cover grammar for a more restricted secondary grammar. The cover initialized name production is necessary to fully cover these secondary grammars. However, use of this production results in an early syntax error in normal contexts where an actual object literal is expected. 3, 2, 5, 1 static semantics. Early errors. Property definition. Method definition. Bullet. It is a syntax error if has direct super of method definition is true. It is a syntax error if private bound identifiers of method definition is not empty. In. Used as a cover grammar for object assignment pattern and may be recognized as part of a capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N. When object literal appears where object assignment pattern is required, the following early error rules are.
So, in the logout, whatever, it's being included, but it's not printing. So I gotta like figure out what's being included, or the if else that wraps in whatever file that calls this file, or includes this file. Enter whatever on, so we'll enter to print this crap. I'm gonna try to find the control flow in on the backups from Windows 7. Unless I can find, I'm gonna find so many files. I just gotta find it somewhere. I find it, and I gotta figure out where to place this test stuff without breaking some of the other test stuff, because there's like a whole like initialization part, and I don't, if I break it, it messes up other stuff. I have to go through and like turn off parts that aren't part of the setup to get it running. And that'll take a little bit of time. What I need to do is just get this in place, get it to run, test it, finish converting it to 64-bit, and then deal with modifying the build, figuring out what modules aren't needed, and which ones are, because there's like a ton of layers of stuff. So I already saved it back up, I ran, it just doesn't print, this file is included. So I'll make like another function maybe to call this stuff, be sure it prints, and I'll convert this thing. I have part of it converted. I just need the control flow macros. I'm going to try to find those, and after that, test it. Then I gotta get the rest of the int types, check whatever, make sure there's none left, and then it's a 64-bit address arithmetic or whatever. That's all that's left. After that, it's a 64 program. Except I do have to, after that, find where things are or need to be truncated on purpose to 4 instead of 8, because I use 4 as a magic number, and I like inlined it, and I just kind of relied on things being 4 as the scale multiple. And now that's not true, because it's 8, so the magic number, if you use 8 for everything, some memory structures will be bloated, some won't work, or be able to access beyond 4 because it's hard-coded to 4. So I gotta do that stuff after I convert it. First I gotta find the control flow macros. This build is going to back up, so I'm gonna find those. Hey, stop talking. I don't know.
Either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions: property definition list, property definition list, property definition, perform, property definition evaluation of property definition list with argument object, perform, property definition evaluation of property definition with argument object, return unused, ECMA International 2024 251, property definition, assignment expression, let x per value be, evaluation of assignment expression, let from value be, get value, x per value, let excluded names be a new empty list, perform, copy data properties, object, from value, excluded names, return unused, property definition, identifier reference, let prop name be string value of identifier reference, let x per value be, evaluation of identifier reference, let prop value be, get value, x per value, assert, object is an ordinary, extensible object with no non-configurable properties, perform, create data property or throw, object, prop name, prop value, return unused, property definition, property name, assignment expression, let prop key be, evaluation of property name, if this property definition is contained within a script that is being evaluated for JSON parse. See step 7 of JSON parse. Then, a let is proto set to be false, else if prop key is proto and is computed property key of property name is false. Then a let is proto set to be true, else a let is proto set to be false, if is anonymous function definition, assignment expression, is true and is proto setter is false. Then a let prop value be. Named evaluation of assignment expression with argument prop key, else a let x per value ref be. Evaluation of assignment expression be let prop value be. Get value, x per value ref, if is proto setter is true. Then, if prop value is an object or prop value is null, then I perform object, prop value be return unused, assert, object is an ordinary, extensible, object with no non-configurable properties. Perform. Create data property or throw, object, prop key, proper value, 0. Return unused. Property definition. Method definition. Perform. Method definition. Evaluation of method definition with arguments, object and true. Return unused. 3, 2, 6. Function defining expressions. See 15.2 for primary expression. Function expression. See 15.5 for primary expression. Generator expression. See 15.7 for primary expression. Class expression. See 15.8 for primary expression. Async function expression. See 15.6 for primary expression. Async generator expression. 52. Copyright sign. ECMA International 2024. 132. 7. Regular expression literal syntax. C12. 9. 5. 3. 2. 7. 1. Static semantics. Early errors. Primary expression. Regular expression literal. It is a syntax error if capital I, S, capital V, A, L, I, D, capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital L, I, T, E, R, A, regular expression literal, is false. 3, 2, 7. 2. Static semantics. Capital I, S, capital V, A, L, I, D, capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital L, I, T, E, R, A, literal. The abstract operation. Capital I, S, capital V, A, L, I, D, capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital L, I, T, E, R, A, takes argument literal, a regular expression literal parse node, and returns a boolean. It determines if its argument is a valid regular expression literal. It performs the following steps when called. Let flags be flag text of literal. If flags contains any code points other than D, G, I, M, S, U, V, or Y, or if flags contains any code point more than once, return false. If flags contains U, let U be true, else let U be false. If flags contains V, let V be true, else let V be false. Let pattern text be body text of literal. If U is false and V is false, then a let string value be code points to string pattern text. B set pattern text to the sequence of code points resulting from interpreting each of the 16-bit elements of string value as a Unicode BMP code point. UTF-16 decoding is not applied to the elements. Let parse result be parse pattern text U, V. If parse result is a parse node, return true, else return false. 3, 2, 7, 3. Runtime semantics. Evaluation primary expression, regular expression literal. Let pattern be code points to string, body text of regular expression literal. Let flags be code POI, NTS to string, flag text of regular expression literal. Return. regexp create, pattern, flags. 3, 2, 8. Template literal syntax. Template literal. Yield. Await. Tagged. No substitution template. Substitution template yield await tagged. Substitution template. Yield. Await. Tagged. Template head expression. Plus in yield await. Template spans yield await tagged. Template spans. Yield. Await. Tagged. Template tail. Template middle list yield await tagged. Template tail. ECMA International 2024 253. Template middle list. Yield. Await. Tagged. Template middle expression. Plus in yield await. Template middle list yield await tagged. template middle expression, plus in yield await. 3, 2, 8, 1 static semantics, early errors, template literal, yield, await, tagged, no substitution template. It is a syntax error if the tagged parameter was not set and no substitution template contains not escape sequence, template literal, yield, await, tagged, substitution template yield await tagged. It is a syntax error if the number of elements in the result of template strings of template literal with argument force is greater than or equal to 232. Substitution template, yield, await, tagged, template head expression, plus in yield await, template spans yield await tagged. It is a syntax error if the tagged parameter was not set and template head contains not escape sequence. Template spans, yield, await, tagged, template tail. It is a syntax error if the tagged parameter was not set and template tail contains not escape sequence. Template middle list, yield, await, tagged, template middle expression, plus in yield await, template middle list yield await tagged, template middle expression, plus in yield await. It is a syntax error if the tagged parameter was not set and template middle contains not escape sequence. 3, 2, 8, to static semantics, template strings. The syntax directed operation template strings takes argument draw, a boolean, and returns a list of either strings or undefined. It is defined piecewise over the following productions. Template literal, no substitution template. Return template string, no substitution template, raw. Substitution template, template head expression template spans. Let head be template string, template head, raw. Let tail be template strings of template spans with argument draw. Return the list concatenation of head and tail. Template spans, template tail. Return template string, template tail, raw. Template spans, template middle list template tail. Let middle be template strings of template middle list with argument draw. Let tail be template string, template tail, raw. Return the list concatenation of middle and tail. 54. ECMA International 2024. Template middle list, template middle expression 1. Return template string, template middle, raw. Template middle list, template middle list template middle expression. Let front be template strings of template middle list with argument raw. Let last be template string, template middle, raw. Return the list concatenation of front and last. 3, 2, 8, 3 static semantics, template string, template token, raw. The abstract operation template string takes arguments template token, a no substitution template parse node, a template head parse node, a template middle parse node, or a template tail parse node, and raw, a boolean, and returns a string or undefined. It performs the following steps when called. If raw is true, then a let string be the TRV of template token, else a let string be the TV of template token. Return string. 3, 2, 8, 4 get template object, template literal. The abstract operation get template object takes argument template literal, a parse node, and returns an array. It performs the following steps when called. Let realm be the current realm record. Let template registry be realm. For each element of template registry, do if E is the same parse node as template literal, then I return E. Let raw strings be template strings of template literal with argument true. Assert raw strings is a list of strings. Let cook strings be template strings of template literal with argument false. Let count be the number of elements in the list cook strings. Assert count 232 1. Let template be array create count 0. Let raw obj be array create count 1. Let index be 0 2. Repeat while index count a let prop be to string index b. Let cooked value be cooked strings index c. Perform define property or throw template prop property descriptor cooked value writable false true false d. Let raw value be the string value raw strings index e. Perform define property or throw raw obj prop property descriptor raw value false true false f. Set index to index plus 1 3. Perform Set integrity level, raw obj, frozen 4. Perform. Define property or throw, template, raw, property descriptor, raw obj, false, enumerable, false, false 5. Perform. Set integrity level, template, frozen 6. Append the record, template literal, template, to realm 7. Return template. Note this operation returns undefined if raw is false and template token contains a not escape sequence. In all other cases, it returns a string. ECMA International 2024 255. Note 1. The creation of a template object cannot result in an abrupt completion. Note 2. Each template literal in the program code of a realm is associated with a unique template object that is used in the evaluation of tagged templates. 1, 3, 2, 8, 6. The template objects are frozen and the same template object is used each time a specific tag template is evaluated. Whether template objects are created lazily upon first evaluation of template literal or eagerly prior to first evaluation is an implementation choice that is not observable to ECMAScript code. 1, 3, 2, 8, 5. Runtime semantics. Substitution evaluation. The syntax-directed operation substitution evaluation takes no arguments and returns either a normal completion containing a list of ECMAScript language values or an abrupt completion. It is defined piecewise over the following productions. Template spans.
In the modern, I don't know. I guess the modern way to program is to use an IDE. I don't know why this is so modern. It's stupid. It doesn't save any time. But, well, it does if you're programming in a shit language with a bunch of like API calls and it's just you're programming in hell, then an IDE makes sense. But on the modern operating system, when you're writing a program, even if you're using IDE to write your program, like Visual Studio, it doesn't matter if it has a context menu, it has a pop-up, if it can like give you a little description of this call, its arguments, what it takes and stuff. None of that helps. When you give something a name, like if you make a type called var, if it's a lowercase, that means that's what var is. You can't define another type, lowercase, var, to use globally across any other place where you want it, unless it's a global, and then it's global, and you can't like differentiate easily. Anything is possible, actually. What I'm getting at though is after you use var, you have to get like creative. So maybe you need another type of var. So you do like capital V AR, so it's not all lowercase, and you do like lowercase v and then uppercase AR. And then when you run out of like combinations of letters, you get to the point where you're like, oh, I need to make a variable type. I'll call it v for f, r. So you spell var with a number, the number 4 instead of a. So I think I'm closer to finding like the code that I'm looking for. I was in like some of the older macros. I have to sort this stuff out. I found my way to the newer macros. So somewhere in these new macros where I spelled var is v for r for var is what I'm looking for. I think I'm close to finding it. It's taking so much time. This is not the modern. Nothing about the modern operating system is modern. It's a bunch of bullshit. I'm gonna get back to finding some shit instead of complaining. Because maybe one day something modern will come out. Who knows? If it did, it'd be better than this.
I Z E D capital E X P R E S S I O N capital A N must cover a parenthesized expression. 3, 2, 9. To runtime semantics evaluation primary expression capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N. Let expa be the parenthesized expression that is covered by capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N. Return evaluation of expa parenthesized expression return evaluation of expression. This may be of type reference. Note to the string conversion semantics applied to the expression value like string prototype concat rather than the plus operator. Note 3 the string conversion semantics applied to the expression value like string prototype concat rather than the plus operator. Note this algorithm does not apply get value to evaluation of expression. The principal motivation for this is so that operators such as delete and type off may be applied to parenthesized expressions. ECMA International 2024 257 13.3 left-hand side expressions syntax. Member expression yield await. Primary expression yield await. Member expression yield await. Expression plus in yield await. Member expression yield await. Identifier name member expression yield await. Template literal yield await plus tagged super property yield await meter property new member expression yield await arguments yield await member expression yield await private identifier super property yield await super expression plus in yield await super identifier name meter property new target import meter new target import meter import meta new expression yield await member expression yield await new expression yield await call expression yield await capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R yield await super call yield await import call yield await call expression yield await arguments yield await call expression yield await expression plus in yield await call expression yield await identifier name call expression yield await template literal yield await plus tagged call expression yield await private identifier super call yield await super arguments yield await import call yield await import assignment expression plus in yield await arguments yield await argument list yield await argument list yield await 58 ECMA International 2024 argument list yield await assignment expression plus in yield await dart assignment expression plus in yield await argument list yield await assignment expression plus in yield await argument list yield await assignment expression plus in yield await optional expression yield await member expression yield await optional chain yield await call expression yield await optional chain yield await Optional expression you.
I think I might need to find an older version of Sublime Text. It has some fucking bugs in this new version, and it's pissing me off now. It's mixing up characters when I do find. It's highlighting things that are visibly even. They're not the same fucking character, but they're being highlighted. I could totally replace the wrong thing while I'm trying to find and replace things. And fuck up a ton of shit. I have to go, I'm gonna go Google on my phone whatever the fuck's going on. Something's wrong with, I don't know. There's something with Sublime Text. I might need to get like Sublime Text 2. I think this is 4. Something's wrong with this fucking text editor. I could have fucked stuff up already now that I realized it's doing this. Like, it was being weird, but I didn't get it. And now I'm like doing Control F on some characters. And the encoding, like, it overlaps with other characters that are completely different characters. They're not a match, but somehow they're showing up as a match. I have to go to Google and think. I'm gonna have to like reopen all these fucking windows again. So I have to install this again. And then I might even install. When you install this program, it goes to like the C programs, but it also goes to like app data / user / hidden, whatever the fuck it is. And like if you try to like downgrade to an old one, it's named Sublime Text 4, even though you downgraded to Sublime Text 2. I gotta go think. Maybe there's like a setting in preferences, because I don't know. It's never done this before. I had Sublime Text, is this 3 or 4? I don't know, I had 3. It wasn't doing this. I never had Sublime Text 4.
Syntactic conversion. Member expression. Identifier name is identical in its behavior to member expression, identifier name string, and similarly, call expression. Identifier name is identical in its behavior to call expression, identifier name string, where identifier name string is the result of evaluating string value of identifier name 3, 3, 2, 1 runtime semantics, evaluation, member expression, expression, let base reference be. Evaluation of member expression, let base value be. Get value, base reference. If the source text matched by this member expression is strict mode code, let strict be true, else let strict be false. Return. Capital E, V, A, L, U, A, T, E, capital P, R, O, P, E, R, T, Y, capital A, C, C, E, S, S, capital W, I, T, H, capital.
It says, I think build 4.192 possibly means version 4.
Value B. Get value, base reference. If the source text matched by this member expression is strict mode code, let strict be true, else let strict be false. Return. Capital E, V, A, L, U A T E, capital P R O P E R T Y.
Fuck. I gotta go think. Fucking pissed off. Fuck this program. I'll be back.
B. Get value, base reference. Let field name string be the string value of private identifier. Return make private reference. Base value, field name string. Call expression, expression. Let base reference be. Evaluation of call expression. Let base value be. Get value, base reference. If the source text matched by this call expression is strict mode code, let strict be true, else let strict be false. Return. Capital E V A L U A T E, capital P R O P E R T Y, capital A C C E S S, capital W I T H, capital E X P R. Base value, expression, strict. Call expression, identifier name. Let base reference be. Evaluation of call expression. Let base value be. Get value, base reference. If the source text matched by this call expression is strict mode code, let strict be true, else let strict be false. Return. Capital E V A L U A T E, capital P R O P E R T Y, capital A C C E S S, capital W I T H, capital I D E N. Base value, identifier name, strict. Call expression, private identifier. Let base reference be. Evaluation of call expression. Let base value be. Get value, base reference. Let field name string be the string value of private identifier. Return make private reference. Base value, field name string. 3, 3, 3, capital E V A L U A T E, capital P R O P E R T Y, capital A C C E S S, capital W I T H, capital E X P R. Base value, expression, strict. The abstract operation, capital E V A L U A T E, capital P R O P E R T Y, capital A C C E S S, capital W I T H, capital E X P R, takes arguments base value, an ECMAScript language value, expression, an expression parse node, and strict, a boolean, and returns either a normal completion containing a reference record or an abrupt completion. It performs the following steps when called. Let property name reference be. Evaluation of expression. Let property name value be. Get value, property name reference. Let property key be. To property key, property name value. Return the reference record. Base value, property key, strict. This value, empty. 3, 3, 4, capital E V A L U A T E, capital P R O P E R T Y, capital A C C E S S, capital W I T H, capital I D E N. Base value, identifier name, strict. The abstract operation, capital E, V, A, L, U, A, T, E, capital P, R, O, P, E, R, T, Y, capital A, C, C, E, S, S, capital W, I, T, H, capital I, D, E, N, takes arguments base value, an ECMAScript language value, identifier name, an identifier name parse node, and strict, a boolean, and returns a reference record. It performs the following steps when called. Let property name string be string value of identifier name, return the reference record. Base value, property name string, strict, empty. ECMA International 2024 261 133 5 Then new operator 3 3 5 1 runtime semantics evaluation new expression new expression return evaluate new expression empty member expression new member expression arguments 1 return evaluate new member expression arguments 3 3 5 1 1 evaluate new construct expa arguments. The abstract operation evaluate new takes arguments construct expa, a new expression parse node or remember expression parse node, and arguments, empty or an arguments parse node, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It performs the following steps when called. Let ref be. Evaluation of construct expa. Let constructor be. Get value. Ref. If arguments is empty, then a let arglist be a new empty list for. Else a let arglist be. Argument list evaluation of arguments. If is constructor is false. Throw a type error exception. Return. Constructor arglist. 3 3 6 function calls. 3 3 6 1 runtime semantics evaluation call expression capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R. Let expa be the call member expression that is covered by capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R. Let member expa be the member expression of expa. Let arguments be the arguments of expa. Let ref be. Evaluation of member expa. Let func be. Get value. Ref. If ref is a reference record, is property reference, ref is false, and ref is eval, then if same value, func, %eval% is true, then I let arglist be. Argument list evaluation of arguments. 2. If arglist has no elements, return undefined. 3. Let eval arg be the first element of arglist. 5. If the source text matched by this call expression is strict mode code, let strict caller be true, otherwise let strict caller be false. V return. Perform eval arg, strict caller, true. Let this call be this call expression. Let tail call be as in tail position. This call return. Evaluate call. Func. Ref. Arguments. Tail call. A call expression evaluation that executes step 6 AV is a direct eval. Call expression arguments. Let ref be. Evaluation of call expression. Let func be. Get value. Ref. Let this call be this call expression. Let tail call be as in tail position. This call return. Evaluate call. Func. Ref. Arguments. Tail call. 62. ECMA International 2024 133 6 2. Evaluate call. Func. Ref. Arguments. Tail position. The abstract operation evaluate call takes arguments func. An ECMAScript language value. Ref. An ECMAScript language value or a reference record. Arguments. A parse node. And tail position. A boolean. And returns either a normal completion containing an ECMAScript language value or an abrupt completion. It performs the following steps when called. If ref is a reference record, then if is property reference, ref, is true, then I let this value be get this value, ref be else I let ref env be ref. 2. Assert, ref env is an environment record. 3. Let this value be ref env with base object, else let this value be undefined. Let arglist be. Argument list evaluation of arguments. If func is not an object, throw a type error exception. If is callable, func is false. Throw a type error exception. If tail position is true, perform prepare for tail call. Return. Call, func. This value, arglist. 3. 7th SOP keyword. 3. 7. 1 runtime. Semantics. Evaluation super property. Super. Expression. Let env be get this environment. Let actual this be env get this binding. Let property name reference be. Evaluation of expression. Let property name value be. Get value. Property name reference. Let property key be. To property key. Property name value. If the source text matched by the super property is strict mode code, let strict be true, else let strict be false. Return. Make super property reference. Actual this. Property key. Strict. Super property. Super. Identify a name. Let env be get this environment. Let actual this be env get this binding. Let property key be string value of identify name. If the source text matched by the super property is strict mode code, let strict be true, else let strict be false. Return. Make super property reference. Actual this. Property key. Strict. Super call. Super arguments. Let new target be get new target. Assert. New target is an object. Let func be get super constructor. Let arglist be. Argument list evaluation of arguments. If is constructor, func, is false, throw a type error exception. Let result be. Construct, func, arglist, new target. Let the ser be get this environment. Perform the ser bind this value. Result. Let f be the ser. 0. Assert. F is an ECMAScript function object. 1. Perform. Initialize instance elements. Result. F. 2. Return result. ECMA International 2024 263 1337. To get superconstructor. The abstract operation get superconstructor takes no arguments and returns an ECMAScript language value. It performs the following steps when called. Let envrec be get this environment. Assert. envrec is a function environment record. Let active function be envrec. Assert. Active function is an ECMAScript function object. Let superconstructor be active function. Return superconstructor. 7. 3 make super property reference. Actual this. Property key. Strict. The abstract operation make super property reference takes arguments actual this. An ECMAScript language value. Property key. A property key, and strict, a boolean, and returns either a normal completion containing a super reference record or a throw completion. It performs the following steps when called. Let env be get this environment. Assert. env has super binding, is true. Let base value be env get super base. Return the reference record. Base value, property key, strict. This value, actual this. 3. 8 argument lists. Note the evaluation of an argument list produces a list of values 1 3 8. 1 runtime semantics. Argument list evaluation. The syntax-directed operation argument list evaluation takes no arguments and returns either a normal completion containing a list of ECMAScript language values or an abrupt completion. It is defined piecewise over the following product. Shines. Arguments. Return a new empty list. Argument list. Assignment expression. Let ref be. Evaluation of assignment expression. Let arg be. Get value. Ref. Return arg. Argument list. Assignment expression. Let list be a new empty list. Let spread ref be. Evaluation of assignment expression. Let spread obj be. Get value. Spread ref. Let iterator record be. Get iterator. Spread obj. Sync. Repeat. Let next be. Iterator step value. Iterator record. Be if next is done. Return list. See append next to list. Argument list. Argument list. Assignment expression. 1. 2. Let preceding args be. Argument list. Evaluation of argument list. Let ref be. Evaluation of assignment expression. 64. ECMA International 2024. 3. Let arg be. Get value. Ref. Return the list concatenation of preceding args and arg. Argument list. Argument list. Assignment expression. Let preceding args be. Argument list. Evaluation of argument list. Let spread ref be. Evaluation of assignment expression. Let iterator record be. Get iterator. Get value. Spread ref. Sync. Repeat. Let next be. Iterator step value. Iterator record. Be if next is done. Return preceding args. See append next to preceding args. Template literal. No substitution template. Let template literal be this template literal. Let site obj be get template object. Template literal. Return site obj. Template literal. Substitution template. Let template literal be this template literal. Let site obj be get template object. Template literal. Let remaining be. Argument list. Evaluation of substitution template. Return the list concatenation of site obj and remaining. Substitution template. Template head expression. Template spans. Let first subref be. Evaluation of expression. Let first sub be. Get value. First subref. Let rest sub be. Substitution. Evaluation of template spans. Assert. Rest sub is a possibly empty list. Return the list concatenation of first sub and rest sub. 3. 9 optional chains. 3. 9. 1 runtime semantics. Evaluation. Optional expression. Member expression. Optional chain. Let base reference be. Evaluation of member expression. Let base value be. Get value. Base reference. If base value is either undefined or null, then a return undefined. Return. Chain. Evaluation of optional chain with arguments base value and base reference. Optional expression. Call expression. Optional chain. Let base reference be. Evaluation of call expression. Let base value be. Get value. Base reference. If base value is either undefined or null, then a return undefined. Return. Chain. Evaluation of optional chain with arguments base value and base reference. Note an optional chain is a chain of one or more property accesses and function calls, the first of which begins with the token ECMA International 2024 265. Optional expression. Optional expression. Optional chain. Let base reference be. Evaluatio n of optional expression. Let base value be. Get value. Base reference. If base value is either undefined or null, then a return undefined. Return. Chain. Evaluation of optional chain with arguments base value and base reference. 3. 9. 2 runtime semantics. Chain evaluation. The syntax-directed operation chain evaluation takes arguments base value, an ECMAScript language value, and base reference, an ECMAScript language value or a reference record, and returns either a normal completion containing either an ECMAScript language value or a reference record, or an abrupt completion. It is defined piecewise over the following productions. Optional chain. Arguments. Let this chain be this optional chain. Let tail call be as in tail position. This chain. Return. Evaluate call. Base value. Base reference. Arguments. Tail call. Optional chain. Expression. If the source text matched by this optional chain is strict mode code, let strict be true, else let strict be false. Return. Capital E V A L U A T E, capital P R O P E R T Y, capital A C C E S S, capital W I T H, capital E X P R. Base value. Expression. Strict optional chain. Identifier name. If the source text matched by this optional chain is strict mode code, let strict be true, else let strict be false. Return capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital I D E N. Base value. Identifier name. Strict optional chain. Private identifier. Let field name string be the string value of private.
What I'm trying to do is find some macros that are for the control flow. Parts like if, else, and stuff. Because there's a block scope, there's a bunch of stuff tied to it. I don't know. Something's off with this text editor. I don't know if it's the Python version. It could be a Windows 11 update or something that changed. But if I do Control F on the letter U, there's a U with an accent or whatever that I spelled for null because I want to spell null with a character that's not the normal U, so I use U with an accent. And when I do Control F on U, like a normal U, it finds the one with the accent also. But it's a different character encoding. It's completely different. It's not supposed to find both of them. And then there's some other characters that are different letters even, and they're matching when I do find. So this might not even be a Sublime thing. It's something with the character encoding that is never done before. All I replaced was the type names so far. I did mass replace a couple things to make it so I could find them easier with a different name. And they didn't have like tricky characters or whatever that I used in place of another letter. So I don't think currently, I'm pretty certain I didn't break anything yet with the characters or whatever. Nothing's mingled yet. But I can't do Control F to find and replace at all now with some of the character like exceptions I used on purpose. I don't have 2-3 hours to like uninstall Sublime, install the older version, check if it works, and then possibly find out that it does the same thing again. And then like install Python runtime again, I don't have time to check Windows, figure out what the fuck it's doing. I'm gonna just remember this for later and try to find the one fucking thing that I set out to do. Everything is shit. I have one thing I'm trying to do, and as I'm trying to do it, all this random shit and fucking crap, because I don't know. It doesn't matter if it's modern. Even the ancient tech sucked. Not the tech, but the software too. This is just crap. It's a bunch of shit. So I'm gonna wait on messing with figuring out whatever the fuck is different with this install, because it's being weird with finding characters and stuff. All I want is to find a couple macros. So I'm gonna do that. I'm gonna get this stupid test. I'm gonna get to the types. I'm gonna convert to 64-bit. And then I'm gonna have to maybe do this. Figure out the text editor. Before I do the OpenGL stuff, because what do I call it? Mango is a check that it's been control search. I don't know. So I'm gonna have to do that, whatever, figure out whatever the fuck is going on with the text editor, if it is even the text editor. And I'm gonna do OpenGL, make a demo, whatever. So I'm gonna continue on this so I can finish this today, which I won't be able to do if I keep finding other little things that just aren't working that I have to deal with. So I'm so annoyed. I'm just gonna get back to finding some stupid macros.
Template literal. Till call expression template literal. Let tag ref be. Evaluation of call expression. Let tag func be. Get value. Tag ref. Let this call be this call expression. Let till call be as in tail position. This call. Return. Evaluate call. Tag func. Tag ref. Template literal. Till call. The 3rd of March 2012 meta properties. 3. 3. 1 2. 1 runtime semantics. Evaluation. New target. New target 1. Return get new target. Import meter. Import meta. Let module be get active script or module. Assert. Module is a source text module record. Let import meter be module. If import meter is empty, then A set import meter to ordinary object create. Null. B let import meter values be host get import meter properties. Module. C for each record. P of import meter values. Do. I perform. Create data property or throw. Import meter. P. D perform host finalize import meter. Import meter. Module. E set module to import meter. F return import meter. Else. A assert. Import meter is an object. P return import meter. 3. 3. 1 2. 1. 1 host get import meter properties. Module record. The host defined abstract operation host get import meter properties takes argument module record, a module record, and returns a list of records with fields, an ECMAScript language value. It allows hosts to provide property keys and values for the object returned from import meter. The default implementation of host get import meter properties is to return a new empty list. Note a tag template is a function call where the arguments of the call are derived from a template literal 1 3 2 8. The actual arguments include a template object 1 3 2 8 4 and the values produced by evaluating the expressions embedded within the template literal. 68. Copyright sign, ECMA International 2024. 133 12 1. To host finalize import meter, module record. The host-defined abstract operation host finalize import meter takes arguments import meter, an object, and module record, a module record, and returns unused. It allows hosts to perform any extraordinary operations to prepare the object returned from import meter. Most hosts will be able to simply define host get import meter properties and leave host finalize import meter with its default behavior. However, host finalize import meter provides an escape hatch for hosts which need to directly manipulate the object before it is exposed to ECMAScript code. The default implementation of host finalize import meter is to return unused. 3.4 Update expression syntax. Update expression, yield, await, left-hand side expression yield await, left-hand side expression yield await, left-hand side expression yield await, plus unary expression yield await, unary expression yield await, 1 3 4 1 static semantics, early errors, update expression, left-hand side expression plus, no line terminator here, plus, no line terminator here, left-hand side expression. It is an early syntax error if assignment target type of left-hand side expression is not simple. Update expression plus unary expression. Unary expression. It is an early syntax error if assignment target type of unary expression is not simple. 3 4 2 postfix increment operator 1 3 4 2 1 runtime semantics. Evaluation. Update expression. Left-hand side expression plus, let LHS be. Evaluation of left-hand side expression, let old value be. Numeric. Get value, LHS. If old value is a number, then let new value be number. Add old value, 1. Else assert old value is a big int. Be let new value be big int. Add old value, 1z. Perform. Put value, LHS. New value. Return old value. ECMA International 2024 269. 1 3 4 3 postfix decrement operator 1 3 4 3 1 runtime semantics. Evaluation. Update expression. Left-hand side expression. Let LHS be. Evaluation of left-hand side expression. Let old value be. Numeric. Get value. LHS. If old value is a number, then let new value be number. Subtract old value, 1. Else assert old value is a big int. Be let new value be big int. Subtract old value, 1z. Perform. Put value, LHS. New value. Return old value. 3 4 4 prefix increment operator 1 3 4 4 1 runtime semantics. Evaluation. Update expression. Plus unary expression. Let x be. Evaluation of unary expression. Let old value be. Numeric. Get value. Exper. If old value is a number, then let new value be number. Add old value. 1. Else assert old value is a big int. Be let new value be big int. Add old value. 1z. Perform. Put value. Exper. New value. Return new value. 3 4 5 prefix decrement operator 1 3 4 5 1 runtime semantics. Evaluation. Update expression. Unary expression. Let x be. Evaluation of unary expression. Let old value be. Numeric. Get value. Exper. If old value is a number, then let new value be number. Subtract old value. 1. Else assert old value is a big int. Be let new value be big int. Subtract old value. 1z. Perform. Put value. Exper. New value. Return new value. 70. ECMA International 2024. 13.5 Unary operators syntax. Unary expression. Yield. Await. Update expression yield await. Delete unary expression yield await. Void unary expression yield await. Type of unary expression yield await plus unary expression yield await. Unary expression yield await. Unary expression yield await. Unary expression yield await plus await. Await expression yield. 3 5 1 delete operator. 3 5 1 1 static semantics. Early errors. Unary expression. Delete unary expression. It is a syntax error if the unary expression is contained in strict mode code and the derived unary expression is primary expression. Identifier reference. Member expression. Member expression. Private identifier. Call expression. Call expression. private identifier, optional chain, private identifier, or optional chain, optional chain. Private identifier. It is a syntax error if the derived unary expression is primary expression, capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N, and capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N, ultimately derives a phrase that, if used in place of unary expression, would produce a syntax error according to these rules. This rule is recursively applied. 3, 5, 1. To runtime semantics. Evaluation. Unary expression. Delete unary expression. Let ref be. Evaluation of unary expression. If ref is not a reference record, return true. If is unresolvable reference, ref is true, then assert ref is false. B return true. If is property reference, ref is true, then assert is private reference, ref is false. B if is super reference, ref is true. Throw a reference error exception. C let base obj be. To object, ref. D let delete status be base obj, ref. E if delete status is false and ref is true. Throw a type error exception. F return delete status. Else a let base be ref. B assert. Base is an environment record. C return base delete binding. Ref. The last rule means that expressions such as delete foo produce early errors because note of recursive application of the first rule. ECMA International 2024 271. Note 1 when a delete operator occurs within strict mode code. A syntax error exception is thrown if its unary expression is a direct reference to a variable, function argument, or function name. In addition, if a delete operator occurs within strict mode code and the property to be deleted has the attribute false, or otherwise cannot be deleted, a type error exception is thrown. Note 2 the object that may be created in step 4c is not accessible outside of the above abstract operation in the ordinary object internal method. An implementation might choose to avoid the actual creation of that object. 3, 5, 2 avoid operator. 3, 5, 2, 1 runtime semantics. Evaluation. Unary expression. Void unary expression. Let x be. Evaluation of unary expression. Perform. Get value. Expa. Return undefined. 3, 5, 3 the TPF operator. 3, 5, 3, 1 runtime semantics. Evaluation. Unary expression. Type of unary expression. Let val be. Evaluation of unary expression. If val is a reference record, then if is unresolvable reference, val is true. Return undefined. Set val 2. Get value. Val. If val is undefined, return undefined. If val is null, return object. If val is a string, return string. If val is a symbol, return symbol. If val is a boolean, return boolean. If val is a number, return number. 0. If val is a big int, return bigint. 1. Assert. Val is an object. 2. Note. The step is replaced in section B. 3, 6, 3, 3. If val has an internal slot, return function. 4. Return object. 3, 5, 4 unary plus operator. Note the unary plus operator converts its operand to number type. Note get value must be called even though its value is not used because it may have observable side effects. 272. ECMA International 2024. 1, 3, 5, 4, 1 runtime semantics. Evaluation. Unary expression. Plus unary expression. Let x be. Evaluation of unary expression. Return. To number. Get value. Expa. 3, 5, 5 unary operator. 3, 5, 5, 1 runtime semantics, evaluation, unary expression, let x be. Evaluation of unary expression, let old value be. To numeric. Get value, expr, if old value is a number, then a return number, unary minus, old value 4. Else ab, assert, old value is a big int, return big int, unary minus, old value. The unary operator converts its operand to a numeric value and then negates it. Negating +0, note, produces -0, and negating -0 produces +0. Bitwise not operator, unary expression, 3, 5, 6, 3, 5, 6, 1 runtime semantics, evaluation, let x be. Evaluation of unary expression, let old value be. To numeric. Get value, expr, if old value is a number, then a return number, bitwise not, old value 4. Else ab, assert, old value is a big int, return big int, bitwise not, old value. Logical not operator, unary expression, 3, 5, 7, 3, 5, 7, 1 runtime semantics, evaluation, let x be. Evaluation of unary expression, let old value be to boolean. Get value, expr, if old value is true, return false, return true. 3.6 exponentiation operator syntax, exponentiation expression, yield, await, unary expression yield await, update expression yield await, exponentiation expression yield await. ECMA International 2024 273 136 1 runtime semantics, evaluation, exponentiation expression, update expression, exponentiation expression, return. Capital E V A L U A T E, capital S T R I N G, capital O R, capital N U M E R I C, capital B I N A R Y, capital E, update expression, exponentiation expression. 3.7 multiplicative operators syntax, multiplicative expression, yield, await, exponentiation expression yield await, multiplicative expression yield await, multiplicative operator, exponentiation expression yield await, multiplicative operator, 1 of, %, 3, 7, 1 runtime semantics, evaluation, multiplicative expression, multiplicative expression, multiplicative operator, exponentiation expression. Let op text be the source text matched by multiplicative operator. Return. Capital E V A L U A T E, capital S T R I N G, capital O R, capital N U M E R I C, capital B I N A R Y, capital E, multiplicative expression, text, exponentiation expression. 3.8 additive operators syntax, additive expression, yield, await, multiplicative expression yield await, additive expression yield await plus multiplicative expression, question mark yield await, additive expression yield await, multiplicative expression yield await. 3, 8, 1 the addition operator, plus, note the addition operator either performs string concatenation or numeric addition. 3, 8, 1, 1 runtime semantics, evaluation, additive expression plus multiplicative expression. Return. Capital E V A L U A T E, capital S T R I N G, capital O R, capital N U M E R I C, capital B I N A R Y, capital E, additive expression, plus, multiplicative expression. Note, the operator performs multiplication, producing the product of its operands. The operator performs division, producing the quotient of its operands. The percent operator yields the remainder of its operands from an implied division. 274. Copyright sign, ECMA International 2024. 138. To the subtraction operator. 3, 8, 2. 1 runtime semantics. Evaluation. Additive expression, multiplicative expression. Return. Capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, additive expression, multiplicative expression. 3.9 bitwise shift operators syntax. Shift expression, yield, await. Additive expression, yield, await. 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 3, 9, 1 the left shift operator. 3, 9, 1. 1 runtime semantics. Evaluation. Shift expression, additive expression. Return. Capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, shift expression, additive expression. 3, 9. To the signed right shift operator. 3, 9, 2. 1 runtime semantics. Evaluation. Shift expression, additive expression. Return. Capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, shift expression, additive expression. 3, 9. 3 the unsigned right shift operator. Note, the operator performs subtraction, producing the difference of its operands. Note performs a bitwise left shift operation on the left operand by the amount specified by the right operand. Note performs a sign filling bitwise right shift operation on the left operand by the amount specified by the right operand. Note performs a zero filling bitwise right shift operation on the left operand by the amount specified by the right operand. ECMA International 2024 275 139 3. 1 runtime semantics. Evaluation. Shift expression, additive expression. Return. Capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, shift expression, additive expression. 3.10 Relational operators. Syntax. Relational expression. In, yield, await. Shift expression, yield, await. Relational expression in yield. Relational expression in yield. Relational expression in yield. Relational expression in yield. Relational expression in yield, await. Shift expression, yield, await, await. Shift expression, yield, await, await. Equals shift expression, yield, await, await. Equals shift expression, yield, await, await. Instantiaf. Note 1. The result of evaluating a relational operator is always of type Boolean, reflecting whether the relationship named by the operator holds between its two operands. Shift expression, yield, await, plus in relational expression, plus in yield, await. in shift expression yield await, plus in private identifier in shift expression yield await. 3. 1 0 1 runtime semantics, evaluation, relational expression, shift expression, letter FB, evaluation of relational expression, little val B, get value, ref, letter FB, evaluation of shift expression, letter val B, get value, ref, letter B, is less than, val, reval, true if R is undefined, return false, otherwise, return R, relational expression, shift expression, letter FB, evaluation of relational expression, little val B, get value, ref, letter FB, evaluation of shift expression, letter val B, get value, ref, letter B, is less than, reval, val, false if R is undefined, return false, otherwise, return R, relational expression equals shift expression, letter FB, evaluation of relational expression, little val B, get value, ref, letter FB, evaluation of shift expression, letter val B, get value, ref, letter B, is less than, reval, val, false if R is either true or undefined, return false, otherwise, return true. 276. ECMA International 2024. Note 2 the in grammar parameter is needed to avoid confusing the in operator in a relational expression with the in operator in a for statement. Relational expression equals shift expression, letter FB, evaluation of relational expression, little val B, get value, ref, letter FB, evaluation of shift expression, letter val B, get value, ref, letter B, is less than, val, reval, true if R is either true or undefined, return false, otherwise, return true. Relational expression instantia of shift expression, letter FB, evaluation of relational expression, little val B, get value, ref, letter FB, evaluation of shift expression, letter val B, get value, ref, return. Instantia of operator, val, reval, relational expression in shift expression, letter FB, evaluation of relational expression, little val B, get value, ref, letter FB, evaluation of shift expression, letter val B, get value, ref. If reval is not an object, throw a type error exception, return, has property, reval, to property key, val, relational expression, private identifier in shift expression. Let private identifier be the string value of private identifier, letter FB, evaluation of shift expression, letter val B, get value, ref. If reval is not an object, throw a type error exception. Let private env be the running execution context's private environment. Let private name be resolved private identifier, private env, private identifier. If private element fin d, reval, private name, is not empty, return true, return false. 3. 1 0 2 instantia of operator, v, target. The abstract operation instantia of operator takes arguments v, an ECMAScript language value, and target, an ECMAScript language value, and returns either a normal completion containing a boolean or a throw completion. It implements the generic algorithm for determining if v is an instance of target either by consulting target's at has instance method or, if absent, determining whether the value of target's prototype property is present in v's prototype chain. It performs the following steps when called. If target is not an object, throw a type error exception. Let inst of handler be get method target at has instance. If inst of handler is not undefined, then a returns a boolean. Call inst of handler target v if is callable. Target is false. Throw a type error exception. Return ordinary has instance target v. Note steps 4 and 5 provide compatibility with previous editions of ECMAScript that did not use a at has instance method to define the instantia of operator semantics. If an object does not define or inherit at has instance, it uses the default instancia of semantics. ECMA International 2024 277 13.11 Equality operators. Syntax. Equality expression in yield await. Relational expression in yield await. Equality expression in yield await equals relational expression in yield await. Equality expression in yield await equals relational expression in yield await. Equality expression in yield await equals relational expression in yield await. Equality expression in yield await equals relational expression in yield await. 3.1.1 runtime semantics. Evaluation. Equality expression equals relational expression. Letter FB. Evaluation of equality expression. Letter val b. Get value. Ref. Letter FB. Evaluation of relational expression. Letter val b. Get value. Ref. Return. Is loosely equal. Val. Equality expression equals relational expression. Letter FB. Evaluation of equality expression. Letter val b. Get value. Ref. Letter FB. Evaluation of relational expression. Letter val b. Get value. Ref. Letter b. Is loosely equal. Val. If R is true, return false. Otherwise, return true. Equality expression equals relational expression. Letter FB. Evaluation of equality expression. Letter val b. Get value. Ref. Letter FB. Evaluation of relational expression. Letter val b. Get value. Ref. Return is strictly equal. Val. Equality expression equals relational expression. Letter FB. Evaluation of equality expression. Letter val b. Get value. Ref. Letter FB. Evaluation of relational expression. Letter val b. Get value. Ref. Let R be is strictly equal. Val. If R is true, return false. Otherwise, return true. 278. ECMA International 2024. Note the result of evaluating an equality operator is always of type Boolean, reflecting whether the relationship named by the operator holds between its two operands. Note 1. Given the above definition of equality, string comparison can be forced by $b $, b. Numeric comparison can be forced by plus equals plus b. Boolean comparison can be forced by equals b. Note 2. The equality operators maintain the following invariants. Up equals b is equivalent to up equals b. Up equals b is equivalent to b equals a, except in the order of evaluation of a and b. Note 3. The equality operator is not always transitive. For example, there might be two distinct string objects, each representing the same string value. Each string object would be considered equal to the string value by the equals operator, but the two string objects would not be equal to each other. For example, new string equals a and a equals new string are both true. New string equals new string is false. Note 4. Comparison of strings uses a simple equality test on sequences of code unit values. There is no attempt to use the more complex, semantically oriented definitions of character or string equality and collating order defined in the Unicode specification. Therefore, strings values that are canonically equal according to the Unicode standard could test as unequal. In effect, this algorithm assumes that both strings are already in normalized form. 3.12 Binary bitwise operators. Syntax. Bitwise and expression in yield await. Equality expression in yield await. Bitwise and expression in yield await. And equality expression in yield await. Bitwise or expression in yield await. Bitwise and expression in yield await. Bitwise or expression in yield await. Bitwise and expression in yield await. Bitwise or 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 expression in yield await. 3.1.2 runtime semantics. Evaluation. Bitwise and expression and equality expression. Return. Capital E V A L U A T E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, bitwise and expression, and equality expression. ECMA International 2024 279. Bitwise or expression. Bitwise or expression. Bitwise and expression. Return. Capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, bitwise or expression, bitwise and expression, bitwise or expression, bitwise or expression, bitwise or expression. Return. Capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, bitwise or expression, bitwise or expression. 3.13 Binary logical operators syntax, logical and expression, in, yield, await, bitwise or expression in yield await, logical and expression in yield await, and bitwise or expression in yield await, logical or expression, in, yield, await, logical and expression in yield await, logical or expression in yield await, logical and expression in yield await, coalesce expression, in, y, yield, await, coalesce expression head in yield await, bitwise or expression in yield await, coalesce expression head, in, yield, await, coalesce expression in yield await, bitwise or expression in yield await, short circuit expression, in, yield, await, logical or expression in yield await, coalesce expression in yield await. 3.13 runtime semantics, evaluation, logical and expression and bitwise or expression. Letter FB. Evaluation of logical and expression. Little val b. Get value. Ref. Let bool be to boolean. Val. If bool is false, return val. Letter FB. Evaluation of bitwise or expression. Return. Get value. Ref. Logical or expression. Logical and expression. Letter FB. Evaluation of logical or expression. Little val b. Get value. Ref. Let bool be to boolean. Val. If bool is true, return val. Letter FB. Evaluation of logical and expression. Return. Get value. Ref. 280. ECMA International 2024. The value produced by a and or operator is not necessarily of type boolean. The value produced, note, will always be the value of one of the two operand expressions. Coalesce expression head. Bitwise or expression. Letter FB. Evaluation of coalesce expression head. Little val b. Get value. Ref. If the val is either undefined or null, then a letter FB. Evaluation of bitwise or expression b return. Get value. Ref. Else a return val. 3.14 Conditional operator. Syntax. Conditional expression, in, yield, await, short circuit expression in yield await, short circuit expression in yield await, assignment expression, plus in yield await, assignment expression in yield await. 3.14 runtime semantics. Evaluation. Conditional expression, short circuit expression, assignment expression, letter FB. Evaluation of short circuit expression. Let val be to boolean. Get value. Ref. If val is true, then a let true ref b. Evaluation of the first assignment expression b return. Get value. True ref. Else a let false ref b. Evaluation of the second assignment expression b return. Get value. False ref. Note the grammar for a conditional expression in ECMAScript is slightly different from that in C and Java, which each allow this.
I found ternary statements. Those macros. That's close. Because that has to do with control flow. So now I gotta find. I'm gonna do control F, whatever, on the ternary statement macros, whatever name they have, and try to find the if-else macros, and then the do while, or even just the while. It doesn't matter what loop, just one of them. And then I can, not but do this function. Then I'll have everything, whatever, to put the rest of this function together, whatever. Maybe I could use ternary here.
Following early error.
If I can't find the if-else, even though I think it's grouped with the ternaries, if it's not, or it doesn't happen to be, I don't want to like try to find it.
Expression, left-hand side expression.
Because I'm tired of trying to find stuff this big project.
Is not simple. 3. Left-hand side.
Whichever one I converted for.
Expression is neither an object literal nor an array literal. Then, a letter of B. Evaluation of left-hand side.
Okay, I found the ternary macros, which means that I could, if I can't find the if-else, which of these, I have macro, whatever. I could replace this with like, since it's JavaScript and undefined is a thing or whatever, I don't know, make it like slightly more readable possibly. I don't know if that happens to be more readable. This is just like an if or whatever. I could use a ternary instead of an if, where this statement is the condition, whatever. If it's true, then this question mark indicates the end of the statement or the condition. If it's true, then I don't have these. If it's true, then it'll do this. If it's false, it'll do this. might just do that if I can't find if else easier. It takes so much work to find it. So I could do that for this if, and then this if here. All I really need to find is do while loop, or just a while loop, or any loop, data structure, or macro, whatever. So I can paste it, and then I have the rest of that thing put together. So if I can find that, then I'm good. I can run this, and then I can get to this stuff. Wait here. I'm running out of time. How long this takes? I might have just enough time left to do this, so that tomorrow will be only this. If not, another day is just another day, and then another day, and then another day, and then another day, and then another day. So someday, one day, I don't know, I'm gonna stop rambling, try to find stupid crap. I'm really hoping the if else and also loops are grouped up in the code with where the ternary macros I have are, because I finally found those. So the rest of the control flow, I think I would have laid the code out next to the ternary. I'm gonna find out if that's what it did, or if it's in a different file. But whatever folder it's in that has this file, I think the rest of the stuff that I'm looking for related is in that file too. This is taking way too long. But at least now I'll have a collection of macros, whatever, because when I get to do this part where I render stuff in OpenGL, I'll literally have everything I need to make some test functions that can increase the environment, whatever you want to call it, the workload, to see which engine can handle more computation between frames. Converting the rest of this to 64-bit is gonna suck. Last time I said 31 plus 63. Or 31 plus 31 isn't 64. The length I don't know, I'm gonna say some stuff that has no context. So I'm talking about, or I'll say something and then not finish whatever the hell the context is.
Settle value.
4 bits, I guess. That's 4, 1 through 4. 4 is length. So put the space. There's 4 zeros in length. Because 0 is a placeholder, commonly depending. So in binary, or a hexadecimal base 2, a nibble. Okay, 0 is equal to 0, 0. 1 is equal to 0, 1. 2 is equal to 1, 0. 4 is equal to 1, 0 is equal. This is 4 things or whatever, 4 zeros, a length of 4. If you hold a number and you're holding in let's say binary, whatever, so 0, 0, like bits, and then 0, 1, 1, 0, and you hit 3, you have to, the only way to represent a new unique identifier is to introduce another number or make the pattern bigger. So add another row or column, whatever it is, here third. So now you have 0, 0 at the bottom again. 4 is 1. So now 4, it can't be represented 0, 1, 2, 3 because 4 is outside of this bit range. So if you have like a computer register that had 2 bits, you want to save the length of something that's 4, like this, it's not possible to save number 4 with the computer with 2 bits because it can only represent 0, 0, 0, 1, 1, 0, 1, 1. And since it's 2 bits, a 2-bit register, whatever, you can't represent this 1 here for 4. So instead, you can represent 4 length 3, where 0 is 1, 1 is 2, 2 is 3, and 3 is 4, which means you remove 0, and 0 is no longer a placeholder in the whatever the mathematical system you want to call it. When you remove 0 and there's no placeholder, there's a whole bunch of magical mathematical opportunities. So I'm not going to get into it, but that's what I was getting at with 31 plus 31 is 64, but the bit size here is actually just double the size. But a register or number 31, where's the calculator?
R, val, optext, val, 3, 1, 5, 5 destructuring assignment supplemental syntax.
So this is 31 in decimal. And data compression for streaming is terrible. Bigger, I won't zoom. This is 31 in decimal. This is 31 in binary. So it's all ones. So 31 is this in binary. It's 5 bits. I don't know of any computer that has a 5-bit register. Anything is possible. And there are some really funky, cool computers. But when you represent bits, whatever, like I said last time, they start bit 0 and go up to 31. So even though there's 32 bits, the position itself is 0 to 31. 32 wouldn't, if it was a 5-bit register, it's not going to fit in the register because it's the length and it's 1 greater. So I don't know. What I was getting at is when you get rid of 0 as a placeholder, and I don't know, magical things can happen in math when you're doing whatever. I'm not going to say what it is though, because whatever. So I really didn't explain anything, but it doesn't matter. I just wasted time rambling. I'm gonna get some more water. Come back and then try to find, well not try, I have to find, to get to the next freaking point of converting this thing. Converting this test function, whatever. I'm gonna try to find the if macros. I found the ternary, so when I get back, that's my goal. It's already been a couple hours, so that's great. But I didn't waste time, because I found just globs and stuff related to other stuff that I'm going to need later. I'm still going to have to, at some point I'm going to have to, like, take stuff out, because it's just, it's a huge unorganized blob. So I gotta like make new files, move things to those files. I don't know. I gotta organize this stuff without breaking anything later. I think I found everything I need for the ifs and the control flow for loops. So I'll be back and I hope this is also the newer code, because I have like version 0, 1, 2, version 3, and version 4. Or version 3? I don't know. I have a couple different versions. The old ones, I grouped them all into one group because they're close, but the newer ones are defined off the back of some of the older ones. And then the newest one is like a reorganized version of both with a bunch of other features added. And that's when I have to find the control flow macros for it, because if I find the older macros, they don't have they don't account for the stuff in the newer macros, and it'll cause bugs if I don't find the right defines for the newer modules, whatever. Okay, I'm done rambling for now. I gotta think about Sublime too. I also have to, at some point, I gotta fix whatever, or figure out what's going on with the character encoding. I'll be back.
Capital P R O P E R T Y, capital D E S T R U C T U R I N G, capital A, S, S, I, G, N, M, E, N, of assignment property list with argument value return. Capital R, E, S, T, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, T, capital E, V, A, of assignment dress property with arguments value and excluded names. Array assignment pattern. Let iterator record B. Get iterator, value, sync, return. Iterator close. Iterator record. Normal completion, unused. Array assignment pattern. Elision. Let iterator record B. Get iterator, value, sync. Let result be completion. Iterator destructuring assignment evaluation of elision with argument. Iterator record. If iterator record is false, return. Iterator close. Iterator record. Result. Return result. Array assignment pattern. Elision not assignment rest element. Let iterator record B. Get iterator, value, sync. If elision is present, then a let status be completion. Iterator destructuring assignment evaluation of elision with argument iterator record. B if status is an abrupt completion, then I assert iterator record is true. 2. Return status. Let result be completion. Iterator destructuring assignment evaluation of assignment rest element with argument iterator record. ECMA International 2024 287. 4. If iterator record is false, return. Iterator close. Iterator record. Result. Return result. Array assignment pattern. Assignment element list. Let iterator record B. Get iterator, value, sync. Let result be completion. Iterator destructuring assignment evaluation of assignment element list with argument iterator record. If iterator record is false, return. Iterator close. Iterator record. Result. Return result. Array assignment pattern. Assignment element list. Elision not assignment rest element opt. Let iterator record B. Get iterator, value, sync. Let status be completion. Iterator destructuring assignment evaluation of assignment element list with argument iterator record. If status is an abrupt completion, then if iterator record is false, return. Iterator close. Iterator record. Status. B return status. If elision is present, then assert status to completion. Iterator destructuring assignment evaluation of elision with argument iterator record. B if status is an abrupt completion, then I assert iterator record is true. 2. Return status. If assignment rest element is present, then assert status to completion. Iterator destructuring assignment evaluation of assignment rest element with argument iterator record. If iterator record is false, return. Iterator close. Iterator record. Status. Return status. 3. 1 5 5 3 runtime semantics. Capital P R O P E R T Y. Capital D E S T R U C T U R I N G. Capital A S S I G N M E N. The syntax-directed operation property destructuring G assignment evaluation takes argument value, an ECMAScript language value, and returns either a normal completion containing a list of property keys or an abrupt completion. It collects a list of all destructured property keys. It is defined piecewise over the following productions: assignment property list, assignment property list, assignment property. Let property names be capital P R O P E R T Y, capital D E S T R U C T U R I N G, capital A S S I G N M E N. Of assignment property list with argument value. Let next names be capital P R O P E R T Y, capital D E S T R U C T U R I N G, capital A S S I G N M E N, of assignment property with argument value. Return the list concatenation of property names and next names. Assignment property identifier reference initializer opt. Let P be string value of identifier reference. Let ref be resolve binding. P let V be jet value P if initializer is present and V is undefined. Then if is anonymous function definition initializer is true. Then I set V to named evaluation of initializer with argument P be else I let default value be evaluation of initializer to semv to get value default value perform put value ref V return P 88 ECMA International 2024 assignment property name assignment element let name be evaluation of property name perform capital K E Y E D capital D E S T R U C T U R I N G capital A S S I G N M E N T capital E V of assignment element with arguments value and name return name 3155 for runtime semantics capital R E S T capital D E S T R U C T U R I N G capital A S S I G N M E N T capital E V A. The syntax directed operation capital R E S T capital D E S T R U C T U R I N G capital A S S I G N M E N T capital E V A takes arguments value, an ECMAScript language value, and excluded names, a list of property keys, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions. Assignment dress property. Destructuring assignment target. Let ref be evaluation of destructuring assignment target. Let rest obj be ordinary object create. Object prototype perform. Copy data properties. Rest obj value. Excluded names return. Put value ref. Rest obj 3155 runtime semantics. Capital I T E R A T O R capital D E S T R U C T U R I N G capital A S S I G N M E N. The syntax directed operation capital I T E R A T O R capital D E S T R U C T U R I N G capital A S S I G N M E N takes argument iterator record, an iterator record, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions. Assignment element list. Assignment elision element return. Capital I T E R A T O R capital D E S T R U C T U R I N G, capital A S S I G N M E N, of assignment elision element with argument iterator record. Assignment element list. Assignment element list. Assignment elision element. Perform. Capital I T E R A T O R, capital D E S T R U C T U R I N G, capital A S S I G N M E N, of assignment element list with argument iterator record. Return. Capital I T E R A T O R, capital D E S T R U C T U R I N G, capital A S S I G N M E N, of assignment elision element with argument iterator record. Assignment elision element. Assignment element. Return. Capital I T E R A T O R, capital D E S T R U C T U R I N G, capital A S S I G N M E N, of assignment element with argument iterator record. Assignment elision element. Elision assignment element. Perform. Capital I T E R A T O R, capital D E S T R U C T U R I N G, capital A S S I G N M E N, of elision with argument iterator record. Return. Capital I T E R A T O R, capital D E S T R U C T U R I N G, capital A S S I G N M E N, of assignment element with argument iterator record. Elision. If iterator record is false, then a let next be completion. Iterator step. Iterator record. B if next is an abrupt completion. Set iterator record to true. C return if abrupt. Next. D if next is false. Set iterator record to true. Return unused. Elision. Elision. Perform. Capital I T E R A T O R, capital D E S T R U C T U R I N G, capital A S S I G N M E N, of elision with argument iterator record. If iterator record is false, then a let next be completion. Iterator step. Iterator record. B if next is an abrupt completion. Set iterator record to true. ECMA International 2024 289. C return if abrupt. Next. D if next is false. Set iterator record to true 3. Return unused. Assignment element. Destructuring assignment target initializer opt. If destructuring assignment target is neither an object literal nor an array literal, then elect if b. Evaluation of destructuring assignment target. Let value be undefined. If iterator record is false, then elect next b. Iterator step value. Iterator record. B if next is not done, then I set value to next. If initializer is present and value is undefined, then if is anonymous function definition. Initializer is true and is identifier ref of destructuring assignment target is true, then I let VB. Named evaluation of initializer with argument refb else. I let default value be. Evaluation of initializer 2. Let VB. Get value. Default value else a let VB value. If destructuring assignment target is either an object literal or an array literal, then a let nested assignment pattern be the assignment pattern that is covered by destructuring assignment target be return. Capital D E S T R U C T U R I N G capital A S S I G N M E N T capital E V A L U A T of nested assignment pattern with argument v return. Put value ref v assignment rest element. Destructuring assignment target. If destructuring assignment target is neither an object literal nor an array literal, then a let ref b. Evaluation of destructuring assignment target. Let a be. Array create 0 let 0 repeat. While iterator record is false, a let next be. Iterate a step value. Iterate a record b. If next is not done, then I perform. Create data property or throw a to string n next 2. Set n to n plus 1. If destructuring assignment target is neither an object literal nor an array literal, then a return. Put value ref a. Let nested assignment pattern be the assignment pattern that is covered by destructuring assignment target return. Capital D E S T R U C T U R I N G capital A S S I G N M E N T capital E V A L U A T of nested assignment pattern with argument A 3 1 5 5 6 runtime semantics capital K E Y E D capital D E S T R U C T U R I N G capital A S S I G N M E N T capital E V N. The syntax directed operation capital K E Y E D capital D E S T R U C T U R I N G capital A S S I G N M E N T capital E V takes arguments value, an ECMAScript language value, and property name, a property key, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions. Assignment element. Destructuring assignment target initializer opt. If destructuring assignment target is neither an object literal nor an array literal, then a let ref b. Evaluation of destructuring assignment target. Let VB. Jet. Value. Property name. If initializer is present and v is undefined, then 290 ECMA International 2024. Note left to right evaluation order is maintained by evaluating a destructuring assignment target that is not a destructuring pattern prior to accessing the iterator or evaluating the initializer. If is anonymous function definition, initializer, and is identifier ref of destructuring assignment target to both true, then I let RHS value be. Named evaluation of initializer with argument ref b else I let default value be. Evaluation of initializer 2. Let RHS value be. Get value. Default value else a let RHS value be v. If destructuring assignment target is either an object literal or an array literal, then a let assignment pattern be the assignment pattern that is covered by destructuring assignment target be return. Capital D E S T R U C T U R I N G capital A, S, S, I, G, N, M, E, N, T, capital E, V, A, L, U, A, T, of assignment pattern with argument RHS value. Return. Put value, ref. RHS value 3.16 comma operator. Syntax. Expression. In. Yield. Await. Assignment expression in yield await. Expression in yield await. Assignment expression in yield await. 1316. 1 runtime semantics. Evaluation. Expression. Expression. Assignment expression. Letter FB. Evaluation of expression. Perform. Get value. Ref. Letter FB. Evaluation of assignment expression. Return. Get value. Ref. For ECMAScript language. Statements and declarations syntax. Statement. Yield. Await. Return. Block statement yield await return. Variable statement yield await. Empty statement expression statement yield await. If statement yield await return. Breakable statement yield await return. Continue statement yield await. Break statement yield await. Plus return. Return statement yield await. With statement yield await return. Labeled statement yield await return. Throw statement yield await. Try statement yield await return. Debugger statement. Note get value must be called even though its value is not used because it may have observable side effects. ECMA International 2024 291. Declaration. Yield. Await. Hoistable declaration yield await. Default. Class declaration yield await. Default. Lexical declaration. Plus in yield await. Hoistable declaration. Yield. Await. Default. Function declaration yield await default. Generator declaration yield await default. Async function declarate in yield await default. Async generator declaration yield await default. Breakable statement. Yield. Await. Return. Iteration statement yield await return. Switch statement yield await return. 4.1 Statement semantics. 4. 1. 1 runtime semantics. Evaluation. Hoistable declaration. Generator declaration. Async function declaration. Async generator declaration. Return empty. Hoistable declaration. Function declaration. Return. Evaluation of function declaration. Breakable statement. Iteration statement. Switch statement. Let new label set be a new empty list. Return. Labeled evaluation of this breakable statement with argument new label set. 4.2 Block syntax. Block statement. Yield. Await. Return. Block yield await return. Block. Yield. Await. Return. Statement list yield await return opt. Statement list. Yield. Await. Return. Statement list item yield await return. Statement list yield await return. Statement list item yield await return. Statement list item. Yield. Await. Return. Statement yield await return. Declaration yield await. 92. ECMA International 2024. 142. 1 Static semantics. Early errors. Block. Statement list. It is a syntax error if the lexically declared names of statement list contains any duplicate entries. It is a syntax error if any element of the lexically declared names of statement list also occurs in the are declared names of statement list. 4. 2. 2 runtime semantics. Evaluation. Block. Return empty. Block. Statement list. Let old env be the running execution context's lexical environment. Let block env be new declarative environment. Old env perform block declaration instantiation. Statement list. Block env. Set the running execution context's lexical environment to block env. Let block value be completion. Evaluation of statement list. Set the running execution context's lexical environment to old env. Return block value. Statement list. Statement list item. Let SL be. Evaluation of statement list. Let S be completion. Evaluation of statement list item. Return. Update empty. S. SL. 4. 2. 3 block declaration instantiation. Code. env, the abstract operation block declaration instantiation takes arguments code, a parse node, and env, a declarative environment record. and returns unused code is the parse node corresponding to the body of the block. env is the environment record in which bindings are to be created. It performs the following steps when called. Let declarations be the lexically scoped declarations of code. Let private env be the running execution context's private environment. For each element D of declarations, do a for each element dn of the bound names of D. Do ECMA International 2024 293. Note 1. No matter how control leaves the block, the lexical environment is always restored to its former state. Note 2. The value of a statement list is the value of the last value producing item in the statement list. For example, the following calls to the eval function all return the value 1 eval 1 eval 1 eval 1 var a. Note when a block or case block is evaluated, a new declarative environment record is created and bindings for each block scoped variable, constant, function, or class declared in the block are instantiated in the environment record. If this constant declaration of D is true, then perform env create immutable binding, dn, true 2. Else perform env create mutable binding, dn, false. Note, this step is replaced in section B. 3, 2, 6. B if D is either a function declaration, a generator declaration, an async function declaration, or an async generator declaration, then I let fn be the sole element of the bound names of D. 2. Let fo be instantiate function object of D with arguments env and private env. 3. Perform env initialize binding, fn, fo. Note, this step is replaced in section B. 3, 2, 6. Return unused. 4.3 declarations in the variable statement. 4, 3, 1. Syntax. Lexical declaration. In yield await. Let or const binding list in yield await. Let or const binding list in yield await. Lexical binding in yield await. Binding list in yield await. Lexical binding in yield await. Lexical binding in yield await. Binding identifier yield await. Initializer in yield await. Opt binding pattern yield await. Initializer in yield await. 4, 3, 1. 1. Static semantics. Early errors. Lexical declaration. Let or const binding list. It is a syntax error if the bound names of binding list contains let. It is a syntax error if the bound names of binding list contains any duplicate entries. Lexical binding. Binding identifier initializer opt. It is a syntax error if initializer is not present and is constant declaration of the lexical declaration containing this lexical binding is true. 94. ECMA International 2024. Let and const declarations. Let and const declarations define variables that are scoped to the running execution contexts. Note, lexical environment. The variables are created when their containing environment record is instantiated but may not be accessed in any way until the variable's lexical binding is evaluated. A variable defined by a lexical binding with an initializer is assigned the value of its initializer's assignment expression when the lexical binding is evaluated, not when the variable is created. If a lexical binding in a let declaration does not have an initializer, the variable is assigned the value undefined when the lexical binding is evaluated. 1, 4, 3, 1. 2. Runtime semantics. Evaluation. Lexical declaration. Let or const binding list. Perform. Evaluation of binding list. Return empty. Binding list. Binding list. Lexical binding. Perform. Evaluation of binding list. Return. Evaluation of lexical binding. Lexical binding. Binding identifier. Let LHS be. Resolve binding. String value of bin. Ding identifier. Perform. Initialize reference binding. LHS. Undefined. Return empty. Lexical binding. Binding identifier initializer. Let binding id be string value of binding identifier. Let LHS be. Resolve binding. Binding id. If is anonymous function definition, initializer, is true, then a let value be. Named evaluation of initializer with argument binding id. Else a let RHS be. Evaluation of initializer be let value be. Get value, RHS. Perform. Initialize reference binding, LHS, value. Return empty. Lexical binding. Binding pattern initializer. Let RHS be. Evaluation of initializer. Let value be. Get value. RHS. Let env be the running execution context's lexical environment. Return. Binding initialization of binding pattern with arguments value and env. 4, 3, 2 variable statement. Syntax. Variable statement. Yield. Await. Our variable declaration list. Plus in yield await. A static semantics rule ensures that this form of lexical binding never occurs in a const. Note. Declaration. A var statement declares variables that are scoped to the running execution contexts. Note. Variable environment. Our variables are created when their containing environment record is instantiated and are initialized to undefined when created. Within the scope of any variable environment, a common binding identifier may appear in more than one variable declaration, but those declarations collectively define only one variable. A variable defined by a variable declaration with an initializer is assigned the value of its initializer's assignment expression when the variable declaration is executed, not when the variable is created. ECMA International 2024 295. Variable declaration list. In yield await. Variable declaration in yield await. Variable declaration list in yield await. Variable declaration in yield await. Variable declaration in yield await. Binding identifier yield await. Initializer in yield await. Opt binding pattern yield await. Initializer in yield await. 4, 3, 2, 1 runtime semantics. Evaluation. Variable statement. var variable declaration list. Perform. Evaluation of variable declaration list. Return empty. Variable declaration list. Variable declaration list. Variable declaration. Perform. Evaluation of variable declaration list. Return. Evaluation of variable declaration. Variable declaration. Binding identifier 1. Return empty. Variable declaration. Binding identifier initializer. Let binding id be string value of binding identifier. Let LHS be. Resolve binding. Binding id. If is anonymous function definition, initializer, is true, then a let value be. Named evaluation of initializer with argument binding id. Else a let RHS be. Evaluation of initializer be let value be. Get value. RHS. Perform. Put value. LHS. Value. Return empty. Variable declaration. Binding pattern initializer. Let RHS be. Evaluation of initializer. Let RVA. LB. Get value. RHS. Return. Binding initialization of binding pattern with arguments reval and undefined. 4, 3, 3 destructuring binding patterns syntax. Binding pattern. Yield. Await. Object binding pattern yield await. Array binding pattern yield await. Note if a variable declaration is nested within a with statement and the binding identifier in the variable declaration is the same as the property name of the binding object of the with statement's object environment record. Then step 5 will assign value to the property instead of assigning to the variable environment binding of the identifier. 96. ECMA International 2024.
I'm trying to find a couple stupid macros. I have a list or whatever. With like an opening, a closing, and it can't be placed inside of an if. And then I have another macro that can be placed in an if. I can't find where that's defined because I didn't use it most of the time. Might need to go to Windows 7 hard drive. I almost gotta like dig through way too many layers macros. I'm trying to like, I gotta figure this out anyways at some point. Every opening macro has a closing macro. And there's a whole bunch of like steps in between. There's order, there's a sequence. It's all managed. It's really, once I find it, I'm good. I just need to find one place where I'm using an if with the correct macro to place inside of an if, and then I'm good. Once I find it, at some point. If I have to add when I add more types, whatever, I have to expand some of them out, like collections, because there's more types now. Or when I get to the standard that's not being read, because Siri wants to read. So I'm trying to like figure out where the hell I will fit these new types in. Everything's like there's not much free space or whatever. It's gonna be really difficult. But for now, just trying to absorb it all in and find a stupid macro that is supposed to be used inside of an if because it doesn't need an ending. It's somewhere. I just have to find one use out of and I can't, it's so hard to read this fucking code. Because it doesn't say int anymore. Now it says freaking, like, whatever I place int with. It says like IJTSEN. It's not highlighted. I can't fucking just easily read stuff. I think I'm gonna go to a backup and look through that because it might be easier. It's more readable. I got rid of ints and unsigned int, and it's really painful to read because nothing's like highlighted correctly. This is really annoying.
Object binding pattern. Yield. Await. Binding rest.
And then of course, this is like the modern text editor on the modern operating system, and you can't just easily, easily change the syntax or add a keyword without going through a whole bunch of work. I don't know. I think that it should be like very simple to add to a program a color or something, so it could like highlight certain types by word. It's really simple. But then it's intentional because they don't want people making up their own syntax or their own crap. They want you to follow the rules. It's all about the rules. So without the rules, you might make something new. Set your own rules. Imagine what a world that would be, where all the old stuff becomes obsolete, like the Windows Phone. The Windows Phone, that's obsolete. I have to find one place. One, that's all I have to find. And then I'm good.
Object binding pattern. Yield. Await. Binding rest property yield await. Binding property list yield await. Binding property list yield await. Binding rest property yield await opt. Array binding pattern. Yield. Await. Eligible binding rest element yield await opt. Binding element list yield await. Binding element list yield await. Eligible binding rest element yield await opt. Binding rest property. Yield. Await. Dart. Binding identifier yield await. Binding property list. Yield. Await. Binding property yield await. Binding property list yield await. Binding property yield await. Binding element list. Yield. Await. Binding elision element yield await. Binding element list yield await. Binding elision element yield await. Binding elision element. Yield. Await. Elision binding element yield await. Binding property. Yield. Await. Single name binding yield await. Property name yield await. Binding element yield await. Binding element. Yield. Await. Single name binding yield await. Binding pattern yield await. Initializer. Plus in yield await opt. Single name binding. Yield. Await. Binding identifier yield await. Initializer. Plus in yield await opt. Binding rest element. Yield. Await. Dart. Binding identifier yield await. Binding pattern yield await. 4, 3, 3, 1 runtime semantics. Property binding initialization. The syntax-directed operation property binding initialization takes arguments value, an ECMAScript language value, and environment record or undefined, and returns either a normal completion contain, either list of property keys or an abrupt completion. It collects a list of all bound property names. It is defined piecewise over the following productions: binding property list, binding property list, binding property. Let bound names be. Property binding initialization of binding property list with arguments value and environment. Let next names be. Property binding initialization of binding property with arguments value and environment. Return the list concatenation of bound names and next names. ECMA International 2024 297. Binding property. Single name binding. Let name be the sole element of the bound names of single name binding. Perform. Keep binding initialization of single name binding with arguments value, environment, and name. Return name. Binding property. Property name. Binding element. Let P be. Evaluation of property name. Perform. Keep binding initialization of binding element with arguments value, environment, and P. Return P. 4, 3, 3, 2 runtime semantics. REST binding initialization. The syntax-directed operation REST binding initialization takes arguments value, an ECMAScript language value, environment and environment record or undefined, and excluded names, a list of property keys, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions: binding rest property, binding identifier, let LHS be, resolve binding, string value of binding identifier, environment, let rest obj be ordinary object create, percent object prototype percent perform, copy data properties, rest obj, value, excluded names. If environment is undefined, return, put value, LHS, rest obj, return, initialize reference binding, LHS, rest obj, 4, 3, 3, 3 runtime semantics, keep binding initialization. The syntax-directed operation keep binding initialization takes arguments value, an ECMAScript language value, environment and environment record or undefined, and property name, a property key, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions: binding element, binding pattern initializer let VB, jet, value, property name. If initializer is present and V is undefined, then a let default value be. Evaluation of initializer be set V2. Get value, default value, return. Binding initialization of binding pattern with arguments V and environment. Single name binding, binding identifier initializer let binding id be string value of binding identifier. Let LHS be. Resolve binding, binding id, environment. Let VB, jet, value, property name. If initializer is present and V is undefined, then if is anonymous function definition, initializer, is true, then I set V2. Named evaluation of initializer with argument binding id be else. Note when undefined is passed for environment, it indicates that a put value operation should be used to assign the initialization value. This is the case for formal parameter lists of non-strict functions. In that case, the formal parameter bindings are pre-initialized in order to deal with the possibility of multiple parameters with the same name. 98. ECMA International 2024 I2. Let default value be. Evaluation of initializer. SEMVIA2. Get value, default value. 5. If environment is undefined, return. Put value, LHS, V, return. Initialize reference binding, LHS, V. 4.4 Empty statement syntax. Empty statement. 4, 1 runtime semantics. Evaluation. Empty statement. 1. Return empty. 4.5 expression statement syntax. Expression statement. Yield. Await. Look ahead. Function. Async. No line terminator here. Function. Class. Let. Expression. Plus in yield await. Note an expression statement cannot start with a U plus 007B, left curly bracket, because that might make it ambiguous with a block. An expression statement cannot start with the function or class keywords because that would make it ambiguous with a function declaration, a generator declaration, or a class declaration. An expression statement cannot start with async function because that would make it ambiguous with an async function declaration or a async generator declaration. An expression statement cannot start with the two-token sequence let, because that would make it ambiguous with a let lexical declaration whose first lexical binding was an array binding pattern. 4, 5, 1 runtime semantics. Evaluation. Expression statement. Expression. Let x per f be. Evaluation of expression. Return. Get value. X per f. 4.6 Thief statement syntax. If statement. Yield. Await. Return. If. Expression. Plus in yield await. Statement yield await return. Else. Statement yield await return. If. Expression. Plus in yield await. Statement yield await return. Look ahead else. The look ahead restriction. Look ahead else resolves the classic dangling else problem in the usual way. That is, when the choice of associated if is otherwise ambiguous, the else is associated with the nearest, innermost, of the candidate ifs. ECMA International 2024 299 14 6 1 Static semantics. Early errors. If statement. If. expression statement else statement. It is a syntax error if is labeled function. The first statement is true. It is a syntax error if is labeled function. The second statement is true. If statement, if, expression statement. It is a syntax error if is labeled function. Statement is true. Note it is only necessary to apply this rule if the extension specified in B 3.1 is implemented. 4, 6, to runtime semantics. Evaluation. If statement, if, expression statement else statement. Let x per f be. Evaluation of expression. Let x per value be to boolean. Get value, x per f. If x per value is true, then let stmt completion be completion. Evaluation of the first statement 4. Else let stmt completion be completion. Evaluation of the second statement 5. Return. Update empty. stmt completion. Undefined. If statement, if, expression statement. Let x per f be. Evaluation of expression. Let x per value be to boolean. Get value, x per f. If x per value is false, then return undefined 4. Else let stmt completion be completion. Evaluation of statement be return. Update empty. stmt completion. Undefined. 4.7 iteration statement syntax. Iteration statement. Yield. Await. Return. Do while statement yield await return. While statement yield await return. For statement yield await return. For an of statement yield await return. 4, 7, 1 semantics. 4, 7, 1. 1 loop continues. Completion. Label set. The abstract operation loop continues takes arguments completion, a completion record, and label set, a list of strings, and returns a boolean. It performs the following steps when called. If completion is a normal completion, return true. If completion is not a continue completion, return false. If completion is empty, return true. 300. ECMA International 2024. 4. If label set contains completion, return true. Return false. 4, 7, 1. To runtime semantics. Loop evaluation. The syntax-directed operation loop evaluation takes argument label set, a list of strings, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It is defined piecewise over the following productions. Iteration statement, do while statement, return. Do while loop evaluation of do while statement with argument label set. Iteration statement, while statement, return. While loop evaluation of while statement with argument label set. Iteration statement, for statement, return. For loop evaluation of for statement with argument label set. Iteration statement, for an of statement, return. For an of loop evaluation of for an of statement with argument label set 1 4, 7, to the do while statement. Syntax. Do while statement, yield, await, return. Do statement yield await return. While, expression, plus in yield await. 4, 7, 2, 1 static semantics. Early errors. Do while statement, do statement while, expression, it is a syntax error if is labeled function, statement, is true. Note it is only necessary to apply this rule if the extension specified in B 3.1 is implemented 1 4, 7, 2, to runtime semantics. Do while loop evaluation. The syntax-directed operation do while loop evaluation takes argument label set, a list of strings, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It is defined piecewise over the following productions. Do while statement, do statement while, expression, let v be undefined 2. Repeat, let stmt result be completion, evaluation of statement, b if loop continues, stmt result, label set, is false, return. Update empty, stmt result, v, see if stmt result is not empty, set v to stmt result, d let x per f be. Evaluation of expression. Note within the statement part of an iteration statement a continue statement may be used to begin a new iteration. Copyright sign, ECMA International 2024 301. E let x per value be. Get value, x per f. F if to boolean, x per value, is false. Return v. 4, 7. 3 while statement syntax. While statement, yield, await, return, while, expression, plus in yield await, statement yield await return. 4. 7. 3. 1 static semantics, early errors. While statement, while, expression statement. It is a syntax error if is labeled function, statement, is true. Note it is only necessary to apply this rule if the extension specified in B3.1 is implemented. 1.4.7.3 to runtime semantics. While loop evaluation. The syntax-directed operation while loop evaluation takes argument label set, a list of strings, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It is defined piecewise over the following productions. While statement, while, expression statement, let v be undefined. 2. Repeat, a let x per f be. Evaluation of expression, b let x per value be. Get value, x per f, see if to boolean, x per value, is false. Return v, d let stmt result be completion. Evaluation of statement, e if loop continues, stmt result, label set, is false. Return. Update empty, stmt result, v, f if stmt result is not empt, y, set v to stmt result. 4. 7. Fourth f for statement syntax. For statement, yield, await, return. 4. Look ahead let, expression, in yield await opt. 1.4.7. 4. 1. Expression, plus in yield await opt, expression, plus in yield await opt, statement yield await return. 4. var variable declaration list, in yield await, expression, plus in yield await opt, expression, plus in yield await opt, statement yield await return. 4. Lexical declaration, in yield await, expression, plus in yield await opt, expression, plus in yield await opt, statement yield await return. Static semantics, early errors. For statement. 4. Expression not, expression not, expression not statement. 4. var variable declaration list, expression not, expression not statement. 4. Lexical declaration expression not, expression not statement. 02. ECMA International 2024. It is a syntax error if is labeled function, statement, is true. Note it is only necessary to apply this rule if the extension specified in B3.1 is implemented. For statement. 4. Lexical declaration expression not, expression not statement. It is a syntax error if any element of the bound names of lexical declaration also occurs in the are declared names of statement. 4. 7. 4. To runtime semantics. For loop evaluation. The syntax-directed operation for loop evaluation takes argument label set, a list of strings, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It is defined piecewise over the following productions. For statement. 4. Expression not, expression not, expression not statement. If the first expression is present, then a let x per f be. Evaluation of the first expression be perform. Get value, x per f. If the second expression is present, let test be the second expression, otherwise, let test be empty. If the third expression is present, let increment be the third expression, otherwise, let increment be empty. Return. For body evaluation, test, increment, statement, label set. For statement. 4. var variable declaration list, expression not, expression not statement. Perform. Evaluation of variable declaration list. If the first expression is present, let test be the first expression, otherwise, let test be empty. If the second expression is present, let increment be the second expression, otherwise, let increment be empty. Return. For body evaluation, test, increment, statement, label set. For statement. 4. Lexical declaration expression not, expression not statement. Let old env be the running execution context's lexical environment. Let loop env be new declarative environment. Old env. Let is const be as constant declaration of lexical declaration. Let bound names be the bound names of lexical declaration. For each element dn of bound names, Do if this const is true, then I perform loop env create immutable binding. Dn true eb else I perform loop env create mutable binding. Dn false set the running execution context's lexical environment to loop env. Let for DCL be completion. Evaluation of lexical declaration. If for DCL is an abrupt completion, then A set the running execution context's lexical environment to old env. B return for DCL. If this const is false, let per iteration let's be bound names. Otherwise let per iteration let's be a new empty list. 0. If the first expression is present, let test be the first expression. Otherwise, let test be empty. 1. If the second expression is present, let increment be the second expression. Otherwise, let increment be empty. 2. Let body result be completion. For body evaluation, test, increment, statement, per iteration let's, label set. 3. Set the running execution context's lexical environment to old env. 4. Return body result. Copyright sign, ECMA International 2024 303. 147. 3 for body evaluation, test, increment, STMT, per iteration bindings, label set. The abstract operation for body evaluation takes arguments test, an expression pars node or empty, increment, an expression pars node or empty, STMT, a statement pars node, per iteration bindings, a list of strings, and label set. A list of strings, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It performs the following steps when called. Let v be undefined. Perform. Create per iteration environment. Per iteration bindings. Repeat. If test is not empty, then I let test ref be. Evaluation of test. 2. Let test value be. Get value. Test ref. 3. If to boolean, test value, is false, return v. B let result be completion. Evaluation of STMT. See if loop continues. Result, label set, is false, return. Update empty, result, v. D if result is not empty, set v to result. Perform. Create per iteration environment, per iteration bindings. F if increment is not empty, then I let incref be. Evaluation of increment. 2. Perform. Get value, incref. 4. 7. 4. Create per iteration environment, per iteration bindings. The abstract operation create per iteration environment takes argument per iteration bindings, a list of strings, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. If per iteration bindings has any elements, then a let last iteration env be the running execution context's lexical environment. B let outer be last iteration env. C assert. Outer is not null. D let this iteration env be new declarative environment. Outer. E for each element bn of per iteration bindings. Do I perform this iteration env create mutable binding. Bn. False. 2. Let last value be last iteration env get binding value. Bn. True. 3. Perform this iteration env initialize binding. Bn. Last value. F set the running execution context's lexical environment to this iteration env. Return unused. 04. ECMA International 2024. 147. 5. The for of, and for await of statement syntax. For in of statement, yield, await, return. 4. Look. Left-hand side expression yield await. In expression, plus in yield await. Statement.
I found a macro spelled test, but with a 3. So it's T3 ST. And I think it might be close to the macros that I'm looking for, because it's inside of an if. But it's just some older code. So I have to, somewhere I defined a different name besides test that has test inside of it. And there's an opening and a closing. So hopefully I can find that. That's all I'm looking for now. Because I think that's it. So, back to searching through everything for one example so you can copy paste it and use it. I don't have the time to like figure out the whole macro closing, opening. It's like it's way complicated. It's way too complicated to like bother with figuring out. As long as I can find the topmost macros used, I can just put them where I need them, type up the operation, whatever, in JavaScript, wrap the stuff with the macros for that operation, and shuffle around, like parse it, basically, so it can run. So all I need, I don't know, I feel like I'm a teeny bit closer. Once I find it, I'm good. I just have to freaking find it. Whatever the fuck it is. It's so annoying. I thought I saved examples, but I only have like the operations themselves, like lines of code. I don't have examples of like control flow, because I had some. I'm like, oh, that's good. And then there's like the easy part of the macros, but the statements and stuff, like the whole line of like operations to evaluate, that's really complicated. So I have like several different ways to evaluate it, and I have things marked as old, but they're still in the file, and I have the new things. And I kept all the old stuff as reference for the new stuff, and it just made it more confusing to read. I should have deleted the old code, but it's hard to delete shit when you write it up, because then it's like, I don't know, I just gotta like sort through stuff, and once I find it, I'm good to go. I'm gonna keep looking.
Actions. Member expression. Primary expression. If primary expression is either an object literal or an array literal, return true, return false. Member expression. Member expression. Expression. Member expression. Identifier name member expression template literal super property. Meta property. New member expression arguments member expression. Private identifier. New expression. New expression. Left-hand side expression. Call expression. Optional expression. Return false. For declaration. Let or const for binding. Return is destructuring of for binding. For binding. Binding identifier. Return false. 06. ECMA International 2024. For binding. Binding pattern 1. Return true. Note this section is extended by an XB. 3.5. 4. 7. 5. 3 runtime semantics. Capital F. O. R. Capital D. E. C. L. A. R. A. T. I. O. N. Capital B. I. N. D. I. N. G. Capital I. N. I. T. I. A. L. I. Z. The syntax directed operation. Capital F. O. R. Capital D. E. C. L. A. R. A. T. I. O. N. Capital B. I. N. D. I. N. G. Capital I. N. I. T. I. A. L. I. Z. Takes arguments value, an ECMAScript language value, and environment record or undefined. and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions. For declaration, let or const for binding, return. Binding initialization of for binding with arguments value and environment. 4, 7, 5. For runtime semantics, capital F, O, R, capital D, E, C, L, A, R, A, T, I, O, N, capital B, I, N, D, I, N, G, capital I, N, S, T, A, N, T, I, A. The syntax directed operation, capital F, O, R, capital D, E, C, L, A, R, A, T, I, O, N, capital B, I, N, D, I, N, G, capital I, N, S, T, A, N, T, I, A, takes argument environment a declarative environment record, and returns unused. It is defined piecewise over the following productions. For declaration, let or const for binding. For each element name of the bound names if for binding, do a if this constant declaration of let or const is true. Then, I perform environment create immutable binding. Name. True be else, I perform environment create mutable binding. Name. Force 2. Return unused. 4, 7, 5. 5 runtime semantics. For an of loop evaluation, the syntax directed operation for an of loop evaluation takes argument label set, a list of strings, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It is defined piecewise over the following productions. For an of statement, 4. Left-hand side expression in expression statement, let key result be. For an of head evaluation, expression, enumerate, return. For an of body evaluation, left-hand side expression, statement, key result, enumerate, assignment, label set. For an of statement, 4. R4, binding in expression statement, let key result be. For an of head evaluation, expression, enumerate, return. For an of body evaluation, for binding, statement, key result, enumerate, var binding, label set. Note undefined is passed for environment to indicate that a put value operation should be used to assign the initialization value. This is the case for var statements in the formal parameter lists of some non-strict functions. See the 10th of February 2011. In those cases, a lexical binding is hoisted and pre-initialized prior to evaluation of its initializer. ECMA International 2024 307. For an of statement, 4. For declaration in expression statement, let key result be. For an of head evaluation, bound names of for declaration, expression, enumerate, return. For an of body evaluation, for declaration, statement, key result, enumerate, lexical binding, label set. For an of statement, 4. Left-hand side expression of assignment expression statement, let key result be. For an of head evaluation, assignment expression, iterate, return. For an of body evaluation, left-hand side expression, statement, key result, iterate, assignment, label set. For an of statement, 4. var for binding of assignment expression statement, let key result be. For an of head evaluation, assignment expression, iterate, return. For an of body evaluation, for binding, statement, key result, iterate, var binding, label set. For an of statement, 4. For declaration of assignment expression statement, let key result be. For an of head evaluation, bound names of for declaration, assignment expression, iterate, return. For an of body evaluation, for declaration, statement, key result, iterate, lexical binding, label set. For an of statement, for await, left-hand side expression of assignment expression statement, let key result be. For an of head evaluation, assignment expression, async iterate, return. For an of body evaluation, left-hand side expression, statement, key result, iterate, assignment, label set, async. For an of statement, For await, var for binding of assignment expression statement, let key result be. For in of head evaluation, assignment expression, async iterate, return. For in of body evaluation, for binding, statement, key result, iterate, var binding, label set, async. For in of statement, for await, for declaration of assignment expression statement, let key result be. For in of head evaluation, bound names of for declaration, assignment expression, async iterate, return. For in of body evaluation, for declaration, statement, key result, iterate, lexical binding, label set, async. Note this section is extended by an XB 3.5, 4, 7, 5, 6 for in of head evaluation, uninitialized bound names, expr, iteration kind. The abstract operation for in of head evaluation takes arguments uninitialized bound names, a list of strings, expr, an expression parse node or an assignment expression parse node, and iteration kind, enumerate, iterate, or async iterate, and returns either a normal completion containing an iterator record or an abrupt completion. It performs the following steps when called. 1. 2. Let old env be the running execution context's lexical environment. If uninitialized bound names is not empty, then 08 ECMA International 2024 ABC D assert uninitialized bound names has no duplicate entries. Let new env be new declarative environment. Old env for each string name of uninitialized bound names. Do I perform new env create mutable binding name false. Set the running execution context's lexical environment to new env. 3. Let expref be completion evaluation of expr. Set the running execution context's lexical environment to old env. Let expr value be get value expref. If iteration kind is enumerate, then if expr value is either undefined or null, then I return completion record, break, empty, empty. B let obj be to object expr value. C let iterator be enumerate object properties. Obj d let next method be jet iterator. Next e return the iterator record. Iterator next method false. Else a assert iteration kind is either iterate or async iterate. B if iteration kind is async iterate, let iterator kind be async. C else let iterator kind be sync. D return get iterator expr value iterator kind. The abstract operation for in of body evaluation takes arguments LHS, a parse node, STMT, a statement parse node, iterator record, an iterator record, iteration kind, enumerate or iterate, LHS kind, assignment, var binding, or lexical binding, and label set, a list of strings, and optional argument iterator kind, sync or async, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It performs the following steps when called. If iterator kind is not present, set iterator kind to sync. Let old env be the running execution context's lexical environment. Let v be undefined. Let destructuring be as destructuring of LHS. If destructuring is true and LHS kind is assignment, then a assert LHS is a left-hand side expression. B let assignment pattern be the assignment pattern that is covered by LHS. Repeat. A let next result be call iterator record. Iterator record. B if iterator kind is async. Set next result 2. Await next result. C if next result is not an object. Throw a type error exception. D left done B. Iterator complete. Next result. E if done is true. Return V. F let next value be iterator value. Next result. G if LHS kind is either assignment or var binding, then I if destructuring is true. Then if LHS kind is assignment, then a let status be completion. Destructuring assignment evaluation of assignment pattern with argument next value 2. Else A assert LHS kind is var binding. B assert LHS is a for binding. C let status be completion. Binding initialization of LHS with argument S next value and undefined. 2. Else let LHS ref be completion. Evaluation of LHS It may be evaluated repeatedly. If LHSref is an abrupt completion, then a let status be LHSref3. Else, a let status be completion. Put value, LHSref. Next value, else. I assert, LHS kind is lexical binding. 2. Assert, LHS is a for declaration. 3. Let iteration env be new declarative environment. Old env, I've. Perform. Capital F, O, R, capital D, E, C, L, A, R, A, T, I, O, N, capital B, I, N, D, I, N, G, capital I, N, S, T, A, N, T, I, A, of LHS with argument iteration en v, for in of body evaluation, LHS, STMT, iterator record, iteration kind, LHS kind, label set, iterator kind, 4, 7, 5, 7, ECMA International 2024 309, 1, 4, 7, 5, 8, runtime semantics, evaluation, v set the running execution context's lexical environment to iteration env, v. If destructuring is true, then, let status be completion, for declaration binding initialization of LHS with arguments next value and iteration env, 7. Else, assert, LHS binds a single name. Let LHS name be the sole element of bound names of LHS. Let LHSref be. Resolve binding. LHS name. Let status be completion. Initialize reference binding. LHSref. Next value. If status is an abrupt completion, then I set the running execution context's lexical environment to old env 2. If iterator kind is async, return. Async iterator close. Iterator record. Status 3. If iteration kind is enumerate, then return status ive. Else assert. Iteration kind is iterate. Return. Iterator close. Iterator record. Status j let result be completion. Evaluation of STMT. K set the running execution context's lexical environment to old env. L if loop continues. Result. Label set. Is false. Then, if iteration kind is enumerate, then 1. Return. Update empty. Result. v2. Else assert. Iteration kind is iterate. Set status to completion. Update empty. Result. v. If iterator kind is async. Return. Async iterator close. Iterator record. Status. Return. Iterator close. Iterator record. Status. If result is not empty, set v to result. Binding identifier. Identifier. Yield await. Let binding id be string value of binding identifier. Return. Resolve binding. Binding id. 4, 7, 5, 9. Enumerate object properties. O. The abstract operation enumerate object properties takes argument O, an object, and returns an iterator. It performs the following steps when called. Return an iterator object, 2, 7, 1, 1, 2, whose next method iterates over all the string-valued keys of enumerable properties of O. The iterator object is never directly accessible to ECMAScript code. The mechanics and order of enumerating the properties is not specified but must conform to the rules specified below. The iterator's throw and return methods are null and are never invoked. The iterator's next method processes object properties to determine whether the property key should be returned as an iterator value. Returned property keys do not include keys that are symbols. Properties of T. target object may be deleted during enumeration. A property that is deleted before it is processed by the iterator's next method is ignored. If new properties are added to the target object during enumeration, the newly added properties are not guaranteed to be processed in the active enumeration. A property name will be returned by the iterator's next method at most once in any enumeration. Enumerating the properties of the target object includes enumerating properties of its prototype, and the prototype of the prototype, and so on, recursively. But a property of a prototype is not processed if it has the same 10 copyright sign, ECMA International 2024 name as a property that has already been processed by the iterator's next method. The values of attributes are not considered when determining if a property of a prototype object has already been processed. The enumerable property names of prototype objects must be obtained by invoking enumerate object properties passing the prototype object as the argument. Enumerate object properties must obtain the own property keys of the target object by calling its internal method. Property attributes of the target object must be obtained by calling its internal method. In addition, if neither row nor any object in its prototype chain is a proxy exotic object, typed array, module namespace exotic object, or implementation provided exotic object, then the iterator must behave as with the iterator given by create for an iterator, O until one of the following occurs: the value of the internal slot of O or an object in its prototype chain changes, a property is removed from O or an object in its prototype chain, a property is added to an object in O's prototype chain, or the value of the attribute of a property of O or an object in its prototype chain changes. Note 1. ECMAScript implementations are not required to implement the algorithm in 1.4.7.1.0.2. 1 directly. They may choose any implementation whose behavior will not deviate from that algorithm unless one of the constraints in the previous paragraph is violated. The following is an informative definition of an ECMAScript generator function that conforms to these rules. Function enumerate object properties. obj const visited equals new set. 4. Const key of reflect own keys. obj if type of key equals symbol. Continue. Const desk equals reflect get own property descriptor. obj key if desk visited add key if desk enumerable yield key. Const proto equals reflect get prototype of obj if proto equals null. Return 4. Const proto key of enumerate object properties. Proto if visited has proto key yield proto key. Note to the list of exotic objects for which implementations are not required to match create for an iterator was chosen because implementations historically differed in behavior for those cases and agreed in all others. 4, 7, 5, 1, 0 for an iterator objects. A for an iterator is an object that represents a specific iteration over some specific object. For an iterator objects are never directly accessible to ECMAScript code. They exist solely to illustrate the behavior of enumerate object properties. ECMA International 2024 311 1475101 create for an iterator object. The abstract operation create for an iterator takes argument object, an object, and returns a for an iterator. It is used to create a for an iterator object which iterates over the own and inherited enumerable string properties of object in a specific order. It performs the following steps when called. Let iterator be ordinary object create. % for an iterator prototype %. Set iterator to object. Set iterator to false. Set iterator to a new empty list. Set iterator to a new empty list. Return iterator 4, 7, 5, 1, 0. To the % for an iterator prototype % object. The % for an iterator prototype % object has properties that are inherited by all for an iterator objects. Is an ordinary object. Has an internal slot whose value is % iterator prototype %. Is never directly accessible to ECMAScript code. Has the following properties: 4, 7, 5, 1, 0, 2. 1% for an iterator prototype %. Next, let O be this value. Assert O is an object. Assert O has all of the internal slots of a for an iterator instance. 1, 4, 7, 5, 1, 0, 3. Let object be O. Repeat. If O is false, then I let keys be object. 2. For each element key of keys, do. If key is a string, then A append key to O3. Set O to true. B repeat. While O is not empty, I let R be the first element of O. 2. Remove the first element from O. 3. If there does not exist an element V of O such that same value, R, V, is true, then let desk be object, R. If desk is not undefined, then A append R to O. B if desk is true, return create I to result object, R. False. C set object to object. D set O to object. E set O to false. F if object is null, return create I to result object, undefined. True. 4, 7, 5, 1, 0. 3 properties of for an iterator instances. For an iterator instances are ordinary objects that inherit properties from the %for an iterator prototype %intrinsic object. For an iterator instances are initially created with the internal slots listed in Table 39. 12. Copyright sign. ECMA International 2024. Table 39. Internal slots of for an iterator instances. Internal slot. Type. Description. Object. An object. The object value whose properties are being iterated. Object was visited. A boolean. True if the iterator has invoked on. False otherwise. Visited keys. A list of strings. The values that have been emitted by this iterator thus far. Remaining keys. A list of strings. The values remaining to be emitted for the current object before iterating the properties of its prototype. If its prototype is not null. 14.8 The continue statement syntax. Continue statement. Yield. Await. Continue. Continue. No line terminator here. Label identifier yield await. 148. 1 Static semantics. Early errors. Continue statement. Continue. Continue label identifier. It is a syntax error if this continue statement is not nested, directly or indirectly, but not crossing function or static initialization block boundaries within an iteration statement. 148. 2 Runtime semantics. Evaluation. Continue statement. Continue. Return completion record. Continue. Empty. Empty. Continue statement. Continue label identifier. Let label be the string value of label identifier. Return completion record. Continue. Empty. Label. 4.9 The break statement syntax. Break statement. Yield. Await. Break. Break. No line terminator here. Label identifier yield await. 149. 1 Static semantics. Early errors. Break statement. Break. ECMA International 2024. 13. It is a syntax error if this break statement is not nested, directly or indirectly, but not crossing function or static initialization block boundaries within an iteration statement or a switch statement. 4. 9. 2 Runtime semantics. Evaluation. Break statement. Break. Return completion record. Break. Empty. Empty. Break statement. Break label identifier. Let label be the string value of label identifier. Return completion record. Break. Empty. Label. 4.10 The turn statement syntax. Return statement. Yield. Await. Return. Return. No line terminator here. Expression. Plus and yield await. 4. 10. 1 Runtime semantics. Evaluation. Return statement. Return. Return completion record. Return. Undefined. Empty. Return statement. Return expression. Let exp_ref be. Evaluation of expression. Let exp value be. Get value. Exp_ref. If get generator kind is a sync. Set exp value to. Await. Exp value. Return completion record. Return. Exp value. Empty. A return statement causes a function to cease execution and, in most cases, returns a value to. Note the caller. If expression is emitted, the return value is undefined. Otherwise, the return value is the value of expression. A return statement may not actually return a value to the caller depending on surrounding context. For example, in a try block, a return statement's completion record may be replaced with another completion RD during evaluation of the finally block. Legacy. 4.11 Fewth statement. Note: one use of the legacy with statement is discouraged in new ECMAScript code. Consider alternatives that are permitted in both strict mode code and non-strict code, such as destructuring assignment. 14. ECMA International 2024. Syntax. With statement. Yield. Await. Return. With expression. Plus and yield await. Statement yield await return. 4. 1. 1 Static semantics. Early errors. With statement. With expression statement. It is a syntax error if the source text matched by this production is contained in strict mode code. It is a syntax error if is labeled function. Statement is true. Note it is only necessary to apply the second rule if the extension specified in B3.1 is implemented. 4. 1. 2 Runtime semantics. Evaluation. With statement. With expression statement. Let val be. Evaluation of expression. Let obj be to object. Get value. Val. Let old env be the running execution context's lexical environment. Let new env be new object environment. Obj. True. Old env. Set the running execution context's lexical environment to new env. Let C be completion. Evaluation of statement. Set the running execution context's lexical environment to old env. Return. Update empty. C. Undefined. Note 2. The with statement adds an object environment record for a computed object to the lexical environment of the running execution context. It then executes a statement using this augmented lexical environment. Finally, it restores the original lexical environment. Note, no matter how control leaves the embedded statement, whether normally or by some form of abrupt completion or exception, the lexical environment is always restored to its former state. 4.12 The switch statement syntax. Switch statement. Yield. Await. Return. Switch. Expression. Plus in yield await. Case block yield await return. Case block. Yield. Await. Return. Case clauses yield await return opt. Case clauses yield await return opt. Default clause yield await return. Case clauses yield await return opt. Case clauses yield await return. Case clause yield await return. Case clauses yield await return. Case clause yield await return. ECMA International 2024 315. Case clause yield await return. Case expression plus in yield await. Statement list yield await return opt. Default clause yield await return. Default statement list yield await return opt. 4.12 static semantics. Early errors. Switch statement. Switch. Expression. Case block. It is a syntax error if the lexically declared names of case block contains any duplicate entries. It is a syntax error if any element of the lexically declared names of case block also occurs in the are declared names of case block. 4.12 runtime semantics. Case block evaluation. The syntax-directed operation case block evaluation takes argument input, any ECMAScript language value, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It is defined piecewise over the following productions. Case block. Return undefined. Case block. Case clauses. Let V be undefined. Let A be the list of case clause items in case clauses. In source text order, let found be false. For each case clause C of A. Do. If found is false, then I set found to. Case clause is selected. C. Input. B. If found is true, then I let R be completion. Evaluation of C. 2. If R is not empty, set V to R. 3. If R is an abrupt completion, return. Update empty. R. V. Return V. Case block. Case clause assopt. Default clause case clause assopt. Let V be undefined. If the first case clauses is present, then let A be the list of case clause items in the first case clauses. In source text order 3. Else let A be a new empty list. Let found be false. For each case clause C of A. Do. If found is false, then I set found to. Case clause is selected. C. Input. B. If found is true, then I let R be completion. Evaluation of C. 2. If R is not empty, set V to R. 3. If R is an abrupt completion, return. Update empty. R. V. Let found INB be false. If the second case clauses is present, then let B be the list of case clause items in the second case clauses. In source text order 8. Else let B be a new empty list 9. If found is false, then 16. ECMA International 2024. For each case clause C of B. Do. I have found INB is false. Then set found INB to. Case clause is selected. C. Input 2. If found INB is true, then let R be completion. Evaluation of case clause C. If R is not empty, set V to R. If R is an abrupt completion, return. Update empty. R. V. 0. If found INB is true, return V. 1. Let default be completion. Evaluation of default clause 2. If defaulter is not empty, set V to defaulter. 3. If defaulter is an abrupt completion, return, update empty, defaulter, v4. Note, the following is another complete iteration of the second case clauses. 5. For each case clause C of B, do a let R be completion, evaluation of case clause C, B if R is not empty, set V to R, C if R is an abrupt completion, return, update empty, R, V6, return V4, 1, 2, 3 case clause is selected, C, input, the abstract operation case clause is selected takes argument C, a case clause parse node, and input, an ECMAScript language value, and returns either a normal completion containing a boolean or an abrupt completion. It determines whether C matches input. It performs the following steps when called. Assert. C is an instance of the production case clause. Case expression. Statement list opt. Let X per F be. Evaluation of the expression of C. Let clause select to be. Get value. X per F. Return is strictly equal. INP. At. Clause selector. 4. 1, 2. For runtime semantics. Evaluation switch statement. Switch. Expression. Case block. Let X per F be. Evaluation of expression. Let switch value be. Get value. X per F. Let old env be the running execution context's lexical environment. Let block env be new declarative environment. Old env perform block declaration instantiation. Case block. Block env. Set the running execution context's lexical environment to block env. Let R be completion. Case block evaluation of case block with argument switch value. Set the running execution context's lexical environment to old env. Return R. Case clause. Case expression. 1. Return empty. Case clause. Case expression. Statement list 1. Return. Evaluation of statement list. Note this operation does not execute C's statement list, if any. The case block algorithm uses its return value to determine which statement list to start executing. Note, no matter how control leaves the switch statement, the lexical environment is always restored to its former state. ECMA International 2024 317. Default clause. Default. 1. Return empty. Default clause. Default. Statement list 1. Return. Evaluation of statement list. 4.13 Labeled statement syntax. Labeled statement. Yield. Await. Return. Label identifier yield await. Labeled item yield await return. Labeled item. Yield. Await. Return. Statement yield await return. Function declaration yield await. Default. 4. 1 3. 1 Static semantics. Early errors. Labeled item. Function declaration. It is a syntax error if any source text is matched by this production. Note an alternative definition for this rule is provided in B 3.1, 1.4, 1.3, 2 Static semantics is labeled function, STMT. The abstract operation is labeled function takes argument STMT, a statement parse node, and returns a boolean. It performs the following steps when called. If STMT is not a labeled statement, return false. Let item be the labeled item of STMT. If item is labeled item, function declaration, return true. Let sub STMT be the statement of item. Return is labeled function, sub STMT. 4. 1 3. 3 Runtime semantics. Evaluation labeled statement. Label identifier. Labeled item. Return. Labeled evaluation of this labeled statement with argument. Note a statement may be prefixed by a label. Labeled statements are only used in conjunction with labeled break and continue statements. ECMAScript has no goto statement. A statement can be part of a labeled statement, which itself can be part of a labeled statement, and so on. The labels introduced this way are collectively referred to as the current label set when describing the semantics of individual statements. 318. ECMA International 2024. 1.4. 1.3. For runtime semantics. Labeled evaluation. The syntax-directed operation labeled evaluation takes argument label set, a list of strings, and returns either a normal completion containing an ECMAScript language var or an abrupt completion. It is defined piecewise over the following productions. Breakable statement. Iteration statement. Let STMT result be completion. Loop evaluation of iteration statement with argument label set. If STMT result is a break completion, then if STMT result is empty, then if STMT result is empty, set STMT result to normal completion, undefined. 2. Else. Set STMT result to normal completion. STMT result. Return STMT result. Breakable statement. Switch statement. Let STMT result be completion. Evaluation of switch statement. If STMT result is a break completion, then if STMT result is empty, then if STMT result is empty, set STMT result to normal completion, undefined. 2. Else. Set STMT result to normal completion. STMT result. Return STMT result. Note 1. A breakable statement is one that can be exited via an unlabeled break statement. Labeled statement. Label identifier. Labeled item. Let label be the string value of label identifier. Let new label set be the list concatenation of label set and label. Let STMT result be completion. Labeled evaluation of labeled item with argument new label set. If STMT result is a break completion and STMT result is label, then A set STMT result to normal completion. STMT result 5. Return STMT result. Labeled item. Function declaration. Return. Evaluation of function declaration. Statement. Block statement. Variable statement. Empty statement. Expression statement. If statement. Continue statement. Break statement. Return statement with statement. Throw statement. Try statement. Debugger statement. Return. Evaluation of statement. Note 2. The only two productions of statement which have special semantics for labeled evaluation are breakable statement and labeled statement. ECMA International 2024 319 14.14 Throw statement syntax. Throw statement. Yield. Await. Throw. No line terminator here. Expression. Plus in yield await. 4. 1 4. 1 runtime semantics. Evaluation. Throw statement. Throw expression. Let x per f be. Evaluation of expression. Let x per value be. Get value. X per f. Return. Throw completion. X per value. 4.15 Tree statement syntax. Try statement. Yield. Await. Return. Try block yield await return. Catch yield await return. Try block yield await return. Finally yield await return. Try block yield await return. Catch yield await return. Finally yield await return. Catch. Yield. Await. Return. Catch. Catch parameter yield await. Block yield await return. Catch block yield await return. Finally. Yield. Await. Return. Finally block yield await return. Catch parameter. Yield. Await. Binding identifier yield await. Binding pattern yield await. 4. 1 5. 1 static semantics. Early errors. Catch. Catch parameter, block. It is a syntax error if bound names of catch parameter contains any duplicate elements. It is a syntax error if any element of the bound names of catch parameter also occurs in the lexically declared names of block. It is a syntax error if any element of the bound names of catch parameter also occurs in the are declared names of block. Note an alternative static semantics for this production is given in B. 3.4 Note, the try statement encloses a block of code in which an exceptional condition can occur, such as a runtime error or a throw statement. The catch clause provides the exception handling code. When a catch clause catches an exception, its catch parameter is bound to that exception. 320 ECMA International 2024 1415 2 Runtime semantics. Catch clause evaluation. The syntax-directed operation catch clause evaluation takes argument thrown value, an ECMAScript language value, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It is defined piecewise over the following productions. Catch parameter, block. Let old-env be the running execution context's lexical environment. Let catch-env be new declarative environment. Old-env, for each element argname of the bound names of catch parameter. Do, perform catch-env create mutable binding. Argname. False. Set the running execution context's lexical environment catch-env. Let status be completion. binding initialization of catch parameter with arguments thrown value and catch env. If status is an abrupt completion, then A. Set the running execution context's lexical environment to old env. B. Return status. Let B be completion. Evaluation of block. Set the running execution context's lexical environment to old env. Return. B. Catch. Catch block. Return. Evaluation of block. 4, 1, 5, 3 runtime semantics. Evaluation. Try statement. Try block catch. Let B be completion. Evaluation of block. If B is a throw completion, let C be completion. Catch clause. Evaluation of catch with argument B. Else. Let C be B. Return. Update empty. C. Undefined. Try statement. Try block. Finally. Let B be completion. Evaluation of block. Let F be completion. Evaluation of finally. If F is a normal completion, set F to B. Return. Update empty. F. Undefined. Try statement. Try block catch. Finally. Let B be completion. Evaluation of block. If B is a throw completion, let C be completion. Catch clause. Evaluation of catch with argument B. Else. Let C be B. Let F be completion. Evaluation of finally. If F is a normal completion, set F to C. Return. Update empty. F. Undefined. Note: no matter how control leaves the block, the lexical environment is always restored to its former state. ECMA International 2024 321 14.16. The debugger statement syntax. Debugger statement. Debugger. 4, 1, 6. 1 runtime semantics. Evaluation. Debugger statement. Debugger. If an implementation-defined debugging facility is available and an ed, then A. Perform an implementation-defined debugging action. B. Return a new implementation-defined completion record. Else A. Return empty. 5. ECMAScript language. Functions and classes. 5.1 Parameter lists. Syntax. Unique formal parameters. Yield. Await. Formal parameters. Yield. Await. Formal parameters. Yield. Await. Empty. Function rest parameter. Yield. Await. Formal parameter list. Yield. Await. Formal parameter list. Yield. Await. Formal parameter list. Yield. Await. Function rest parameter. Yield. Await. Formal parameter list. Yield. Await. Formal parameter. Yield. Await. Formal parameter list. Yield. Await. Formal parameter. Yield. Await. Function rest parameter. Yield. Await. Binding rest element. Yield. Await. Formal parameter. Yield. Await. Binding element. Yield. Await. 5, 1. 1 static semantics. Early errors. Unique formal parameters. Formal parameters. 22. Copyright sign. ECMA International 2024. Note: evaluating a debugger statement may allow an implementation to cause a breakpoint when run under a debugger. If a debugger is not present or active, this statement has no observable effect. Note: various ECMAScript language elements cause the creation of ECMAScript function objects. 10.2. Evaluation of such functions starts with the execution of their internal method. 102. 1. It is a syntax error if bound names of formal parameters contains any duplicate elements. Formal parameters. Formal parameter list. It is a syntax error if is simple parameter list of formal parameter list is false and bound names of formal parameter list contains any duplicate element. 5. 1. 2 static semantics. Contains expression. Ax-directed operation contains expression, takes no arguments and returns a boolean. It is defined piecewise over the following productions. Object binding pattern. Binding rest property. 1. Return false. Object binding pattern. Binding property list. Binding rest.
I have a define guard for like version 3, whatever in the program. So on means it's version 3. I'm reading my notes. Off means it's not. And I have in my notes whatever. Use this toggle to disable the E3 shit, so it won't be included when testing the 012. And then I have another note, but will default to version 2. comma, need to change below for version 0 or version 1. So I think when I turn this toggle off, it'll be version 2, unless I define one of the defines below, which are two separate ones for version 0 or version 1 individually. And I think those are both off. And when both are off is when it's version 2. Because I wrap stuff in version 0 and version 1 as off, and then version 2 was everything that's added around what was off. And then version 3, I did the same thing again, basically. And it's really confusing. I am so close to finding the stupid freaking macro, but not yet. I'm gonna find it at some point.
Expression of formal parameter list is true. Return true. Return contains expression of formal parameter. Arrow parameters. Binding identifier 1. Return false. Arrow parameters. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Let formals be the arrow formal parameters that is covered by capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Return contains expression of formals. Async arrow binding identifier. Binding identifier. Return false. 5 1 3. Static semantics is simple parameter list. The syntax directed operation is simple parameter list, takes no arguments and returns a boolean. It is defined piecewise over the following productions. Binding element. Binding pattern. Return false 324. ECMA International 2024. Binding element. Binding pattern initializer 1. Return false. Single name binding. Binding identifier 1. Return true. Single name binding. Binding identifier initializer 1. Return false. Formal parameters. Empty. 1. Return true. Formal parameters. Function rest parameter 1. Return false. Formal parameters. Formal parameter list. Function rest parameter 1. Return false. Formal parameter list. Formal parameter list. Formal parameter. If a simple parameter list of formal parameter list is false, return false. Return is simple parameter list of formal parameter. Formal parameter. Binding element. Return is simple parameter list of binding element. Arrow parameters. Binding identifier. Return true. Arrow parameters. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Let formals be the arrow formal parameters that is covered by capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Return a simple parameter list of formals. Async arrow binding identifier. Binding identifier. Return true. Capital C O V E R. Capital C A L L. Capital E X P R E S S I O N. Capital A N D. Capital A S Y N C. Capital A R R. Member expression arguments. Let head be the async arrowhead that is covered by capital C O V E R. Capital C A L L. Capital E X P R E S S I O N. Capital A N D. Capital A S Y N C. Capital A R R. Return a simple parameter list of head. Point 4 static semantics. Has initializer. The syntax-directed operation has initializer takes no arguments and returns a boolean. It is defined piecewise over the following productions. Binding element. Binding pattern. Return false. ECMA International 2024 325. Binding element. Binding pattern initializer 1. Return true. Single name binding. Binding identifier 1. Return false. Single name binding. Binding identifier initializer 1. Return true. Formal parameter list. Formal parameter list. Formal parameter. If his initializer of formal parameter list is true, return true. Return.
I don't want to test the other build modes, since it's possible they might not work. Because it's been a while. It's like, it's really annoyingly complicated. So I'll turn one thing on, and I'll have to like figure out what other things have to be set on for this one thing, and then what other things have to be off. All I want is to do a little test without changing anything, so I know that it might not work, but it doesn't matter because I don't need to turn that stuff on until I need it. So I just want to like touch the outside of the code, not get involved with like all the like included files and other crap. I need to find one single case with a conditional operation. That's all I want. And I know it's somewhere, like right in plain sight, and I'm probably looking past it every single time. So I'm gonna like try looking where I haven't looked in the code, and I might find it.
Z E D capital E X P R E S S I O N capital A N. Return expected argument count of formals. 26. ECMA International 2024. Property set parameter list. Formal parameter. If his initializer of formal parameter is true, return 0. Return 1. Async arrow binding identifier. Binding identifier 1. Return 1. 5.2 function definitions syntax. Function declaration. Yield. Await. Default. Function binding identifier yield await. Formal parameters. Yield. Await. Function body. Yield. Await. Plus default. Function. Formal parameters. Yield. Await. Function body. Yield. Await. Function expression. Function binding identifier. Yield. Await opt formal parameters. yield, await, function body, yield, await, function body, yield, await, function statement list, yield, await, function statement list, yield, await, statement list, yield, await, plus return opt 152, 1 static semantics, early errors, function declaration, function binding identifier, formal parameters, function body, function, formal parameters, function body, function expression, function binding identifier opt, formal parameters, function body. If the source text matched by formal parameters is strict mode code, the early error rules for unique formal parameters. Formal parameters are applied if binding identifier is present and the source text matched by binding identifier is strict mode code. It is a syntax error if the string value of binding identifier is either eval or arguments. It is a syntax error if function body contains use strict if function body is true and is simple parameter list of formal parameters is false. It is a syntax error if any element of the bound names of formal parameters also occurs in the lexically declared names of function body. It is a syntax error if formal parameters contain super property is true. It is a syntax error if function body contains super property is true. It is a syntax error if formal parameters contain supercall is true. It is a syntax error if function body contains supercall is true. Function body. Function statement list. It is a syntax error if the lexically declared names of function statement list contains any duplicate entries. Note the lexically declared names of a function body does not include identifiers bound using var or function declarations. ECMA International 2024 327. It is a syntax error if any element of the lexically declared names of function statement list also occurs in the var declared names of function statement list. It is a syntax error if contains duplicate labels of function statement list with argument is true. It is a syntax error if contains undefined break target of function statement list with argument is true. It is a syntax error if capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E a function statement list with arguments and is true. 5. 2 static semantics. Function body contains use strict. The syntax-directed operation function body contains use strict takes no arguments and returns a boolean. It is defined piecewise over the following productions. Function body. Function statement list. If the directive prologue of function body contains a use strict directive, return true. Otherwise, return false. 5. 2. 3 runtime semantics. Evaluate function body. The syntax-directed operation evaluate.
I have an operation order, an argument list, an object list, and an array list. And that gets contained in a container that could be comma separated. And then there's a semicolon at some point at the end of the list between statement parts. And there's like another wrapper and another wrapper, another macro placed between. It is so many layers. I just want to find one little thing. Wherever the hell I have it, like evaluate, like a statement list, it evaluates to true or false. I have a macro somewhere that holds the evaluation to put inside of an if. I just need to find that. I don't know where the heck it is. I feel like I'm really close. At some point, I'm just gonna see it and be like, that's it. I'm not there yet.
O R D I N A R Y capital F U N C T I O N, capital O B J, takes arguments env, an environment record, and private env, a private environment record or null, and returns an ECMAScript function object. It is defined peak UIs over the following productions: function declaration, function binding identifier, formal parameters, function body. Let name be string value of binding identifier. Let source text be the source text match by function declaration. Let f be ordinary function create, percent function prototype percent, source text, formal parameters, function body, non-lexical this, env, private env, perform cert function name, f, name, perform make constructor, f, return f, function declaration, function, formal parameters, function body. Let source text be the source text match by function declaration. Let f be ordinary function create, percent function prototype percent, source text, formal parameters, function body, non-lexical this, env, private env, perform cert function name, f, default, perform make constructor, f, return f, 328. ECMA International 2024. An anonymous function declaration can only occur as part of an export default declaration. Note, and its function code is therefore always strict mode code. 152.5 Runtime semantics. Capital I N S T A N T I A T E, capital O R D I N A R Y, capital F U N C T I O N, capital E X P. The syntax directed operation, capital I N S T A N T I A T E, capital O R D I N A R Y, capital F U N C T I O N, capital E X P, takes optional argument name, a property key or a private name, and returns an ECMAScript function object. It is defined piecewise over the following productions: function expression, function, formal parameters, function body. If name is not present, set name to. Let env be the lexical environment of the running execution context. Let private env be the running execution context's private environment. Let source text be the source text match by function expression. Let closure be ordinary function create, percent function prototype percent, source text, formal parameters, function body, non-lexical this, env, private env, perform cert function name, closure, name, perform make constructor, closure, return closure, function expression, function binding identifier, formal parameters, function body, assert. Name is not present. Set name to string value of binding identifier. Let outer env be the running execution context's lexical environment. Let funky env be new declarative environment. Outer env perform funky env create immutable binding. Name false. Let private env be the running execution context's private environment. Let source text be the source text match by function expression. Let closure be ordinary function create, percent function prototype percent, source text, formal parameters, function body, non-lexical this, func env, private env, perform cert function name, closure, name 0, perform make constructor, closure 1, perform func env initialize binding, name, closure 2, return closure 5, 2, 6 runtime semantics. Evaluation, function declaration, function binding identifier, formal parameters, function body, 1. Return empty. Note 1 an alternative semantics is provided in B 3.2. Function declaration, function, formal parameters, function body, 1. Return empty. Function expression, function binding identifier opt, formal parameters.
I like disabled stuff in the new mode. To support function calls. And I have a it's the most confusing shit I've ever read. It is so confusing. I don't know how I managed to like I should have It was clever though. It was too clever. I hate myself. This is so complicated. I'll figure it out eventually. It's taking so long.
I-O-N capital A-N yield await concise body in look ahead expression body in await function body yield await expression body in await assignment expression in yield await supplemental syntax when processing an instance of the production arrow parameters.
I was looking for the ifs or whatever, and I'm like trying to figure out everything because I can't find what the fuck I'm looking for. I don't know why the fuck. Where the fuck did it go? It has to be here somewhere. I'm gonna have to like get all old Windows 7 and find it on that drive. If it's not, I think the file's literally not here.
E-N-T-H-E-S-I-Z.
I'm like trying to like piece together what parts tie to what. Now I'm distracted. So I'll like figure this, whatever I'm trying to figure out now. I'm gonna do both, I don't know.
It is a syntax error if arrow parameters contains yield expression is true. It is a syntax error.
I thought I would like just remember, oh this is blah 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 blah, but like it's like fucking levels. On levels, on levels, of levels. Of updates and updates and updates. To optimize and optimize and freaking complicated. Any minute now, I'm gonna be like, ah, got it. Until then, it's
O-N capital A-N capital C-O-V-E-R capital P-A-R-E-N-T-H-E-S-I-Z-E-D capital E-X-P-R-E-S-S-I-O-N capital A-N must cover an arrow formal parameters 1 5 3 2 static semantics Concise body contains use strict. The syntax directed operation concise body contains use strict takes no arguments and returns a boolean. It is defined piecewise over the following productions: concise body, expression body, return false. 30. ECMA International 2024. Arrow parameters: yield, await, binding identifier yield await. Concise body, function body, return function body contains use strict of function.
I don't want to show the code, but I don't know, I defined some things like v2. Like, I should have given it a real fucking name that's longer than v2. I'm trying to find all the things like related to v2, but v2 is like everywhere, so they also tag things with underscore v2 underscore. That's why I use like naming conventions when I try to like name things, because I didn't 8 years ago, but now I do, and now I wish I did. And I have v2 with parentheses, and then v2 without parentheses, and one of them takes an argument and the other one doesn't. Oh, it's so fucking confusing.
A N T I A T E capital A R R O W capital F U N C T I O N capital E X P R E S takes optional argument name, a property key or a private name, and returns an ECMAScript function object. It is defined piecewise over the following productions: arrow function.
Most of the loops, like for testing and stuff, I just made like a normal cint, because I didn't want the overhead of the JavaScript type to show up, because I want to test like everything in the loop, not have like the loop impact the test in some like large way. That's why I don't have ifs and stuff, because I like, or control flow, because I was like setting stuff up to for everything but the fucking control flow. Where the fuck is the control flow? Fuck's sake. I think I gotta like piece a macro together. I gotta figure out how the fuck it's even put together.
Equals concise body return capital I N S T A N T I A T E capital A R R O W capital F U N C T I O N capital E X P R.
Okay, so I can't take this anymore. I'm gonna lose it. I'm gonna replace in the output chatbot gave me. I'm gonna replace these ifs here with conditionals because I found the conditionals, but I can't find like the if control flow and stuff related to it, next to it, or the while loops, or any of that. I don't know where the fuck that stuff is at. It's probably in another file. I'm tired of looking. I'm like overwhelmed with the amount of shit I'm gonna have to like figure out again to like modify anything. So I'm gonna like replace these ifs. This again.
Parameters also occurs I in the lexically declared names of function body, method definition, set class element name, property set parameter list. Function body. It is a syntax error if bound names of property set parameter list contains any duplicate elements. It is a
So I'm gonna replace
to function body is true and is
these ifs here.
error if any element of the bound names of property set parameter list also occurs in the lexically declared name.
Zoom in some more.
To static semantics has direct super. The syntax directed operation has direct.
So I'm gonna replace these ifs with the ternary. And I'll just make the loop counter just a normal C integer. I wanted to use one of my type, whatever, one of my JavaScript variable things. It's so it's using like the internal or whatever instead of just a normal C in. It's not, I don't know. I don't think I'm gonna figure out or find what I'm looking for anytime soon. So I'm gonna make these two ifs, whatever, into conditionals. I'll use just a normal loop counter, and I have the rest of the macros I need to make the object keys and all these globals that hold the object, because the local variables on my system, it's more complicated than the globals. I think I have like 26 globals or something that I predefined for the purpose of debugging. So I'm gonna throw together a test. I'm gonna run it and see how fast it is. I don't know if I'm gonna replace types. I'm kind of stuck in thought. I got so much to think through now. So I'm gonna do that. I don't know, I feel like what I'm looking for is like right in some super obvious place. I'm like totally missing it. But I've looked and I've looked and I like so these conditionals. I'll be back. I'm so annoyed. It's so complicated. And then I have a type for an object list here, like they have whatever JavaScript. I don't know, I think the rest of it should straight up be like the same operations or whatever. I'm just gonna make a test and run it. That's the best. I gotta find the if so. It's so annoying. It has to be somewhere.
Method definition, class element name, unique formal parameters, function body. Let method def be. Define method of method definition with argument object. Perform set function name. Method def. Return. Define method property. Object. Method def. Enumerable. Method definition. Get class element name. Function body. Let proc key be. Evaluation of class element name. Let env be the running execution context's lexical environment. Let private env be the running execution context's private environment. Let source text be the source text match by method definition. Let formal parameter list be an instance of the production formal parameters. Empty. Let closure be ordinary function create. Percent function prototype percent. Source text. Formal parameter list. Function body. Non-lexical this. env. Private env. Perform make method. Closure. Object. Perform set function name. Closure. Prop key. Get. If prop key is a private name, then a return private element. Accessor. Undefined 10. Else a let desc be the property descriptor. Enumerable. True be perform. Define property or throw. Object. Prop key. Desk, see return unused. Method definition, set class element name, property set parameter list. Function body, let prop key be. Evaluation of class element name. Let env be the running execution context's lexical environment. Let private env be the running execution context's private environment. Let source text be the source text match by method definition. Let closure be ordinary function create. Percent function prototype percent. Source text. Property set parameter list. Function body. Non-lexical this. env. Private env. Perform make method. Closure. Object. Perform set function name. Closure. Prop key. Set. If prop key is a private name, then a return private element. Accessor. Closure 9. Else a let desc be the property descriptor. Enumerable. True be perform. Define property or throw. Object. Prop key. Desk. See return unused. Generator method. Class element name. Unique formal parameters. Generator body. Let prop key be. Evaluation of class element name. Let env be the running execution context's lexical environment. Let private env.
This whole thing is so complicated. If it's not faster, it should be. I have the numbers. But I didn't check, like, crap code, like, what Chatbot gave me. I told it to give me, like, a good, like, garbage code to test. I checked, like, normal code that seen people write. So the crap code should run just as fast. Well, it's crap code. If it's rewritten, it'd be better, whatever. But it should still be faster. Unless crap code, like, messes things up because the C compiler's not able to optimize, kind of like normal. The C compiler can't, like, rearrange things depending on how the code or whatever that it's compiling. I just gotta test this. That's all I want to do. So I'm gonna do that in a minute.
Object create. Percent async generator function prototype percent perform. Define property or throw. Closure. Prototype. Property descriptor. Prototype. Writable. True. False. False. 0. Return. Define method property. Object. Prop key. Closure. Enumerable. Async method. async class element name, unique formal parameters, async function body. Let proc key be evaluation of class element name. Let env be the lexical environment of the running execution context. Let private env be the running execution context's private environment. Let source text be the source text matched by async method. Let closure be ordinary function create, %async function prototype %source text. Unique formal parameters, async function body, non-lexical this, env, private env, perform make method, closure, object, perform set function name, closure, prop key, return, define method property, object, prop key, closure, enumerable. 5.5 Generator function definitions syntax, generator declaration, yield, await, default, function binding identifier yield await, formal parameters, plus yield, await, generator body, plus default, function, formal parameters, plus yield, await, generator body, generator expressi on, function binding identifier, plus yield, await opt formal parameters, plus yield, await, generator body, generator method, yield, await, class element name yield await, unique formal parameters, plus yield, await, generator body, function body, plus yield, await, yield expression, in, await, yield, no line terminator here, assignment expression in, plus yield await, yield, no line terminator here, assignment expression in, plus yield await. ECMA International 2024 335. Note 2 Yield expression cannot be used within the formal parameters of a generator function because any expressions that are part of formal parameters are evaluated before the resulting generator is in a resumable state. Note 3 Abstract operations relating to generators are defined in 2.7.5.3.1.5.5.1 static semantics, early errors, generator method, class element name, unique formal parameters, generator body. It is a syntax error if has direct super generator method is true. It is a syntax error if unique formal parameters contains yield expression is true. It is a syntax error if function body contains use strict of generator body is true and is simple parameter list of unique formal parameters is false. It is a syntax error if any element of the bound names of unique formal parameters also occurs in the lexically declared names of generator body, generator declaration, function binding identifier, formal parameters, generator body, function, formal parameters, generator body, generator expression, function binding identifier opt, formal parameters, generator body. If the source text match by formal parameters is strict mode code, the early error rules for unique formal parameters are applied. If binding identifier is present in the source text match by binding identifier is strict mode code, it is a syntax error if the string value of binding identifier is either eval or arguments. It is a syntax error if function body contains use strict of generator body is true and is simple parameter list of formal parameters is false. It is a syntax error if any element of the bound names of formal parameters also occurs in the lexically declared names of generator body. It is a syntax error if formal parameters contains yield expression is true. It is a syntax error if formal parameters contains super property is true. It is a syntax error if generator body contains super property is true. It is a syntax error if formal parameters contains supercall is true. It is a syntax error if generator body contains supercall is true. 5. To runtime semantics. Evaluate generator body. The syntax-directed operation evaluate generator body takes arguments function object, an ECMAScript function object, and arguments list, a list of ECMAScript language values, and returns a throw completion or a return completion. It is defined piecewise over the following productions: generator body, function body, perform, function declaration instantiation, function object, arguments list, let GB, ordinary create from constructor, function object, %generator function prototype %generator brand, set G to empty, perform generator start, G, function body, return completion record, return, G, empty. 36. ECMA International 2024. Note 1 The syntactic context immediately following yield requires use of the capital I, N, P, U, T, capital E, L, E, M, E, N, T, capital R, E, G, capital E, X, P, capital O, R, capital T, E, M, P, L, A, T, E, capital T, A. Lexical goal 155 3 runtime semantics capital I N S T A N T I A T E capital G E N E R A T O R capital F U N C T I O N capital O B. The syntax directed operation capital I N S T A N T I A T E capital G E N E R A T O R capital F U N C T I O N capital O B takes argument CNV, an environment record, and private env, a private environment record or null, and returns an ECMAScript function object. It is defined piecewise over the following productions: generator declaration, function binding identifier, formal parameters, generator body. Let name be string value of binding identifier. Let source text be the source text matched by generator declaration. Let f be ordinary function create. Generator function prototype source text. Formal parameters. Generator body. Non-lexical this. env. Private env. Perform cert function name. F. Name. Let prototype be ordinary object create. Generator function prototype perform. Define property or throw. F. Prototype. Property descriptor. Prototype true. False. False. Return F. Generator declaration. Function. Formal parameters. Generator body. Let source text be the source text matched by generator declaration. Let f be ordinary function create. Generator function prototype source text. Formal parameters. Generator body. Non-lexical this. env. Private env. Perform cert function name. F. Default. Let prototype be ordinary object create. Generator function prototype perform. Define property or throw. F. Prototype. Property descriptor. Prototype true. False. False. Return F. 5 for runtime semantics. Capital I N S T A N T I A T E capital G E N E R A T O R capital F U N C T I O N capital E X. The syntax directed operation capital I N S T A N T I A T E capital G E N E R A T O R capital F U N C T I O N capital E X takes optional argument name, a property key or a private name, and returns an ECMAScript function object. It is defined piecewise over the following productions: generator expression, function, formal parameters, generator body. If name is not present, set name to. Let env be the lexical environment of the running execution context. Let private env be the running execution context's private environment. Let source text be the source text matched by generator expression. Let closure be ordinary function create. Generator function prototype source text. Formal parameters. Generator body. Non-lexical this. env. private env perform set function name, closure, name. Let prototype be ordinary object create, %generate a function prototype %perform. Define property or throw, closure, prototype, property descriptor, prototype, writable, true, false, false, return closure, generator expression, function binding identifier, formal parameters, generator body, assert, name is not present, set name to string value of binding identifier, let outreenv be the running execution context's lexical environment, let funkenv be new declarative environment, outreenv perform funkenv create immutable binding, name, false. Let private env be the running execution context's private environment. Let source text be the source text matched by generator expression. An anonymous generator declaration can only occur as part of an export default declaration. Note, and its function code is therefore always strict mode code. ECMA International 2024 337 8. Let closure be ordinary function create, %generate a function prototype source text, formal parameters, generator body, non-lexical thing.
Try. I'm gonna try to look it one more time. For one of the control flow macros, I'm gonna give up really soon, and then I'm gonna hack it together. Get some kind of test in a minute. I don't have time to make another macro that does control flow because I can't, it's so complicated. I have to really dig in. I'm trying to I don't know, I'm gonna try to find whatever. And then I'm gonna give up and just make some kind of test without using an F or whatever. Let's use a ternary.
U N C T I O N capital E X of generator expression, yield return, yield undefined, yield expression, yield assignment expression. Let X per F be evaluation of assignment expression. Let value be get value X per F. Return yield value, yield expression, yield assignment expression. Let generator kind be get generator kind. Let X per F be evaluation of assignment expression. Let value be get value X per F. Let iterator record be get iterator value generator kind. Let iterator be iterator record. Let received be normal completion undefined. Repeat. Note the binding identifier in a generator expression can be referenced from inside the generator expression's function body to allow the generator code to call itself recursively. However, unlike in a generator declaration, the binding identifier in a generator expression cannot be referenced from and does not affect the scope enclosing the generator expression. 38. ECMA International 2024. A. B. If received is a normal completion, then I let in a result be call iterator record. Iterator record. Received 2. If generator kind is async, set in a result 2. Await in a result 3. If in a result is not an object, throw a type error exception. I've let done be iterato are complete in a result v. If done is true, then return iterator value in a result v. If generator kind is async, set received to completion async generator yield iterator value in a result 7. Else set received to completion generator yield in a result. Else if received is a throw completion, then I2 let throw be get method iterator throw. If throw is not undefined, then 2, 3, 5 let in a result be call throw iterator received. If generator kind is async, set in a result 2. Await in a result. Note, exceptions from the inner iterator throw method are propagated. Normal completions from an inner throw method are processed similarly to an inner next. If in a result is not an object, Throw a type error exception. Let done be. Iterator complete. In a result. 15.6 syntax. If done is true, then error return. Iterator value. In a result. If generator kind is async. Set received to completion. Async generator yield. Iterator value. In a result. Else. Set received to completion. Generator yield. In a result. 3. Else. Note. If iterator does not have a throw method, this throw is going to terminate the yield loop. But first we need to give iterator a chance to clean up. Let close completion be completion record. Normal. Empty. Empty. If generator kind is async. Perform. Async iterator close. Iterator record. Close completion. Else. Perform. Iterator close. Iterator record. Close completion. Note. The next step throws a type error to indicate that there was a yield protocol violation. Iterator does not have a throw method. 6. Throw a type error exception. See else. I assert. Received is a return completion. 2. Let return be. Get method. Iterator. Return. 3. If return is undefined, then set value to received. If generator kind is async, then a set value to await value. Return completion record. Return value. Empty. Let in a return result be. Call. Return. Iterator. Received via if generator.
I just had like a random flashback, and I can remember where tons of shit is at. Not the stuff that I'm looking for, but I don't know. I'm starting to remember this crap. I have a clobber of code, and I got X macros where they expand and they define and they undefine, and I have it sectioned off into groupings, and I'm starting to like remember everything. I'm probably gonna like have like the most boring dream tonight, but I'll wake up remembering a ton of shit. I'll probably wake up just as tired as not sleeping, because I'm gonna be thinking in my sleep. I don't know, I think I figured a whole bunch out.
Unique formal parameters plus yield.
I think I'm closer. I don't know, I'm gonna figure something out. I'm just some kind of freaking test or whatever.
Because any expressions that are part of formal parameters are evaluated before the resulting async generator is in a resumable state. Note 2 abstract operations relating to async generators are defined in 2.7, 6, 3, 1.5, 6, 1 static semantics. Early errors. Async generator method. Async class element name. Unique formal parameters. Async generator body. It is a syntax error if has direct super of async generator method is true. It is a syntax error if unique formal parameters contains yield expression is true. It is
I can finally like kind of get what each macro with its random ass name actually does. Making progress. It's still really fucking complicated, but you can see how, whatever, I don't know.
async generator body. Async generator expression. Async function binding identifier opt. Formal parameters. Async generator body. If the source text matched by formal parameters is strict mode code. The early error rules for unique formal parameters. Formal parameters are applied if binding identifier is present and the source text matched by binding identifier is strict mode code. It is a syntax error if the string value of binding identifier is either.
I found one of the if macros. It's named internal fdat underscore if t underscore. I use the number 3 for the E in internal because I have other things named internal, so I use 3, so it wouldn't be the same thing as those other things named internal. But this is like the inner macro. It's not like the outer macro with all the layers on it. I'm gonna like make up some kind of test and just use conditionals in a second. I think I finally found whatever ish, like close to what I was looking for.
I-O-N, capital I-N-S-T-A-N-T-I-A-T-I, function object, arguments list. Let generator be. Ordinary create from constructor. Function object, %async generator function prototype %async generator context, set generator to empty, perform async generator start, generator, function body, return completion record, return, generator, empty, 40, ECMA International 2024, 156, 3 runtime semantics, capital I-N-S-T-A-N-T-I-A-T-E, capital A-S-Y-N-C, capital G-E-N-E-R-A-T-O-R, capital F-U-N-C-T, the syntax directed operation, capital I-N-S-T-A-N-T-I-A-T-E, capital A-S-Y.
Like I said earlier, whatever, I have like evaluation line, I don't know what they were now, but I got the macros for the A list, the B list, and the C list types. I don't know what the hell A, B, and C stand for, because I defined those to another define, and then to another define, and then to another define. There's like a whole bunch. There's way too many layers. So I gave it just a ABC. It's a really dumb way to categorize things by letter, because I don't know what the fuck it means. It's just a letter. And what it does, I gotta find it and then figure it out. I don't have notes really. All the comments are like blocks of code, not really notes. I wish I kept notes. Now I have too many notes. There is no balance between anything. It's either one way or the other.
Declaration. Let F be ordinary function create. %async generator.
Either like too many notes or not enough notes. Because somewhere in the middle isn't quite enough notes, but then becomes too much and it's too little. But this is like way too few notes. I have just generic names, labels. They all do something. And I don't know what it does until I trace down all the things that use it and figure it out that way. So I'm gonna keep doing whatever. It's not so boring now. I'm just documenting this, so documentaries are boring. So I really don't care. You shouldn't even be watching this if you have a life. You should like stop watching. Go live your life. Because watching somebody do something really complicated that takes a long time would be a total waste of your time. Not a total waste, but a waste. Or not. I don't know. It's depends on context, I guess.
ECMAScript function object. It is defined piecewise over the following productions: async generator expression, async function, formal parameters, async generator body. If name is not present, set name to. Let env be the lexical environment of the running execution context. Let private env be the running execution context's privat environment. Let source text be the source text matched by async generator expression. Let closure be ordinary function create. %async generator function prototype %source text. Formal parameters. Async generator body. Non-lexical this. env. Private env. Perform set function name. Closure. Name. Let prototype be ordinary object create. %async generator function prototype %perform. Define property or throw. Closure. Prototype. Property descriptor. Prototype. Writable. True. False. False. Return closure. Async generator expression. Async function binding identifier. Formal parameters. Async generator body. Assert. Name is not present. Set name to string value of binding identifier. Let outer env be the running execution context's lexical environment. Let funky env be new declarative environment. Outer env. Perform funky env create immutable binding. Name. False. An anonymous async generated declaration can only occur as part of an export default. Note: declaration. ECMA International 2024 341 6. Let private env be the running execution context's private environment. Let source text be the source text matched by async generator expression. Let closure be ordinary function create. %async generator function prototype %source text. Formal parameters. Async generator body. Non-lexical this. Funcs env. Private env. Perform set function name. Closure. Name 0. Let prototype be ordinary object create. %async generator function prototype %1. Perform. Define property or throw. Closure. Prototype. Property descriptor. Prototype. Writable. True. False. False. 2. Perform func env initialize binding. Name. Closure. 3. Return closure. 5. 6. 5. Runtime semantics. Evaluation. Async generator expression. Async function binding identifier opt. Formal parameters. Async generator body. Return. Capital I N S T A N T I A T E. Capital A S Y N C. Capital G E N E R A T O R. Capital F U N C T. Of async generator expression. 5.7 Class definitions. Syntax. Class declaration. Yield. Await. Default. Class binding identifier yield.
I think I need to waste time trying to figure out how to make Sublime color a fucking type name a different color because it's white. I replaced unsigned ins and signed ins with UJ TSC underscore Q or whatever the number integer address, whatever it was. It's unfucking readable. I don't know what the fuck is a type or a macro when it's like, I'm so used to color coding. So I'm gonna try that right now. Cause that's like 90%. I can't read it. I don't know. It says like static, and it says this, I don't know. I can't like visualize what it is unless it has the fucking type name in front of it. I probably have to like find and replace every time and then undo. I'm gonna try that. I'll like replace the keyword I used back to unsigned in so it's like readable, and I'll undo that so it uses the keyword again until I get used to like reading it with this defined keyword instead of the type that it normally is.
Let constructor be constructor method of class body. If constructor is empty, return false. Return has direct super of constructor. Class body, class element list. It is a syntax error if prototype property name list of class element list contains more than one occurrence of constructor. It is a syntax error if private bound identifiers of class element list contains any duplicate entries, unless the name is used once for a getter and once for a setter and in no other entries, and the getter and setter are either both static or both non-static. Class element method definition. It is a syntax error if prop name of method definition is not constructor and has direct super of method definition is true. It is a syntax error if prop name of method definition is constructor and special method of method definition is true. Class element static method definition. It is a syntax error if has direct super of method definition is true. It is a syntax error if prop name of method definition is prototype. Class element field definition. It is a syntax error if prop name of field definition is constructor. Class element static field definition. It is a syntax error if prop name of field definition is either prototype or constructor. Field definition. Class element name initializer opt. It is a syntax error if initializer is present and contains arguments of initializer as true. Copyright sign ECMA International 2024 343, it is a syntax error if initializer is present and initializer contains supercall is true. Class element name private identifier. It is a syntax error if string value of private identifier is constructor. Class static block body. Class static block statement list. It is a syntax error if the lexically declared names of class static block statement list contains any duplicate entries. It is a syntax error if any element of the lexically declared names of class static block statement list also occurs in the var declared names of class static block statement list. It is a syntax error if contains duplicate labels of class static block statement list with argument is true. It is a syntax error if contains undefined break target of class static block statement list with argument is true. It is a syntax error if capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of class static block statement list with arguments and is true. It is a syntax error if contains arguments of class static block statement list is true. It is a syntax error if class static block statement list contains supercall is true. It is a syntax error if class static block statement list contains await is true. 5, 7, 2 static semantics. Class element kind. The syntax-directed operation class element kind takes no arguments and returns constructor method, non-constructor method, or empty. It is defined piecewise over the following productions. Class element. Method definition. If prop name of method definition is constructor, return constructor method, return non-constructor method, class element, static method definition, field definition, static field definition, return non-constructor method, class element, class static block, return non-constructor method, class element, return empty, 5, 7, 3 static semantics, constructor method. The syntax-directed operation constructor method takes no arguments and returns a class element pars node or empty. It is defined piecewise over the following productions: class element list, class element. If class element kind of class element is constructor method, return class element, return empty, class element list, class element list, class element. 2. Let head be constructor method of class element list. If head is not empty, return head. 44. ECMA International 2024. 3. If class element kind of class element is constructor method, return class element, return empty. 5, 7, 4 static semantics. Is static. The syntax-directed operation is static, takes no arguments and returns a boolean. It is defined piecewise over the following productions: class element, method definition, return false, class element, static method definition, return true, class element, field definition, return false, class element, static field definition, return true, class element, class static block, return true, class element, return false. 5, 7, 5 static semantics, non-constructor elements. The syntax-directed operation non-constructor elements takes no arguments and returns a list of class element pars nodes. It is defined piecewise over the following productions: class element list, class element. If class element kind of class element is non-constructor method, then a return class element, return a new empty list, class element list, class element list, class element. Let list be non-constructor elements of class element list. If class element kind of class element is non-constructor method, then a append class element to the end of list. 3. Return list. Note early error rules ensure that there is only one method definition named constructor and that it is not an accessor property or gene rated definition. ECMA International 2024 345. 1, 5, 7, 6 static semantics. Prototype property name list. The syntax-directed operation prototype property name list takes no arguments and returns a list of property keys. It is defined piecewise over the following productions: class element list, class element. Let prop name be prop name of class element. If prop name is empty, return a new empty list. If a static of class element is true, return a new empty list. Return prop name, class element list, class element list, class element. Let list be prototype property name list of class element list. Let prop name be prop name of class element. If prop name is empty, return list. If a static of class element is true, return list. Return the list concatenation of list and prop name. 5, 7, 7 static semantics. All private identifiers valid. The syntax-directed operation all private identifiers valid takes argument names, a list of strings, and returns a boolean. Every grammar production alternative in this specification which is not listed below implicitly has the following default definition of all private identifiers valid. For each child node of this pars node, do A if child is an instance of a non-terminal, then I if all private identifiers valid of child with argument names is false, return false. 2. Return true. Member expression, private identifier. If names contains the string value of private identifier, then a return all private identifiers valid of member expression with argument names. Return false. Call expression, private identifier. If names contains the string value of private identifier, then a return all private identifiers valid of call expression with argument names. Return false. Optional chain, private identifier. If names contains the string value of private identifier, return true. Return false. Optional chain, private identifier. If names contains the string value of private identifier, then a return all private identifiers valid of optional chain with argument names. Return false. Class body, class element list. 2. Let new names be the list concatenation of names and private bound identifiers of class body. Return all private identifiers valid of class element list with argument new names. 46. ECMA International 2024. Relational expression. Private identifier in shift expression. If names contains the string value of private identifier, then a return all private identifiers valid of shift expression with argument names. Return false. 5, 7, 8. Static semantics. Private bound identifiers. The syntax-directed operation private bound identifiers takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Field definition. Class element name initializer opt. Return private bound identifiers of class element name. Class element name. Private identifier. Return a list whose sole element is the string value O. F private identifier. Class element name. Property name. Class element. Class static block. Return a new empty list. Class element list. Class element list. Class element. Let names 1 be private bound identifiers of class element list. Let names 2 be private bound identifiers of class element. Return the list concatenation of names 1 and names 2. Method definition. Class element name. Unique formal parameters. Function body. Get class element name. Function body. Set class element name. Property set parameter list. Function body. Generator method. Class element name. Unique formal parameters. Generator body. Async method. Async class element name. Unique formal parameters. Async function body. Async generator method. Async class element name. Unique formal parameters. Async generator body. Return private bound identifiers of class element name. 5, 7, 9. Static semantics. Contains arguments. The syntax-directed operation contains arguments, takes no arguments and returns a boolean. Every grammar production alternative in this specification which is not listed below implicitly has the following default definition of contains arguments. For each child node child of this parse node. Do A if child is an instance of a non-terminal, then I if contains arguments if child is true. Return true to. Return false. ECMA International 2024 347. Identifier reference. Identifier. If the string value of identifier is arguments. Return true. Return false. Function declaration. Function binding identifier. Formal parameters. Function body. Function. Formal parameters. Function body. Function expression. Function binding identifier opt. Formal parameters. Function body. Generator declaration. Function binding identifier. Formal parameters. Generator body. Function. Formal parameters. Generator body. Generator expression. Function binding identifier opt. Formal parameters. Generator body. Async generator declaration. Async function binding identifier. Formal parameters. Async generator body. Async function. Formal parameters. Async generator body. Async generator expression. Async function binding identifier opt. Formal parameters. Async generator body. Async function declaration. Async function binding identifier. Formal parameters. Async function body. Async function. Formal parameters. Async function body. Async function expression. Async function binding identifier opt. Formal parameters. Async function body. Return false. Method definition. Class element name. Unique formal parameters. Function body. Get class element name. Function body. Set class element name. Property set parameter list. Function body. Generator method. Class element name. Unique formal parameters. Generator body. Async generator method. Async class element name. Unique formal parameters. Async generator body. Async method. Async class element name. Unique formal parameters. Async function body. Return C. Ontons arguments of class element name. The 5th of July 2010 runtime semantics. Class field definition evaluation. The syntax-directed operation class field definition evaluation takes argument home object, an object, and returns either a normal completion containing a class field definition record or an abrupt completion. It is defined piecewise over the following productions. Field definition. Class element name initializer opt. 2. Let name be. Evaluation of class element name. If initializer is present, then 48. ECMA International 2024. ABCDE. Let formal parameter list be an instance of the production formal parameters. Empty. Let env be the lexical environment of the running execution context. Let private env be the running execution context's private environment. Let source text be the empty sequence of Unicode code points. Let initializer be ordinary function create, percent function prototype percent, source text, formal parameter list, initializer, non-lexical this, env, private env, f perform make method, initializer, home object, g set initializer to name, else, a let initializer be empty, return the class field definition record, name, initializer. Note the function created for initializer is never directly accessible to ECMAScript code. The 5th of July 2011 runtime semantics, capital C, L, A, S, S, capital S, T, A, T, I, C, capital B, L, O, C, K, capital D, E, F, I, N, I, T, I, O, N, capital E, V, A, L, the syntax directed operation, capital C, L, A, S, S, capital S, T, A, T, I, C, capital B, L, O, C, K, capital D, E, F, I, N, I, T, I, O, N, capital E, V, A, L, takes argument home object, an object, and returns a class static block definition record. It is defined piecewise over the following productions: class static block, static, class static block body. Let lex be the running execution context's lexical environment. Let private env be the running execution context's private environment. Let source text be the empty sequence of Unicode code points. Let formal parameters be an instance of the production formal parameters. Empty. Let body function be ordinary function create, percent function prototype percent, source text, formal parameters, class static block body, non-lexical this, lex, private env, perform make method, body function, home object, return the class static block definition record, body function. Note the function body function is never directly accessible to ECMAScript code. The 15th of July 2012 runtime semantics, evaluate class static block body. The syntax-directed operation evaluate class static block body takes argument function object, an ECMAScript function object, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It is defined piecewise over the following productions: class static block body, class static block statement list, assert. Function object is a synthetic function created by capital C, L, A, S, S, capital S, T, A, T, I, C, capital B, L, O, C, K, capital D, E, F, I, N, I, T, I, O, N, capital E, V, A, L. Step 5. Perform. Capital F, U, N, C, T, I, O, N, capital D, E, C, L, A, R, A, T, I, O, N, capital I, N, S, T, A, N, T, I, A, T, I, function object. Return. Evaluation of class static block statement list. The 5th of July 2013 runtime semantics, class element evaluation. The syntax directed operation class element evaluation takes argument object, an object, and returns either a normal completion containing either a class field definition record, a class static block definition record, a private element, or unused, or an abrupt completion. It is defined piecewise over the following productions: class element, field definition, static field definition, return. Class field definition evaluation of field definition with argument object, class element, Method definition. Static method definition. Return. Method definition. Evaluation of method definition with arguments, object and false. Class element. Class static block. Return. Capital C L A S S capital S T A T I C capital B L O C K capital D E F I N I T I O N capital E V A L of class static block with argument object. Copyright sign ECMA International 2024 349. Class element 1. Return unused. The 5th of July 2014. Runtime semantics. Class definition evaluation. The syntax-directed operation class definition evaluation takes arguments class binding, a string or undefined, and class name, a property key or a private name, and returns either a normal completion containing a function object or an abrupt completion. Note: freeze of specification. Private methods and accessors are included alongside private fields in the slot of class instances. However, any given object has either all or none of the private methods and accessors defined by a given class. This feature has been designed so that implementations may choose to implement private methods and accessors using a strategy which does not require tracking each method or accessor individually. For example, an implementation could directly associate instance private methods with their corresponding private name and track, for each object, which class constructors have run with that object as their this value. Looking up an instance private method on an object then consists of checking that the class constructor which defines the method has been used to initialize the object, then returning the method associated with the private name. This differs from private fields, because field initializers can throw during class instantiation. An individual object may have some proper subset of the private fields of a given class, and so private fields must in general be tracked individually. It is defined piecewise over the following productions: class tail, class heritage art, class body art. Let env be the lexical environment of the running execution context. Let class env be new declarative environment, env. If class binding is not undefined, then a perform class env create a mutable binding. Class binding true. Let outer private environment be the running execution context's private environment. Let class private environment be new private environment, outer private environment. If class body is present, then a for each string dn of the private bound identifiers of class body. Do I if class private environment contains a private name pn such that pn is dn, then as cert. This is only possible for getter setter pairs too. Else, let name be a new private name whose is dn. Append name to class private environment. If class heritage is not present, then a let protoparent be %object prototype %. Let constructor parent be %function prototype %. Else. 50. ECMA International 2024. A, B, C, D, E, F. Set the running execution context's lexical environment to class CNV. Note: the running execution context's private environment is outer private environment when evaluating class heritage. Let superclass ref be completion. Evaluation of class heritage. Set the running execution context's lexical environment to env. Let superclass be get value superclass ref. If superclass is null, then I2. Let protoparent be null. Let constructor parent be %function prototype %. Else if is constructor superclass is false, then I throw a type error exception. Else I let protoparent be get superclass prototype 2. If protoparent is not an object and protoparent is not null, throw a type error exception. 3. Let constructor parent be superclass. Let proto be ordinary object create protoparent 0. If class body is not present, let constructor be empty 1. Else let constructor be constructor method of class body 2. Set the running execution context's lexical environment to class CNV 3. Set the running execution context's private environment to class private environment 4. If constructor is empty, Then, a let default constructor be a new abstract closure with no parameters that captures nothing and performs the following steps when called. I let args be the list of arguments that was passed to this function by, or, 2. If new target is undefined, throw a type error exception. 3. Let f be the active function object. If f is derived, then, note, this branch behaves similarly to constructor, args, super, args. The most notable distinction is that while the aforementioned ECMAScript source text observably calls the @iterator method on %array prototype %, this function does not. Let func be if is constructor, func is false. Throw a type error exception. Let result be construct, func, args, new target, else. Note, this branch behaves similarly to constructor. Let result be ordinary create from constructor, new target, %object prototype %v. Perform. Initialize instance elements. Result. F7. Return result. Be let f be create built-in function, default constructor, 0, class name, the current realm record, constructor parent, 5. Else, a let constructor info be define method of constructor with arguments proto and constructor parent. Be let f be constructor info. C perform make class constructor. F d perform set function name. F class name. 6. Perform make constructor. F false. Proto. 7. If C last heritage is present, set f to derived. 8. Perform. Define method property. Proto constructor. F false. 9. If class body is not present, let elements be a new empty list. 0. Else, let elements be non-constructor elements of class body. 1. Let instance private methods be a new empty list. 2. Let static private methods be a new empty list. 3. Let instance fields be a new empty list. 4. Let static elements be a new empty list. 5. For each class element of elements, do if is static of e is false, then I let element be completion, class element evaluation of e with argument proto be else. I let element be completion, class element evaluation of e with argument f. See if element is an abrupt completion, then I set the running execution context's lexical environment to env2. Set the running execution context's private environment to outer private environment. 3. Return element d set element to element e if element is a private element. Then I assert element is either method or accessor. 2. If a static of e is false, let container be instance private methods. 3. Else, let container be static private methods. If container contains a private element pay such that pay, then ECMA International 2024 351 1. Assert element and pay are both accessor. If element a let combined be private element, accessor. Else a let combined be private element, accessor. Element pay v else append element to container. F else if element is a class field definition record, then if a static of e is false, append element to instance fields. 2. Else append element to static elements. G else if element is a class static block definition record, then I append element to static elements. 6. Set the running execution context's lexical environment to env. 7. If class binding is not undefined, then I perform class env initialize binding, class binding, f. 8. Set f to instance private methods. 9. Set f to instance fields. 0. For each private element method of static private methods, do a perform private method or accessor add f method 31. For each element record of static elements, do if element record is a class field definition record, then I let result be completion, define field, f element record be else. I assert element record is a class static block definition record. 2. Let result be completion, call element record f. See if result is an abrupt completion, then I set the running execution context's private environment to outer private environment. 2. Return result. 2. Set the running execution context's private environment to outer private environment. 3. Return F, the 5th of July 2015 runtime semantics. Capital B, I, N, D, I, N, G, capital C, L, A, S, S, capital D, E, C, L, A, R, A, T, I, O, N, capital E, V, A, L, U, A, T, the syntax-directed operation, capital B, I, N, D, I, N, G, capital C, L, A, S, S, capital D, E, C, L, A, R, A, T, I, O, N, capital E, V, A, L, U, A, T, takes no arguments and returns either a normal completion containing a function object or an abrupt completion. It is defined piecewise over the following productions: class declaration, class binding identifier, class tail. Let class name be string value of binding identifier. Let value be class definition evaluation of class tail with arguments class name and class name. Set value to the source text match by class declaration. Let env be the running execution context's lexical environment. Perform. Initialize bound name, class name, value, env. Return value, class declaration, class tail. Let value be class definition evaluation of class tail with arguments undefined and default. Set value to the source text match by class declaration. Return value 352. ECMA International 2024. Class declaration. Class tail only occurs as part of an export declaration and note, establishing its binding is handled as part of the evaluation action for that production. C1623 7. The 15th of July 2016 runtime semantics. Evaluation. Class declaration. Class binding identifier, class tail. Perform. Capital B, I, N, D, I, N, G, capital C, L, A, S, S, capital D, E, C, L, A, R, A, T, I, O, N, capital E, V, A, L, U, A, T, of this class declaration. Return empty. Class expression. Class tail. Let value be class definition evaluation of class tail with arguments undefined and set value to the source text match by class expression. Return value. Class expression. Class binding identifier, class tail. Let class name be string value of binding identifier. Let value be class definition evaluation of class tail with arguments class name and class name. Set value to the source text match by class expression. Return value. Class element name. Private identifier. Let private identifier be string value of private identifier. Let private env rec be the running execution context's private environment. Let names be private env rec. Assert. Exactly one element of names is a private name whose is private identifier. Let private name be the private name in names whose is private identifier. Return private name. Class static block statement list. Empty. 1. Return undefined. 5.8 Async function definitions syntax. Async function declaration. Yield. Await. Default. Async. No line terminator here. Function binding identifier yield await. Formal parameters. Yield plus await. Async function body plus default. Async. No line terminator here. Function. Formal parameters. Yield plus await. Class declaration. Class tail only occurs as part of an export declaration and is never, note, directly evaluated. Async function body. Async function expression. Async. No line terminator here. Function binding identifier. Yield plus await opt. Formal parameters. Yield plus a wait. Async function body. Async method. Yield await. Async. No line terminator here. Class element name yield await. Unique formal parameters. Yield plus await. Async function body. Async function body. Function body. Yield plus await. ECMA International 2024. 53. Await expression. yield, await unary expression yield, plus await. Note 1. Await is passed as a keyword of an await expression when the await parameter is present. The await parameter is present in the top level of the following contexts. Although the parameter may be absent in some contexts depending on the non-terminals, such as function body, in an async function body, in the formal parameters of an async function declaration, async function expression, async generator declaration, or async generator expression. Await expression in this position is a syntax error via static semantics. In a module, when script is the syntactic goal symbol, await may be parsed as an identifier when the await parameter is absent. This includes the following contexts: anywhere outside of an async function body or formal parameters of an async function declaration, async function expression, async generator declaration, or async generator expression, in the binding identifier of a function expression, generator expression, or async generator expression. 158. 1 static semantics, early errors, async method, async class element name, unique formal parameters, async function body. It is a syntax error if function body contains use strict of async function body is true and is simple parameter list of unique formal parameters is false. It is a syntax error if has direct super of async method is true. It is a syntax error if unique formal parameters contains await expression is true. It is a syntax error if any element of the bound names of unique formal parameters also occurs in the lexically declared names of async function body, async function declaration, async function binding identifier, formal parameters, async function body, async function, formal parameters, async function body, async function expression, async function binding identifier, formal parameters, async function body. It is a syntax error if function body contains use strict of async function body is true and is simple parameter list of formal parameters is false. It is a syntax error if formal parameters contains await expression is true, if the source text match by formal parameters is strict mode code. The early error rules for unique formal parameters. Formal parameters are applied if binding identifier is present and the source text match by binding identifier is strict mode code. It is a syntax error if the string value of binding identifier is either eval or arguments. It is a syntax error if any element of the bound names of formal parameters also occurs in the lexically declared names of async function body. It is a syntax error if formal parameters contain super property is true. It is a syntax error if async function body contains super property is true. It is a syntax error if formal parameters contain super call is true. It is a syntax error if async function body contains super call is true.
The ternary whatever. I finally found what it's tied to. I don't know. If there's error, if there's a invalid left hand property, or a missing right hand expression, or invalid right hand expression. Oh, missing or invalid. Or if the right hand is invalid and its right hand is a property. Somewhere in here is something related to the if statement. But I'll look later. I think I have the macros to print. So I think I'm gonna make a loop, have the increment in the loop, and then I'll print to make sure like I actually incremented the number, and then I'll make the whole whatever what was it? Stress test function that I made. And I can like speed test it. I'll use like a ternary instead of a if else whatever. This is so annoying. It's literally it's gonna be a pain in the ass to update. When I say like hard-coded stuff, I mean I like hard-coded numbers. It's just really stupid. So now I gotta like try to change this shit. I'll find another one. Like 90% of the program. It's fucking hard-coded. I had a plan to update things later, so I didn't use macros for some stuff. So like this one, whatever, I'll just use the whatever, I don't know. I'm just use a calculator so I don't mess up. I'll just put an X in there instead of 1. It's not easy to read though. I don't know, the underscore might be. If I put a 1, that's difficult to read? I don't know. So with 1. So this test is an AND. It tests this 32-bit value. It tests if this 1 bit is set. If it's not, if it's set, whatever, it takes this jump. If not, it enters and it throws this error. This one tests for this bit. This bit here, whatever, and this bit, and this bit. So if any of these bits are set, then it takes this jump. Otherwise it falls through. It's a invalid expression, whatever. This one here tests for this bit. This bit here. This bit, this bit, this bit, this, not this, not this, not this, this, but not this bit. So if any of these bits are set, it's not a property, because it's only a property if this bit, this bit, this bit, or this bit are set. It's a really, it's like 700 something combinations. I want to die. If I change anything or add anything, holy fuck, I gotta update. Manually find these and like change it. I'm gonna take a break. That's what I've been looking at. I'm looking for the ifs, but distracted by the amount of stuff I gotta do. I should have like I should have set up like this, where I define like the specific bits. So like this one has 4 bits that are not tested for. I'm tired, whatever, so let's just say that's how, whatever it is. Assuming I'm testing for the opposite, or not, maybe, I don't know. I'm not thinking right, I'm trying to think of other stuff. I should have defined it like this, where bit A, B, C, D, and bits A that have only this bit. So it would look like this, whatever. If I did it this way, I wouldn't have to look at this, because it would be this whatever here, but I'd also have to invert it to make the on bits off or on or whatever. And then these up here, whatever, this test for this bit. Let's pretend that's bit C. And let's pretend this is bits B and D. So now, if bit C changes, wherever bit C is used, which is here and here, I can change it where it's defined here to wherever, whatever it has to be. Let's say let's do it here. Now, these are all updated with bit C in that position. But instead, what I have right now is that is basically this whatever. This is hexadecimal. It's the same thing as binary. It's just more compact. I'll just paste the binary. So it's like equivalent. Okay, so now let's say like bit C. So here. if bit C is 0, I think that's 10. I'm too tired. If that's the 10th bit, it means that now, since I didn't do this, if I have to change the 10th bit, I have to find every place that I have a binary number and change the 10th bit. So what? This one and this one, I guess. Oh, let's say this is the 10th bit. Let's be on. Maybe this one. Off, whatever. I just mix that up, whatever. Doesn't matter. So, I'm gonna have a whole lot of work to do to add anything to this. So at some point, I'm gonna have to get rid of all these actual numbers and put defines in instead. This is not manageable at all in any way. I've been trying to decipher what bits go to which things. It's a little complicated. So I was trying to find the ifs, and I was doing this. I'm gonna take a break. There's 700 combinations of these. It's a lot. I have to. I don't know. It's a lot of work. I'll be back.
One five eight to runtime semantics. Instantiate a sync function object. The syntax-directed operation instantiate a sync function object takes argument CNV, an environment record, and private env, a private environment record or null, and returns an ECMAScript function object. It is defined piecewise over the following productions: a sync function declaration, a sync function binding identifier, formal parameters, a sync function body. Let name be string value of binding identifier. Let source text be the source text matched by a sync function declaration. Let f be ordinary function create. Percent a sync function prototype. Percent source text. Formal parameters. A sync function body. Non-lexical this. env. Private env. Perform cert function name. F. Name. Return f. A sync function declaration. A sync function. Formal parameters. A sync function body. Let source text be the source text matched by a sync function declaration. Let f be ordinary function create. Percent a sync function prototype. Percent source text. Formal parameters. A sync function body. Non-lexical this. env. Private env. Perform cert function name. F. Default. Return f. 5, 8, 3 runtime semantics. Capital I. N S T A N T I A T E capital A S Y N C capital F U N C T I O N capital E X P R E S. The syntax directed operation. Capital I N S T A N T I A T E capital A S Y N C capital F U N C T I O N capital E X P R E S. takes optional argument name, a property key or a private name, and returns an ECMAScript function object. It is defined piecewise over the following productions: async function expression, async function, formal parameters, async function body. If name is not present, set name to. Let env be the lexical environment of the running execution context. Let private env be the running execution context's private environment. Let source text be the source text matched by async function expression. Let closure be ordinary function.
I give up looking for the if for now. I'll do that later. I'm gonna need it though for stupid OpenGL test.
Let funky env be new declarative environment.
For now, I'm gonna find one of the functions that's being called related to
expression. Let closure be ordered.
Related to whatever. I'm just gonna find one of them, and then I'll put the test in there, use ternaries, and then just use a normal int counter for the loop condition, and then I've gotta worry about the if statement, check, condition, whatever.
Function expression can be referenced from inside.
I don't know where the hell it is. It should exist. I can't find it. I don't know where the freaking if is. I know, but I can't put my finger on it. It's like
8. For runtime semantics, evaluate async function body. The syntax-directed operation evaluate async function body takes arguments function object.
I don't know. Eventually, it'll come to me, and I'll be like, oh, that was it. And I just spent all this time figuring out unrelated stuff that I gotta know anyways. It's gonna be a lot of work. I say a JavaScript engine, I mean, it's like a full-blown JavaScript engine. It's not like a little tiny project. It's really complicated. I'm gonna try to find one of the function calls, the debug ones that are called, that I can pack tests into at the bottom and run it. And then tomorrow I'm gonna get the rest of the unsigned ints and rename them if I missed any. I have to check all the files, whatever. Then I'll start the 64-bit arithmetic, and then I'll go through the standard, at which point I'm going to have to deal with a whole lot of stuff. It's be complicated. It's really complicated. I only have so many bits, and I think some of them, I had just enough bits available to represent a certain collection of operations. I can't add more operations to what I have without freaking expanding it, and then it messes up the bit field above it. What I might be able to do, since this be 64-bit, I could cheat, kind of, This is a 32-bit.
V E R.
I'm thinking I might just have to because I'm not gonna freaking go through 700 binary values, and it's a lot. I shouldn't have hard-coded it, but what I'm saying is I'm still gonna have to go through like 700, but
Yield await.
I can like set 32 bits higher than the lower 32 bits.
R capital C.
So since it's 64 bit whatever, I might be able to like do this whatever, and then everything will be updated. I have all the I still gotta put the conditions in place in the logic. No matter what I do, it's gonna be a shit loop. So I'm gonna stop thinking about this and get it to print a type value, make a loop, and test some stuff. My first step, just get it all 64-bit. Then I'll deal with the engine part and adding more support for this stuff. So I'm gonna find so I'm gonna print to the screen the counts, whatever.
Sync arrow function. Async arrow binding ID.
I give up on trying to find an if for now. I might have to like cheat and like make a temporary int, assign it to like a conditional result, and then test that int so it doesn't have to test like 2 or more conditions for like the ifs, whatever. If I can't find, and I know it's somewhere, it's not worth spending another 70 hours looking for. So I'm gonna get it to print or whatever first, and then do a speed test, I guess, and then that's it for today.
Capital A N D capital A S Y N C capital A R R must cover an async arrowhead. It is a syntax error if capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R contains yield expression is true. It is a syntax error if capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R contains await expression is true. It is a syntax error if any element of the bound names of capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N R also occurs in the lexically declared names of a concise body. It is a syntax error if capital A S Y N C capital C O N C I S E capital B O D Y capital C O N T A I N S capital U S E capital S T R of a concise body is true and is simple parameter list of capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R is false. 5. 9. 2 static semantics. Capital A S Y N C capital C O N C I S E capital B O D Y capital C O N T A I N S capital U S E capital S T R. The syntax directed operation capital A S Y N C capital C O N C I S E capital B O D Y capital C O N T A I N S capital U S E capital S T R takes no arguments and returns a boolean. It is defined piecewise over the following productions: a concise body, expression body, return false, a concise body, a function body, return function body contains use strict of a function body. 1. 5. 9. 3. Runtime semantics. Evaluate a concise body. The syntax directed operation evaluate a concise body takes arguments function object, an ECMAScript function object, and arguments list, a list of ECMAScript language values, and returns a return completion. It is defined piecewise over the following productions: a concise body, expression body, let promise capability be new promise capability, %promise %, let decl result be completion, function declaration instantiation, function object, arguments list. If decl result is an abrupt completion, then a perform call promise capability undefined decl result 4. Else a performance and function start promise capability expression body return completion record return promise capability empty. 5. 9. For runtime semantics capital I N S T A N T I A T E capital A S Y N C capital A R R O W capital F U N C T I O N capital E. The syntax directed operation capital I N S T A N T I A T E capital A S Y N C capital A R R O W capital F U N C T I O N capital E takes optional argument name, a property key or a private name, and returns an ECMAScript function object. It is defined piecewise over the following productions: a arrow function, a arrow binding identifier equals, a concise body if name is not present, Set name 2. Let env be the lexical environment of the running execution context. Let private env be the running execution context's private environment. Let source text be the source text matched by a sync arrow function. Let parameters be a sync arrow binding identifier. Let closure be ordinary function create. %async function prototype source text parameters async concise body lexical this env private env perform cert function name closure name return closure ECMA International 2024 357 async arrow function capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R equals async concise body. If name is not present, set name 2. Let env be the lexical environment of the running execution context. Let private env be the running execution context's private environment. Let source text be the source text matched by a sync arrow function. Let head be the async arrow head that is covered by capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R. Let parameters be the arrow formal parameters of head. Let closure be ordinary function create. %async function prototype source text parameters async concise body lexical this env private env perform cert function name closure name return closure 5 9 5 runtime semantics evaluation async arrow function async arrow binding identifier equals async concise body capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R equals async concise body return capital I N S T A N T I A T E capital A S Y N C capital A R R O W capital F U N C T I O N capital E of async arrow function 15.10 tail position calls 5.1.0.1 static semantics is in tail position call. The abstract operation is in tail position takes argument call, a call expression parse node, a member expression parse node, or an optional chain parse node, and returns a boolean. It performs the following steps when called. If the source text matched by call is non-strict code, return false. If call is not contained within a function body.
I was trying to find the if again. I think I'm really close, but I give up looking now. It's complicated because you can check if 5 is less than the string of potato, or you can check if 5 is less than the string that is 8, like if the number 8 is inside of the string. And I don't remember JavaScript totally, but I think that'd like be true. I think. I can't remember. Whatever it would be. JavaScript kind of makes no sense It has rules. They're all defined in this standard here, ECMA 262. So as long as you follow the rules and you learn what they are, you would know what the number 5, the integer 5, if it's less than a string that has the number 8 in it. But if it's like five is less than undefined, because undefined is a type. Is that false? I don't know. There's like a whole bunch of I'm gonna put the big whatever. It's complicated. So I need an if. Somewhere in here, there's a freaking if. And I can't find it. It's just be true or false. That's all I need. I can use it as a condition for whatever. So I'm gonna find something that is being called print to the screen or the console, and then just try to like fucking print one of the variables. It's so complicated.
Statement with argument call. If statement. If. Expression statement. Do while statement. Do statement while. Expression while statement. While. Expression statement. For statement. For. Expression not. Expression not. Expression not statement. For. The variable declaration list. Expression not. Expression not statement. For. Lexical declaration expression not. Expression not statement. For in of statement. For. Left-hand side expression in expression statement. For. The for binding in expression statement. For declaration in expression statement. ECMA International 2024 359. With statement. With expression statement. Return has call entail position of statement with argument call. Labeled statement. Label identifier. Labeled item. Return has call entail position of labeled item with argument call. Return statement. Return expression. Return has call entail position of expression with argument call. Switch statement. Switch. Expression. Case block. Return has call entail position of case block with argument call. Case block. Case clause assopt. Default clause case clause assopt. Let has be false. If the first case clauses is present, set has to has call entail position of the first case clauses with argument call. If his is true, return true. Set has to has call entail position of default clause with argument call. If his is true, return true. If the second case clauses is present, set has to has call entail position of the second case clauses with argument call. Return has case clauses. Case clauses case clause. Let his be has call entail position of case clauses with argument call. If his is true, return true. Return has call entail position of case clause with argument call. Case clause. Case expression. Statement list opt. Default clause. Default. Statement list opt. If statement list is present, return has call entail position of statement list with argument call. Return false. Try statement. Try block catch. Return has call entail position of catch with argument call. Try statement. Try block finally. Try block catch finally. Return has call entail position of finally with argument call. Catch. Catch. Catch parameter. Block. Return has call entail position of block with argument call. 60. ECMA International 2024. Assignment expression. Yield expression. Arrow function. Async arrow function. Left-hand side expression equals assignment expression. Left-hand side expression assignment operator assignment expression. Left-hand side expression and equals assignment expression. Left-hand side expression equals assignment expression. Left-hand side expression equals assignment expression. Bitwise and expression. Bitwise and expression and equality expression. Bitwise or expression. Bitwise or expression. Bitwise and expression. Bitwise or expression. Bitwise or expression. Bitwise or expression. Equality expression. Equality expression equals relational expression 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 relational expression shift expression relational expression shift expression relational expression equals shift expression relational expression equals shift expression relational expression instance of shift expression relational expression in shift expression private identifier in shift expression additive expression shift expression additive expression shift expression additive expression plus multiplicative expression additive expression multiplicative expression multiplicative operator exponentiation expression update expression exponentiation expression update expression left hand side expression plus left hand side expression plus unary expression delete unary expression void unary expression type of unary expression plus unary expression await expression ECMA International 2024 361 call expression super call import call expression call expression identifier name call expression private identifier new expression member expression member expression identifier name super property meter property new member expression arguments member expression private identifier primary expression this identifier reference literal array literal object literal function expression class expression generator expression async function expression async generator expression regular expression literal template literal return false expression assignment expression assignment expression return has call and tail position of assignment expression with argument call conditional expression short circuit expression assignment expression let his be has call and tail position of the first assignment expression with argument call if his is true return has call and tail position of the second assignment expression with argument call logical and expression and bitwise or expression 1 return has call and tail position of bitwise or expression with argument call logical or expression logical and expression return has call and tail position of logical and expression with argument call coalesce expression head bitwise or expression 1 return has call and tail position of bitwise or expression with argument call 62 ECMA International 2024 call expression capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R call expression arguments cal L expression template literal if this call expression is call return true return false optional expression member expression optional chain call expression optional chain return has call and tail position of optional chain with argument call optional chain expression identifier name private identifier optional chain expression optional chain identifier name optional chain private identifier return false optional chain arguments optional chain arguments if this optional chain is call return true return false member expression template literal if this member expression is call return true return false primary expression capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N let X be the parenthesized expression that is covered by capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N. Return has call and tail position of exp with argument call. Parenthesized expression. Expression. Return has call and tail position of expression with argument call. ECMA International 2024 363 1510 3. Prepare for tail call. The abstract operation prepare for tail call takes no arguments and returns unused. It performs the following steps when called. Assert. The current execution context will not subsequently be used for the evaluation of any ECMAScript code or built-in functions. The invocation of call subsequent to the invocation of this abstract operation will create and push a new execution context before performing any such evaluation. Discard all resources associated with the current execution context. Return unused. A tail position call must either release any transient internal resources associated with the currently executing function execution context before invoking the target function or reuse those resources in support of the target function. 6. ECMAScript language. Scripts and modules. 6.1 Script syntax. Script. Script body opt. Script body. Statement list. Yield. Await. Return. 6. 1. 1 Static semantics. Early errors. Script. Script body. It is a syntax error if the lexically declared names of script body contains any duplicate entries. It is a syntax error if any element of the lexically declared names of script body also occurs in the declared names of script body. Script body. Statement list. It is a syntax error if statement list contains super unless the source text containing super is eval code that is being processed by a direct eval. Additional early error rules for super with indirect eval are defined in 192.1.1. It is a syntax error if statement list contains new target unless the source text containing new target is eval code that is being processed by a direct eval. Additional early error rules for new target indirect eval are defined in 192.1.1. It is a syntax error if contains duplicate labels of statement list with argument is true. It is a syntax error if contains undefined break target of statement list with argument is true. It is a syntax error if capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of statement list with arguments and is true. It is a syntax error if all private identifiers valid of statement list with argument is false unless the source text containing script body is eval code that is being processed by a direct eval. Note, for example, a tail position call should only grow an implementation's activation record stack by the amount that the size of the target function's activation record exceeds the size of the calling function's activation record. If the target function's activation record is smaller, then the total size of the stack should decrease. 64. ECMA International 2024 161. 2 Static semantics. Is strict. The syntax-directed operation is strict, takes no arguments and returns a boolean. It is defined piecewise over the following productions. Script. Script body opt. If script body is present in the directive prologue of script body contains a use strict directive, return true. Otherwise, return false. 6. 1. 3 Runtime semantics. Evaluation. Script. Empty. Return undefined. 6. 1. 4 Script records. A script record encapsulates information about a script being evaluated. Each script record contains the fields listed in Table 40. Table 40. Script record fields. Field name. Value type. Meaning. Realm. A realm record or undefined. The realm within which this script was created undefined if not yet assigned. ECMAScript code. A script parse node. The result of parsing the source text of this script. Loaded modules. A list of records with fields. A string, and a module record, a map from the specifier strings imported by this script to the resolved module record. The list does not contain two different records with the same host defined. Anything default value is empty. Field reserved for use by host environments that need to associate additional information with the script. 1.6.1. 5 parse script. Source text. Realm. Host defined. The abstract operation parse script takes arguments source text, ECMAScript source text, realm, a realm record or undefined, and host defined anything and returns a script record or a non-empty list of syntax error objects. It creates a script record based upon the result of parsing source text as a script. It performs the following steps when called. Let script be parse text, source text, script. If script is a list of errors, return script record, realm, script. Host defined. Note an implementation may parse script source text and analyze it for early error conditions prior to evaluation of parse script for that script source text. However, the reporting of any errors must be deferred until the point where this specification actually performs parse script upon that source text. ECMA International 2024 365 1.6.1. 6 Script evaluation. Script record. The abstract operation script evaluation takes argument script record, a script record, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It performs the following steps when called. Let global env be script record. Let script context be a new ECMAScript code execution context. Set the function of script context to null. Set the realm of script context to script record. Set the script or module of script context to script record. Set the variable environment of script context to global env. Set the lexical environment of script context to global env. Set the private environment of script context to null. Suspend the running execution context. 0. Push script context onto the execution context stack. Script context is now the running execution context. 1. Let script be script record. 2. Let result be completion. Global declaration instantiation. Script. Global env. 3. If result is a normal completion, then set result to completion. Evaluation of script. If result is a normal completion and result is empty, then I set result to normal completion, undefined. 4. Suspend script context and remove it from the execution context stack. 5. Assert. The execution context stack is not empty. 6. Resume the context that is now on the top of the execution context stack as the running execution context. 7. Return result. 6. 1. 7 Global Declaration Instantiation. Script. ENV. The abstract operation Global Declaration Instantiation takes argument script, a script parse node, and ENV, a global environment record, and returns either a normal completion containing unused or a throw completion script as the script for which the execution context is being established. TNV is the global environment in which bindings are to be created. It performs the following steps when called. Let lex names be the lexically declared names of script. Let var names be the var declared names of script. For each element name of lex names, do if env has var declaration, name is true. Throw a syntax error exception. B if env has lexical declaration, name is true. Throw a syntax error exception. C let has restricted global. B env has restricted global property, name. D if his restricted global is true. Throw a syntax error exception. For each element name of var names, do if env has lexical declaration, name is true. Throw a syntax error exception. Let var declarations be the var scope declarations of script. Let functions to initialize be a new empty list. Let declared function names be a new empty list. For each element D of var declarations, in reverse list order, do 366. ECMA International 2024. Note 1. When an execution context is established for evaluating scripts, declarations are instantiated in the current global environment. Each global binding declared in the code is instantiated. A. If D is not either a variable declaration, a for binding, or a binding identifier, then I. 2. 3. Assert. D is either a function declaration, a generator declaration, an async function declaration, or an async generator declaration. Note: if there are multiple function declarations for the same name, the last declaration is used. Let fn be the sole element of the bound names of D. If declared function names does not contain fn, then let fn definable be env can declare global function fn. 2. If fn definable is false, throw a type error exception. Append fn to declared function names. Insert D as the first element of functions to initialize. Let declared var names be a new empty list. 0. For each element D of var declarations, do if D is either a variable declaration, a for binding, or a binding identifier. Then I for each string vn of the bound names of D, do if declared function names does not contain vn, then a let vn definable be env can declare global var vn b if vn definable is false. Throw a type error exception. See if declared var names does not contain vn, then I append vn to declared var names. 1. Note: no abnormal terminations occur after this algorithm step if the global object is an ordinary object. However, if the global object is a proxy exotic object, it may exhibit behaviors that cause abnormal terminations in some of the following steps. 2. Note: an xb 3 2 2 adds additional steps at this point. 3. Let lex declarations be the lexically scoped declarations of script. 4. Let private env be null. 5. For each element D of lex declarations, do a note: lexically declared names are only instantiated here but not initialized. B for each element Dn of the bound names of D, do I if this constant declaration of D is true, then perform env create immutable binding. Dn true. 2. Else perform env create mutable binding. Dn false. 6. For each parse node f of functions to initialize, do a let fn be the sole element of the bound names of f. B let fo be instantiate function object of f with arguments env and private env. C perform env create global function binding fn fo false. 7. For each string vn of declared var names, do a perform env create global var binding vn false. 8. Return unused. Note 2. Early errors specified in 1.6. 1. Prevent name conflicts between function var declarations and let const class declarations, as well as redeclaration of let const class bindings for declaration contained within a single script. However, such conflicts and redeclarations that span more than one script are detected as runtime errors during global declaration instantiation. If any such errors are detected, no bindings are instantiated for the script. However, if the global object is defined using proxy exotic objects, then the runtime tests for conflicting declarations may be unreliable, resulting in an abrupt completion in some global declarations not being instantiated. If this occurs, the code for the script is not evaluated. Unlike explicit var or function declarations, properties that are directly created on the global object result in global bindings that may be shadowed by let const class declarations. 6.2 Modules syntax. Module body opt, module body, module item list, module item list, module item list, module item. ECMA International 2024 367. Module item. Import declaration, export declaration, statement list item, yield, plus await, return, module export name, identifier name, string literal. 6. 2. 1 module semantics. 6. 2. 1. 1 static semantics. Early errors. Module body. Module item list. It is a syntax error if the lexically declared names of module item list contains any duplicate entries. It is a syntax error if any element of the lexically declared names of module item list also occurs in the are declared names of module item list. It is a syntax error if the exported names of module item list contains any duplicate entries. It is a syntax error if any element of the exported bindings of module item list does not also occur in either the are declared names of module item list or the lexically declared names of module item list. It is a syntax error if module item list contains super. It is a syntax error if module item list contains new target. It is a syntax error if contains duplicate labels of module item list with argument is true. It is a syntax error if contains undefined break target of module item list with argument is true. It is a syntax error if capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E a module item list with arguments and is true. It is a syntax error if all private identifiers valid of module item list with argument is false. Module export name string literal. It is a syntax error if is string well-formed Unicode. The SV of string literal is false. 6, 2, 1. 2 static semantics. Imported local names. Import entries. The abstract operation imported local names takes argument import entries, a list of import entry records, and returns a list of strings. It creates a list of all of the local name bindings defined by import entries. It performs the following steps when called. Let local names be a new empty list. For each import entry record I of import entries, do a append I to local names 3. Return local names 6, 2, 1. 3 static semantics. Module requests. The syntax directed operation module requests takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Module empty. Return a new empty list. The duplicate exported names rule implies that multiple export default export declaration items. Note, within a module body is a syntax error. Additional error conditions relating to conflicting or duplicate declarations are checked during module linking prior to evaluation of a module. If any such errors are detected, the module is not evaluated. 68. ECMA International 2024. Module item list. Module item. Return module requests of module item. Module item list. Module item list module item. Let module names be module requests of module item list. Let additional names be module requests of module item. For each string name of additional names, do if module names does not contain name, then I append name to module names. Return module names. Module item. Statement list item. Return a new empty list. Import declaration. Import clause from clause. Return module requests of from clause. Module specifier. String literal. Return a list whose sole element is the SV of string literal. Export declaration. Export from clause from clause. Return the module requests of from clause. Export declaration. Export named exports. Export variable statement. Export declaration. Export default hoistable declaration. Export default class declaration. Export default assignment expression. Return a new empty list 1 6 2 1. For abstract module records, a module record encapsulates structural information about the imports and exports of a single module. This information is used to link the imports and exports of sets of connected modules. A module record includes 4 fields that are only used when evaluating a module. For specification purposes, module record values are values of the record specification type and can be thought of as existing in a simple, object-oriented hierarchy where module record is an abstract class with both abstract and concrete subclasses. This specification defines the abstract subclass named cyclic module record and its concrete subclass named source text module record. Other specifications and implementations may define additional module record subclasses corresponding to alternative module definition facilities that they defined. Module record defines the fields listed in Table 41. All module definition subclasses include at least those fields. Module record also defines the abstract method list in Table 42. All module definition subclasses must provide concrete implementations of these abstract methods. ECMA International 2024 369. Table 41. Module record fields. Field name. Value type. Meaning. Realm. A realm record. The realm within which this module was created. Environment. A module environment record or empty. The environment record containing the top-level bindings for this module. This field is set when the module is linked. Namespace, an object or empty. The module namespace object, 28.3. If one has been created for this module. Host defined. Anything default value is undefined. Field reserved for use by host environments that need to associate additional information with a module. Table 42. Abstract methods of module records. Method. Purpose. Load requested modules. Host defined. Prepares the module for linking by recursively loading all its dependencies. Promise. Get exported name.
I think I gave up for today. I can't just simply call a function because it's like 4 macro depth, and the function has a name, and it glues to the name a double underscore, and it glues to that the length of the arguments, and they're all like separate defines, and it's kind of complicated. So I was looking at, I'm trying to like wrap my head around the whole thing as I'm trying to like do something else. So tomorrow I'm gonna figure out one of the functions being called, because I can't just easily add one and call it because it's complicated. So I don't know, I'm gonna think. I think I got rid of the if. It's like, I think I found it, and it's commented out. So I'm gonna think on it. Tomorrow I'll try to make some progress. This is really complicated. So I'm gonna let the stream run on this, because the stream isn't always done. So peace.
Initially new. Transitions to unlinked. Linking. Linked. Evaluating. Possibly evaluating async. Evaluated. In that order. As the module progresses throughout its lifecycle. Evaluating async indicates this module is queued to execute on completion of its asynchronous dependencies, or it is a module whose field is true that has been executed and is pending top-level completion. Evaluation error. A throw completion or empty. A throw completion representing the exception that occurred during evaluation, undefined if no exception occurred or if is not evaluated. DFS index. An integer or empty. Auxiliary field used during link and evaluate only. If is either linking or evaluating. This non-negative number records the point at which the module was first visited during the depth-first traversal of the dependency graph. DFS ancestor index. A. An integer or empty. Auxiliary field used during link and evaluate only. If is either linking or evaluating. This is either the module's own or that of an earlier module in the same strongly connected component. Requested modules. A list of strings. A list of all the module specifier strings used by the module represented by this record to request the importation of a module. The list is in source text occurrence order. Loaded modules. A list of records with fields. A string. And a module record, a map from the specifier strings used by the module represented by this record to request the importation of a module to the resolved module record. The list does not contain two different records with the same cycle root. A cyclic module record or empty, the first visited module of the cycle, the root DFS ancestor of the strongly connected component. For a module not in a cycle, this would be the module itself. Once evaluate has completed, a module says the of its copyright sign, ECMA International 2024, 71, Table 43, additional fields of cyclic module records, continued, field name, value type, meaning, has TLA, a boolean, whether this module is individually asynchronous. For example, if it's a source text module record containing a top-level await. Having an asynchronous dependency does not mean this field is true. This field must not change after the module is parsed. Async evaluation, a boolean, whether this module is either itself asynchronous or has an asynchronous dependency. Note: the order in which this field is set is used to order queued executions. C16, 2, 1, 5, 3, 4. Top-level capability. A. Promise capability record or empty. If this module is the of some cycle, and evaluate was called on some module in that cycle, This field contains the promise capability record for that entire evaluation. It is used to settle the promise object that is returned from the evaluate abstract method. This field will be empty for any dependencies of that module, unless a top-level evaluate has been initiated for some of those dependencies. Async parent modules, a list of cyclic module records. If this module or a dependency has true, and execution is in progress, this tracks the parent importers of this module for the top-level execution job. These parent modules will not start executing before this module has successfully completed execution, pending async dependencies, an integer or empty. If this module has any asynchronous dependencies, this tracks the number of asynchronous dependency modules remaining to execute for this module. A module with asynchronous dependencies will be executed when this field reaches 0 and there are no execution errors. In addition to the methods defined in Table 42, cyclic module records have the additional methods listed in Table 44. tar, blah 44. Additional abstract methods of cyclic module records. Method. Purpose. Initialize environment. Initialize the environment record of the module, including resolving all imported bindings, and create the module's execution context. Execute module. Promise capability. Evaluate the module's code within its execution context. If this module has true in, then a promise capability record is passed as an argument, and the method is expected to resolve or reject the given capability. In this case, the method must not throw an exception, but instead reject the promise capability record if necessary. A graph loading state record is a record that contains information about the loading process of a module graph. It's used to continue loading after a call to host load imported module. Each graph loading state record has the fields defined in Table 45. 72. Copyright sign. ECMA International 2024. Table 45. Graph loading state record fields. Field name. Value type. Meaning. Promise capability. A. Promise capability record. The promise to resolve when the loading process finishes is loading. A boolean. It is true if the loading process has not finished yet, neither successfully nor with an error. Pending modules count. A non-negative integer. It tracks the number of pending host load imported module calls visited. A list of cyclic module records. It is a list of the cyclic module records that have been already loaded by the current loading process, to avoid infinite loops with circular dependencies. Host-defined. Anything default value is empty. It contains host-defined data to pass from the load requested module's caller to host load imported module. 1 load requested modules. Host-defined. The load requested module's concrete method of a cyclic module record module takes optional argument host-defined anything and returns a promise. It populates the of all the module records in the dependency graph of module. Most of the work is done by the auxiliary function in a module loading. It takes an optional host-defined parameter that is passed to the host load imported module hook. It performs the following steps when called. If host-defined is not present, let host-defined be empty. Let PC be new promise capability, %promise %. Let state be the graph loading state record. True. 1. Promise capability, PC, host-defined. Perform in a module loading. State, module, return PC. 6, 2, 1, 5, 1, 1 in a module loading. State, module. The abstract operation in a module loading takes arguments state, a graph loading state record, and module, a module record, and returns unused. It is used by load requested modules to recursively perform the actual loading process for module's dependency graph. It performs the following steps when called. Assert. State is true if a module is a cyclic module record. Module is new, and state does not contain module. Then A. Append module to state. B. Let requested modules count be the number of elements in module. C. Set state to state plus requested modules count. D. For each string required of module. Do I if module contains a record whose is required. Then let record be that record. Perform in a module loading. State. Record 2. Else. Note the host-defined parameter can be used to pass additional information necessary to fetch the imported modules. It is used, for example, by HTML to set the correct fetch destination for link rel equals preloaders equals tags import Expressions never set the host-defined parameter. ECMA International 2024 373. 1. Perform host load imported module. Module. Required. State. Note. Host load imported module will call finish loading imported module, which re-enters the graph loading process through continue module loading. 3. If state is false, return unused. Assert. State 1. Set state to state 1. If state equals 0, then assert state to false. B for each cyclic module record loaded of state. Do. if loaded as new, set loaded to unlinked. C perform. Call. State. Undefined. Return unused. 6. 2. 1. 5. 1. To continue module loading. State. Module completion. The abstract operation continue module loading takes arguments state, a graph loading state record, and module completion, either a normal completion containing a module record or a throw completion, and returns unused. It is used to re-enter the loading process after a call to host load imported module. It performs the following steps when called. If state is false, return unused. If a module completion is a normal completion, then perform in a module loading. State. Module completion. Else assert state to false. B perform. Call. State. Undefined. Module completion. Return unused. 6. 2. 1. 5. To link. The link concrete method of a cyclic module record module takes no arguments and